We need more conversations like this. This is good.
Yep. Shows the status of globe these days. Quiet. Nobody can talk about it anymore.
Man. Maybe they're bored.
Yeah, they should be, because they got nothing left. They tried and tried and tried, and we just sit here and knock them down, pulling strikes all day long.
You do that.
Easy. Anything you say that's globe proof, we knock it just knock it right out of the ballpark. That's no good.
I haven't seen that or heard it.
Oh, well, you haven't been listening.
Oh, okay. Well, the globe is in the claim. Flat Earth is the claim.
How is flat Earth a claim?
Because it goes against the consensus. So you have the burden. Yeah, the globe doesn't have to prove anything.
So everybody says
Northern Hemisphere. Different constellations.
Everybody thinks there's unicorns in their garage. I have to go along with it.
Well, if you were talking about unicorns, that'd be different, but that's not what we're talking about.
Different? Why is it different? If everybody thinks Santa Claus, if kids 6 and under think Santa Claus is real, does that make Santa Claus real?
I don't know. If you could show the Santa Claus is real, that'd be different.
No. You don't know if Santa Claus is real or not. You might have something wrong with you, dude.
Somebody else might think Santa Claus is real, so what do you do with that person?
Look at them like they're fucking nuts. Ask them if they're okay.
What do you with a person who thinks Santa Claus is real?
Yeah, it's called the globe.
You fucking for real, man?
Yeah, they believe the Santa globe is real. Globers believe the Santa Claus globe is real, and we're trying to convince these kids Grandma and Grandpa lied.
Raiden said that he believes in Santa Claus still. He's not sure if he's real or not. Yes, you did.
I said I believe in Santa Claus. When did I say that?
You said you're not sure.
No, I was just going along with you. You're talking about everything but the Earth. So unicorns and Santa Claus.
The Earth is a unicorn.
Irrelevant stuff, you know?
Right. The globe unicorn. It's irrelevant, right?
I was just making the point to him that the globe isn't a claim.
The globe is a unicorn. We know. You don't have to make that point to us.
How is a globe not a claim?
Because it's the consensus. That's why flat Earth is the claim.
What does that mean by it's a consensus? I don't understand.
Don't know what that means?
No.
Okay, well, I'll explain to you one time. The scientific consensus
No, that's wrong. There's no scientific papers that measured the Earth to be a ball.
You can read about it. Use Google as your friend.
I'm telling you, there's no papers that say Earth is a ball.
Okay, who told you that?
Dude, you're the one who said it's there. I said, no, you need to provide it.
Show me 3 that says the Earth is flat, and I'll turn into a flat earther immediately.
That's not how this works. You made the claim. Provide your proof.
I don't need to provide anything to you. What do you mean? Look at the satellite image.
So you jumped to space.
Debunk it.
Wow. So you got nothing
Yeah,
left.
debunk it.
You got
debunk
nothing
it.
left. I jumped. Yeah, airplanes take the pictures.
No, airplanes aren't satellites. What do you mean?
I told you how you're getting your pictures.
Read about it. What are you asking me for? You know how to read, right? Or are you illiterate?
Nigger. Has anyone got a premise conclusion for the flat Earth hypothesis? That's what I thought.
If most of the known surface of the Earth is water, and water at rest seeks level, then the Earth is flat. There's your
I don't know. What makes you think it seeks rest? When have you ever seen water rest?
No, I said when water is at rest, it seeks.
When is water at rest?
You know,
In my
in
cup.
a contained environment that has no dynamic.
What, like the ocean? You saying the ocean is a contained environment?
No, yeah. Well, I would say that water needs to be contained. Yes, in every scenario, it has to be contained.
Is the ocean contained water?
I would say that the land contains the water.
And would you say the ocean is contained within that land?
Yeah, lower than it.
Yes.
Lower than the land, not higher. No ball.
Yeah, but I don't ever see the ocean at rest.
I don't ever see the ocean.
People have thought the tides. People have thought the tides for millennia.
Do you really think this is a good
ocean has never gone to rest? The white horses that represent the sea foam bouncing off the rock
listen?
have never laid
do you
rest.
really think? listen, Flippy Flop.
Nightly,
You really?
the waves lay siege.
Are you not listening? Are you going to listen? Are you really thinking that this is a good line of argumentation against what I said?
Yeah, because you're saying at rest, and I'm like, bro, there is no.
Just because of hydrostatic equilibrium. So we can say for sure that water at rest will seek level on its surface. You agree with that?
Even in lakes and rivers, you see water moving. It moves.
So
no, there is a state.
If water
there is a state at which there is. No, just one sec.
Just look across the surface, my friend.
Listen, dude, in the field of hydrostatics, there is a term that they use for when a liquid is at rest. They understand that due to the molecular theory,
fools and they're idiots,
that there is movement within the molecules. They understand that, but for all intents and purposes, it looks to us, the surface, as if it is still. They call it at rest.
You have given me no good reason to believe that water is ever at rest. Whenever I look at the water in my cup, I see it moving.
You're just being pedantic. It's being a pedantic fuckwit. That's all you're being.
Present movement.
You're not presenting a good argument to what I said. I gave you a
being more difficult than you have to be.
You said water is flat at rest.
You're intentionally being a fucking difficult little child.
In fact, when I fill up my cup, I actually see the water act like a dome over the shape of the water. It's not a flat surface.
Hey, buddy, maybe you should put the Adderall drip in.
Do you want me to show you a picture of it making a dome over the surface of the cup?
You're talking
I can send you a photo of it.
Oh yeah, you. Let me just let you get it all out, buddy. You go ahead and say everything you need to say.
Despite its container being absent from its presence, the water do not floweth over the rim of the cup. It maintains its position in domes like a present shelter.
Add a bit more, dude. Add a bit fucking more. See what happens.
Do you not understand?
You don't. Think you're gonna come in here with some sort of fucking gotcha, and you've got nothing, dude. Nothing. You've got meniscus on the top of a cup. Holy shit, Earth must be a globe. Fucking idiot.
Water at rest is not flat, Brahim. I see it move even in this, and even when it is doming like it is, it's still moving.
You said you've never seen water at rest.
Bro, it's not at rest. It's still moving.
How would you know then?
Because it's still moving. You can see if you put like a particle, like for example, if you put sugar in there, you'll see the sugar get moved around by the water.
That's cool.
As the hotter water goes up and the cooler water goes down, you actually see, the movement.
That's cool. Did you have a point?
Yes.
Which is?
I made the point.
Nope. You didn't make one.
Water is not at rest and it is not flat.
Not at rest and not flat.
Yes. And you are idiot.
Is that an argument?
That's a claim. I'll back my reputation on that claim.
Well, it's kind of a red herring to the current claim.
It's fine. This is a new argument. I felt that we just concluded the previous one.
No, we didn't.
Oh, did we not?
Didn't really argue anything.
It was pretty conclusive.
Yeah, you just said it's not.
It sounded like we agreed. It sounded like we agreed. Really. It's not at rest, and it's also not flat.
You're just imagining things. You said it's not at rest. It doesn't have to be.
And it's not flat.
Well, it's seeking level. Is it not?
It's seeking level. What does that mean?
Yeah, so if it were perfectly still,
are you a Freemason? Are we trying to meet upon the level? Is that what you're saying?
No.
Do you want to part upon the square, or are you just... What is this?
This is you just saying stupid shit to avoid the point.
Cool, bro. Some wear collars, other wears chains, but no penny makes a dollar.
So you should say that it's seeking a curve if you believe that it's a globe that this water is conforming to, not that it's just not at rest. Because you could say the same thing either way. Oh, there's waves, bro.
Yeah, bro, there is waves. There literally is waves.
It was a non sequitur.
It's actually such a great point that you brought up that there are waves, because that's not flat. That's not
like
flat.
stacking water.
So like when you come over here and you say the Earth is flat, bro, I'm like, bro,
I know it's flat because
that contradicts my experience, bro. That contradicts my direct experience.
You cannot stack water. If you shut the fuck up,
so you're out here talking like the Earth is flat
water above the dirt,
speak over the fucking top of everyone. Right. So for your benefit, I've posted a citation in the side chat from a physics textbook, Henry and Katz. Henry Samat and Robert Katz, physics textbook, chapter 8, page 152. The points at the same horizontal level surface within a body of liquid are at the same pressure as long as the liquid is at rest. In fact, this statement is often taken as the definition of a level surface. I want you to go now and eat shit. An idiot.
Can you guys kiss already?
Yeah, because on a globe, water at rest would be curved. So what if I came back and said, water's never at rest? You'd be like, well, you're retarded. So you're just showing you won't engage with the point, which is all I need to hear.
That's pretty cool. I came in the
just a deflection away from Flatsy's main point.
Yeah, he's just obviously a troll. Yeah.
So, why do you guys think people are retarded?
It's not flat. There's hills. It doesn't measure flat.
Hey, is this a place to present a globe Earth proof argument?
That'd be awesome. I appreciate it.
All right, I'll do my best. I'll probably fail, and you guys will slap me down.
All right.
I want to see stacking water.
All right, I want to start. I want to come at this from the field of engineering, surveying for engineering, civil engineering. So, land surveyors, I've discovered through a book called Surveying for Engineering.
But not the land? I just want to make sure you're not physically doing or touching any water. You're just reading books. Go ahead, brother.
Yeah, I heard the gentleman earlier referring to a physics book for definitions and for information, referring to Surveying for Engineering by Uren and Price. This book's been around for like 45 years. It's basically a high level. It's like we could call it like a Bible for surveying and engineering.
Does it just show us where water can be higher than my mud puddle or your aquarium, or where you don't need any aquarium walls to make a 10-foot high mud puddle water aquarium?
Yo, D-Muck, you gotta chill a little bit. He's trying to chill, bro.
Yeah, cool story.
Okay, so here's the argument. It goes like this. The geological surveyors for engineering, they perform their surveys effectively. This is my first premise. When they do their work, which includes a bunch of math, they're successful.
Yeah, but do they touch water?
Being that they don't fail in their projects, the math is correct. That's
2 plus 2 is 4. I didn't have to touch anything. It doesn't make sense. Where did they touch grass or water?
All right. So if we accept that they are successful in their leveling efforts.
Making shit up? No.
I'm sorry. Am I just going to be heckled while I'm trying to make the argument for you to examine, or are you?
Yeah, I think this guy is triggered.
Okay, so premise 1, they are successful in their leveling attempts, right? Premise 2 is that in the work that they do, they are including a radius value for the Earth, which is 6,371 kilometers. Their math depends on the radius value, and it does work. If the radius value was wrong, their projects would fail. And since their projects succeed, and they're able to do this in every direction, meaning a radius value is being able to be applied in every direction successfully, the only way to have a radius in every direction is for it to be a sphere. Therefore, the Earth must be a sphere, or else their projects would fail.
So I heard a claim in the form of an argument. So there's a lot of nuance there that's going to need to be addressed.
Well, I stated 2 premises, which premises are claims in themselves, but the conclusion.
Are you saying that they go out to achieve a certain? They go out to achieve a certain goal, right?
Yes.
Practically do something in reality. What is that they're going to? What are they aiming to achieve?
Leveling and gauging distances.
Elevations?
I'm sorry, you were cut off there. What'd you say?
The elevations?
Yep, elevations. Yeah, these are some of the things that they do, right?
Okay, that's what they're going out to do.
Right. I guess leveling. Yeah, you could say that it's right.
But leveling, as in a horizontal plane of reference, right?
Correct. A constant elevation. Yeah, that would be level.
So, and then you said that they apply a value, a radius value, 3,959 miles. What form do they apply it to that horizontal plane of reference?
Right. So they apply a curve correction formula, which is CC meaning curve correction equals.
Why would you do that? Why would you do that?
To account for the curve.
I haven't measured it yet. This is supposed to be measuring it, not presuming that it's already there and using values which represent that curve, which you haven't yet measured and demonstrated to exist in the first instance.
Well, the thing is, even if they had made the number up and guessed it, or if an angel came and told it to them in a dream, or if it was given to them in a fortune cookie, if they applied this number into this math and it was the wrong number, their project would fail. But since the projects don't fail, it must be the right number. You see?
So they know they haven't failed.
Because they come up with the correct distances and their buildings end up.
How do they know it's correct? If that's the method by which that they're using and saying that they're not incorrect, they're claiming to be correct using that methodology, right? Then how do they know? By what other standard was it compared?
Well, because let's say if they're 15 kilometers from a mountain peak, and then they
know they're 15 kilometers from a mountain peak.
Well, they can pace it out
using the method that you just described.
Right. Because they can pace it out afterward and confirm that the measurements correspond with reality.
Pace it out how? How do they? What do you mean pace it out?
Well, they could, roll a wheel and count how many revolutions. They could pull out a tape measure. They could in
That's how they get the distance to the mountain in the first instance.
No, they can calculate using the theodolite and taking visual reference points, then applying the curve correction formula in part of the equation of measuring the distance, and then they can confirm that they got it right, and it corresponds to reality.
So they do it with their guess first, and then take a measuring wheel and walk to the destination target.
Well, no, that's a mischaracterization. It's not a guess. I'm saying even if it was a guess, it just happens that they ended up with the right number for the radius value.
It would be a guess.
Yeah, even if it was a guess,
you don't know.
Even if it was a guess, the point is that
it is a guess.
But the point is
a guess.
All right.
However, where did they get that radius? Where did they get that radius value from to be able to apply it in the first
That's actually irrelevant to my claim.
No, it's not. If it's the foundation of this claim,
it's not relevant.
You're going to have to verify that that's correct.
No, it's not relevant. Who or where?
It is relevant because if that part's not true, then anything derived from it can't be true either. Like if that part is incorrect or invalidated, then I can't determine the validity or the veracity of anything you're claiming is derived from it.
That's false.
Saying that this radius value is fundamental to this.
If they received the number from a con man pedophile, it wouldn't matter. If it's the right number, it's the right number.
Dude, I can't entertain any claim that is based off this value until we've established that this value is true.
But the proof of its trueness is in the result that it corresponds with reality.
Well, that would be affirming the consequent formological fallacy.
No, wrong.
Yes.
No, it's right. 4 + 4 is 4.
Also a pragmatic fallacy.
And a pragmatic fallacy.
4 + 4 is wrong. 4 + 4 is 8.
Can you define for me how it turns out to be a fallacy?
4 + 4 is 8.
Where did they get
here?
What are you guys talking about?
By asking me, you're performing
radius
a genetic fallacy.
Where did they get the radius value?
You're performing a genetic fallacy. You're saying that you're saying that the origin of the number determines whether or not it's true.
Oh my!
I want to evaluate the process by which that value was derived.
From where? Fallacy. Genetic fallacy.
It's not a genetic fallacy.
No, it's not a genetic fallacy because I want to determine the veracity of the methods used in order to get that value to see if it stands to reason or has any sort of flaw.
No, but this is I told you that this is the recipe for making cookies, you follow the recipe, you get cookies, then it is a recipe for making cookies. It doesn't matter where that recipe came from.
What's the recipe to measure the earth?
I'm not telling you. That's not what I'm telling you. I'm telling you.
You're not measuring earth. Then go home. That's what you need to do. That's the whole point here.
All right. I'm telling you the recipe for curve correction.
You're telling us math recipes to do math.
In measuring distance, I'm telling you the curve correction.
So far, you've made claims. You haven't actually provided anything like that shows that anybody actually even did.
The proof that the Earth is round is my girlfriend has a fat ass.
Well, actually, I did. I started
immature little shit. Piss off.
I started with the proof that this is real. This is what engineers do in the field. This is in their textbooks. This is the formula that they use. They apply it in reality, corresponds with reality because we get the results that we're looking for.
You're claiming that's the case, right? I said that there were still nuances that need to be addressed. Exactly what did they do? Where were they? What instrumentation did they use? How did they do all this? At what times a day was it performed? What else did they account for? There's a lot of other things involved, right? So you just made this claim that this thing was done, that someone went out to achieve something and they could not have achieved it without this precious radius value number, which you refused to discuss the origins of.
So you're saying, your argument is, I don't believe you that they do this?
No, the argument is that you don't have no proof of that radius value. That's the argument.
I just presented proof of the radius value.
What is it?
That when we apply it as a curve into the curve correction formula, it corresponds with reality.
So you don't have no actual proof. You don't have an observation.
That is actual proof. That is.
So you didn't measure it then, right?
That's not the only way to get proof.
So it's no measurement, no observation.
This is a test of it, and the test shows true.
Test of what? We literally just told you.
This is a test of the radius value.
Great. It's affirming the consequence then.
See, the thing is, if the number was not correct, their projects would fail.
Yeah. So
since the projects don't fail, the number is correct.
So basically, you seeing something.
But I wasn't affirming the consequence. Actually, you called that one. You said that if the number is correct, the project doesn't fail. The project doesn't fail, so the number is correct.
Affirming the consequence.
Yes.
Yeah. Well, regular Joe is right. That'd be an affirming the consequence fails.
Well, no, it's the law of excluded middle. It either is correct or is not. There's no other option.
No, it's affirming.
And if it's not incorrect, then it is what?
No,
it doesn't matter. The way you structured it was invalid. Circular reasoning.
It's not circular reasoning.
It's
law of excluded. It's law of excluded middle. There's no other option. This is not a false binary. It's either incorrect or it's correct. It can't be both.
already assuming that you are correct. You're affirming the consequence.
No, I'm proving that I'm correct.
No, you're not proving anything. You're assuming that
you can deny
correct.
That, but I actually I've set up a logical syllogism. And it's totally logically sound. It's totally sound.
Explaining it. You just basically saying that to yourself. Now it's just confirmation bias at this point.
But no, you already
came up with right. You already came up with a radius. You already came up with a radius value without confirming it to be true. This is not a measurement. This is just a calculation. And you're saying that somehow you're using it as a correction for actual measurements, even though the calculation isn't the actual method because you haven't measured it. You just put in this calculation in there, and then you say, oh, if I see this in reality, therefore it's true. It's a classic affirming the consequence fallacy.
At least show some fucking documentation and point us to the exact page and paragraph or whatever where the measurement was taken and they applied whatever formula you think they needed to correct for, right, in order to get a correct distance. Show us that.
I can do that.
Okay, so you're going to show us where you measured the curvature, right?
That's not what he said. That's
the documentation should be identifying the curvature that you're getting this calculation from. Or else you just saying you just putting it in there. That would just be an assumption.
Well, he asked me for one thing, and then you asked for another.
Oh, so you want to run away from affirming the consequence fallacy that you in, huh?
That's not what it is. You're just wrong about that.
No, I'm actually right about that. You just explained what it was. If I assume P is true, therefore I would see Q. I see Q, so therefore P is true, affirming the consequence.
That's not my argument. That's not how it's structured.
That's literally what you just said, bro. No, you said, based upon my calculation, I assume it. Based upon the calculation that I'm already assuming to be true, if I apply it in reality, just basically putting this calculation along with a measurement, and if I see that, therefore, my premise is true, affirming the consequence in logical fallacy, circular reasoning.
Do you understand what a law of excluded middle means?
Yeah, it's affirming the consequence, which you explained, sir. I just told you what it was.
No, I'm asking you, do you know what, can you tell me what law of excluded middle is? I don't have to know what you know. I just know what you just did. No, you don't know what I just did. You're misrepresenting.
I just told you what you just did.
No, I'm not doing the P equals
trying to explain it another way. I just told you what you just did.
No, you're just coping, actually, because you're just not coping. You're sort of straw manning what I'm doing, and it's a cope.
So I'm straw manning what you actually just said to us.
Yes, correct.
Great. So show me where the straw man is at.
You're saying that I'm saying if P, then Q, Q, then P. And that's not what I'm doing.
Okay, that's just a formula of affirming the consequence fallacy. Explain.
Right. What I'm doing is a different formula.
Okay, based upon what you told us, you said that you're putting a radius value, something that you already assumed to be true. It's not a measurement. It's not nothing that you observe, right? It's just something that you're going to apply, right, with a method of a measurement. So it's just a calculation. And if you apply this calculation based upon a prediction that you see into the real world, therefore that calculation is true. That is a classic affirming the consequence fallacy. because you already begging the question that the radius value is true before you apply it to anything like a measurement, which is not a measurement, right? It's just a calculation for a correction for an actual measurement.
The difference between what I'm doing and what you're saying I'm doing is this. In the affirming the consequent fallacy, it's structured that if this, then that. Well, we have that, therefore we must have this. Mine is different because in the affirming the consequent fallacy, there are other possibilities for what could explain Q. That's the problem. If P, then Q, Q, then P.
It's just illogical.
No, I'm right.
No, it's not. You're wrong.
No, the reason why the affirming the consequent fallacy exists
is affirming the consequent fallacy because it's indirect. You haven't proven P to be true yet. You only using P in circular reasoning. That's the purpose of affirming the consequence fallacy. Not it could be something else. What are you talking about?
Exactly.
In my formula,
it's circular reasoning, Big Tech. Stop trying to run away from it.
It's not
circular reasoning.
I mean, you can keep asserting
read the
that.
Philosophy backing it up.
You can assert that all day, but
it's circular reasoning. You don't have no proof. You haven't validated your claim of curvature, sir. You already assuming it to be true. It's just a calculation. It's just a concept at this point. But you assume that it's true, so therefore you're going to put it with a measurement, right? Which is actually a correction. It's not a measurement. You're just calculating a correction. Therefore, it works within your paradigm. Therefore, this curvature must be true. The thing that you already begging the question of. Classic affirming the consequence. Is if I assume P, this calculation of a radius value to be true, then I would see it within this. Then I could correct for this measurement, and I would assume that it would be true in reality. I corrected. This model actually works according to this calculation. Therefore, P must be true. Classic affirming the consequence fallacy.
My argument is
circular reasoning.
Well, you gave an affirming the consequence, and that's what the logical form you gave is, and that's always invalid.
The form of the argument is this: if this equation works, then the Earth must be a sphere, and there's no other thing it can be.
Affirming the consequence.
Yeah,
if
and
this
the
formula
pragmatic
works,
fallacy.
it must be a sphere.
Yeah.
You realize that you're.
It seems like you reworded it this time, because the other time when you're talking to regular Joe, you said if it's a sphere, yeah, then we get this equation. We have the equation, therefore sphere.
Right, because if you're going to word it that way, then we're going to go back to our original question that we're going to have for you. When did you validate this calculation or this radius value?
Radius, yeah, yep.
It's validated through testing.
Great.
It had to be circular reasoning again.
When we
right to use the result in order to confirm your if is circular reasoning, unless you know that your P is true in the first instance, and then it's valid. Then it's a valid modus ponens.
You keep trying to run away from that part. It should be very easy if you got a measurement of curvature, or you can validate it in any way. It's just basically you identifying it to be true.
Also, the reason why it's not sound logic that because first of all, you're using logical fallacies, but your way of thinking about it could be attributed to something that would be in optics rather than actual Earth curve. So you need to be able to attribute every single thing that is, because the only way that you're able to do this is with optics. So that should be a factor. Don't you agree?
The only way you're able to do this is with optics, so it should be a factor.
Right, with the surveying. Isn't that what you guys are still talking about?
Yes.
Yeah, they use line of sight measurements, right?
Yes.
Okay.
Right.
So you're using optics to get these measurements. So don't you think that it's wise to make sure that those optics are accounted for? This is why what you're saying can be attributed to something, let's say, like the Rayleigh criterion of optics with the angular resolution and the angle of incidence. Like those things, actually, that's what your supposed Earth curve is anyways. It matches perfectly, and it's not accounted for when you're talking about optics and using line of sight measurements.
So is your, are you wagering that these surveyors who are succeeding in their projects are not taking into account?
That's just your claim that they're succeeding.
They're
using flat Earth measurements. I don't understand
you
that.
You still haven't provided any documentation or any sort of form of publication which is showing that they did succeed. Why don't you start there?
Wait, I need to prove to you that I need to prove to you first that civil engineers are successful in their
that these actions were performed. Yes, like show something that would lend credence to this story you're telling us.
Yeah, they measure curvature. That should be pretty easy.
What if I show you a structure that was built that's 4 kilometers long?
Oh my fucking God.
It's designed to be perfectly flat for a scientific experiment that's taking place that requires it to be flat. And in the construction of this structure, the surveyors did apply this.
So pretty much everything was shown.
With that, right? Show us the documentation detailing what you originally fucking stated.
Or is this a basis assertion at this point? Yeah, you saying, "Oh, well, I'm gonna show you something else besides what you're supposed to be claiming, which should be your main premise."
So do I get it right that you doubt that this happens and exists?
No, we want you to show us.
Okay, if you don't doubt it, then what's the purpose of me having to do that homework for you? If it's not in doubt, then what's the purpose of this inquiry?
Well, how do you know about it? Did you just hear about it on the grapevine, standing at the fucking water cooler at work, or what? Source.
I mean, you're getting really upset.
Hide your sources, dude.
Hey, what's with this whining type of talking you're doing to me, mate? Like, hey, just relax. I'm asking you a question. If it's in doubt, then it's worth us doing some research.
Provide your sources.
I'm asking
for this information that you have obviously gained from somewhere. We're interested in where it came from.
And antagonistically demanding this of me. Is it in
because you're being a little bitch?
Oh, okay. So, all right. Always nice talking to the flat earthers. They get triggered. Everything they don't like is fake.
Poison in the well. Here we go.
And then they
as always. Here it comes.
Yeah. Moon landing was fake. You're correct. ISS is fake. All that shit's fake. You're right.
There we go. We got it.
Yep.
So when they're blown out with
like
an argument,
Globers always do. Whenever we ask them about curvature, this is what happens.
Well, I mean, they get upset.
What happens.
They start yelling at you and calling you a bitch, and then they call things into question that are not in question.
Even though
everything I don't like is fake.
Everything we ask him to provide evidence, and here he go.
Well, I mean, you could ask.
All we ask you to do is just
you could also give me a reason why you're asking. I think that's fair.
I mean, the only thing we ask you to do is
because we want to analyze the authenticity and veracity of the information that you're supplying. We want to know where it came from and who's claiming to have done all this shit. Maybe we might want to go out and do the same thing ourselves so that we can then know too. Like you seem to know all about it.
So you just don't know about civil engineering.
You making a claim about it, so you don't want to present it.
Yeah, I think you're playing ignorant as a form of coping and dodging.
No, we just playing.
That's what I'm suspecting. I'm suspecting that what you're doing is leading me with a red herring of like, oh, prove it to me, big tit. Oh, I don't believe you. And I think we all know that it's true.
So you want us to just trust me, bro, because you say it so, or whatever? That's what you want.
Well, just it's. I'm literally asking you.
I mean, you're the one that brought it up.
True. You won't bite the bullet and say, yes, I doubt that that's true. Nobody's saying that to me, and I keep asking.
We don't know anything. Is your claim?
Oh, we don't know anything is your claim. That's what you're saying? We don't know anything?
Yeah, we don't know what you're talking about.
So I'm talking to people who don't know anything. It's a little difficult.
We don't know what you're talking about. It's very specific.
But do you doubt that civil engineers are practicing this and having success? Yes or no?
Success.
Yes, because you won't share where you got the information
from. So yes, you doubt it.
Yeah, I doubt you. Your knowledge on this.
I'm really trying to figure out what are you saying engineers is doing? Are you talking about engineers or surveyors?
It's surveying for engineering. The engineers are doing giant projects that require level and distance.
You said it.
And the surveyors are serving this need.
Level. Yep. They just need a level. They use a theodolite, shoot a level line, boom. Not a curved line. You got it.
Wrong. In fact,
that's what
do you know what level means to a surveyor? Do you want the definition? Because I got it.
Not a curved line.
You know what level mean, period?
It literally is a curved line, and if you don't mind, I'll read the definition to you right from this book.
Okay, so where do they measure this curved line?
In terms of level line and horizontal line.
Where did they measure the curved line?
I'm going to tell you right now.
No, you reading
these words are frequently used in leveling,
sir,
and they need to be carefully defined.
Definition. Where did they measure this curved line?
Sir, I'm trying to share with you the definition.
Right. No. We already know what you're about to say. We already know that you're going to say level means curve. You know we disagree with that.
Why would I say that?
We don't have to have an argument.
Why would I say that? Why would I say that?
You know we disagree with that. Because
you disagree with the surveyors who are doing these projects for engineers.
Okay, you know, I disagree with you, sir. You haven't shown. Great. You haven't shown this curvature yet. You haven't shown this radius value yet. I'm trying to get you to show it. You rather just read what people say.
I'm trying to define the words that we're using so we can have.
Great. Go ahead and define it, but you will have to validate it by showing it, right?
Wouldn't that be optics?
Oh, it would be optics. So no Earth curve then.
Oh, so are you setting up a impossible scenario? Since optics are no Earth question, curve then, right? And then you asked me to show you something, and then we're going to say that it's an optical.
Yes, Earth curve is impossible. It's an impossible scenario. That's correct.
I don't know why you keep trying to use that tactic. The burden is upon you.
Fallacy.
There's no impossible. There is no impossible measure here. All you have to do is just validate a claim. Simple. If you claiming that level, right? And it's example that you about to give us is actually the surface curving based upon whatever you want to say. You can't say, oh, we're optics all of a sudden, because that means there's no physical Earth curve then. Still not showing it.
I mean, we called into question the word level, and I'm trying to define the word.
I haven't called into question that. You just brought that up.
I said we.
Yeah. So I gave you that. So now you would have to show it, right?
Show it?
Yeah.
You said
you already agreed with me.
You want me to show you a picture of a definition?
No.
It's
It's not a definition. We moving past that point. I'm gonna give you your little definition in your little fantasy world. Right?
How would you like me to show it?
I'm gonna give you your little definition.
You already agreed to level being horizontal.
Right.
That's correct. You already said it was horizontal.
And what does horizontal mean?
Not. There's no horizontals on a ball.
What is horizontal?
No slope. Zero slope.
That's not what horizontal means.
Straight line, perpendicular to vertical, no slope.
Right. Horizontal is not a straight line. Then.
What does vertical mean?
So vertical wouldn't be
perpendicular to horizontal,
and that ain't gonna measure.
Oh, right. Now we're into circular definitions.
Are we?
If horizontal is perpendicular to vertical,
it's kind of funny that we answering the question.
Sorry, I forgot for a second. Horizontal, parallel to the plane of the horizon. That's also a definition you can use, and vertical at right angles to horizontal, which is parallel to the plane of horizon.
And there's no parallel.
It's kind of funny we answering these questions like,
wait a minute,
very easily.
Use the
giving
word.
Him answers and he don't like them.
Use the same word.
We giving him answers and he don't like them. But yet when we ask him to show us this curvature, he's
you
not
said
doing
horizontal is perpendicular to horizon, which is the same
those are different words, dude.
Horizon and horizontal.
You think that they're the same word? You think horizon and horizontal are interchangeable synonyms? People just use them interchangeably.
It's like I'm going to draw.
It's a different form. That's like saying flat is parallel to flatness.
That's literally the definition of horizontal, dude. Parallel to plane of horizon.
Well, let me offer you another one. This actually comes from the directives given to the surveyors who are trying to
parallels on a ball, dude.
I mean, you can keep saying.
Wait, is he actually going to provide something from somewhere?
I keep trying
a source,
to, and I keep
amazing.
interrupted. I mean, I've spoken over every time that I try to offer to you.
It's kind of funny that you're not being. It's kind of funny.
It's almost like you don't want to hear the answer. That's going to
It's kind of funny that you're not.
It's almost like you're coping and running from the truth.
It's kind of funny that nobody's coping.
Everybody's going to keep on speaking so that I can't say the definition.
Yeah. No, we only speak whenever we ask you a question that basically shows us this Earth curve.
Post it in the chat. Sure, I'll do that. Can I also say it so that everybody can hear it?
Yes, you can also speak it out.
Okay with that?
It's taking so long.
Anybody object to me giving this definition?
We don't got to be angry with this guy. We don't got to be angry.
Not angry. I want to be able to read along.
All right. You want it in the side chat, right? In the VC chat, it's right there.
Yeah,
so the YouTube viewers can see it too.
Great. Do you see the image that I've posted of the definition? Everything's highlighted.
I thought you said you was going to read it.
You tell me when, because I've been trying to this whole time. I keep getting shut down. Just give me permission.
Okay, go ahead. I already basically.
The past couple of days, I've already debunked gravity, so we can get rid of your definition since it requires gravity now.
You don't believe in little g gravity?
Great. So he's changing it already. So you're not going to read it then, right?
I'm waiting for permission.
Why do you need permission, moron?
Because excuse me, sir, we don't need to resort to
you're demonstrating that you're a moron right now. How many people told you to go ahead and read it?
Well, and then everyone keeps speaking over me, so I want to have the floor.
No, because you're doing everything but reading it.
Okay, now I'm going to read it. Please don't interrupt.
Stop. Just read it.
A horizontal line is one which is normal to the direction of little g gravity, the vertical. At the particular point, such as P in the figure that I've showed you, a horizontal line or surface are therefore tangential to the level lines or surfaces at individual points.
Okay. So what's the tangent? What's the tangent line?
So then there's easily it should be easy to show that there's a tangent point, right?
Right.
That would be the intersection of the observer's line of sight with the surface of the Earth, that so-called level line, which is actually curved.
And that tangent line.
So that'd be the horizon. That'd be the geometric horizon. So all we have to do is post a black swan. That's easy.
And a tangent line is horizontal, right?
Horizontal to that point.
Horizontal to the point where
there is no such point.
Right, the horizontal to the point where the Earth is where the surface is supposed to be curving, correct?
The point where you're measuring vertical with gravity,
where the surface is
the plumb line at the point. If you put a plumb line at a point, if you take it perpendicular to that plumb line, now you have a horizontal.
But it is a line
with that
it's
point.
Not a point.
You are creating You are creating a line.
It says right here in your definition. It's a line. Now we
right there in my definition at the top.
You could go ahead and get.
And that's also why it's not a globe. There you go. Very simple.
Can I know your religion?
Yeah, I'm not religious.
No, not religious.
Okay. And others?
Maybe.
Some people may be Christian, some people may be Muslim, some people may be Gnostic. Who knows? Some people may be whatever. We may have Hare Krishnas. Doesn't really make a difference because that's someone's personal belief system.
No, it's a privacy for you. It's a private for you or for anyone.
What's that? Say that again.
It's private.
Private? No, we told you.
Okay.
Not everyone, like, so what people's religion is, right? That's personal to them, right? That's not how people know that the earth is not a globe. All right, no one in here is going to quote a Bible verse as evidence that the earth's not a globe.
Okay, I'm new in Discord, so I don't understand the system.
Yeah, we actually get rid of all religious texts and we go out and empirically verify reality, because it's what reality determines whether or not the texts were actually correct. Wouldn't you say that, Abo?
Like, who said that flat earth? Which religious book telling that?
I don't understand you, swallow.
So if you want to know that the text that you read, the religious text, like whether it's the Quran or the Bible, if you want to know that the textbook that those were written in are correct, you would go into the real world and verify that what those texts are saying, correct?
What is your religion first?
I don't have a religion.
Like, you have before or not?
Yeah, a long time ago, I used to go to church.
Yeah, like, you need to verify. Yeah, true. And what next? Go ahead.
What?
Hold up. What's your point? Like, what do you want to prove here? You should prove whether the text is correct or not.
Yeah, if you get told something about reality, right, and it should be okay to go and check to make sure that that's true. That's what we did, and it turns out that what we're told about the Earth is not true.
Like, who told that Earth is flat?
Swallow, you.
Yeah, so the Earth tells that it's flat because that's how it presents itself. But we were told that it's not flat. Okay, then when we went and tested the Earth, and it is actually flat, just like we experience.
And you want to say we must test our religions to check it's correct or not?
No, because that's faith, right? That's just faith. Okay, so that's got nothing to do with this topic. We're talking about testing the Earth that we're told is a certain size and shape. That has nothing to do with religion at all.
Okay.
We're talking about vision, we're talking about geometry, and we're talking about science. That's all we're talking about.
Okay. I will leave this voice because I will go to pray al-Maghrib. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.
All right, have a good day.
Wa alaikum salam, dude.
So, like, what we're gonna talk about? Like, why Earth is flat? I like, what the heck? We already know by the science.
No, we already know why it's flat.
What? Like, how do you know it's flat? Like,
because it's measured that way. It's measured that way. We already know why it's flat too.
Like how? Like, how you think that it's a flat?
It's measured that way.
Like,
it also it presents itself that way, and then we went out and tested the Earth. Okay, if the Earth is a globe, this might be shocking to you, but if the Earth is a globe, the water has to be curving.
Oh my!
No. Like,
yeah.
Wait.
Yeah. Did you hear what I said about the water?
It's this simple, dude. It's really this simple.
Yeah.
Like-
So what should the water be doing if the Earth's a globe? It should be curving over distance, right? Just try to focus. If the Earth is a globe, the water should be curving over distance. Right?
I'll make it simple. Gravity holds water on Earth. The Earth is a ball, therefore water should be curving.
Okay, but I had a different question. As you mentioned earlier,
Yeah, but you need
is
to acknowledge what we said, and then you can answer your question. So if the Earth is a globe, the surface of the water should be curving over distance.
What do you mean by curving? I'm not getting the curving word.
Yeah, like you know what the word curving means? Bending.
Oh yeah, I just searched. Okay.
Yeah.
You want to tell that?
Do you remember what I said? When I said that gravity holds water on the Earth, right? You agree that gravity's holding water down on the Earth? Ten verse.
Yeah, I agree.
Gravity holds water down, right? Gravity's holding the water down.
Yep.
And then the surface of the water all the way around the Earth should be curving to make a ball, right?
Yeah.
Okay. Go ahead, DJ.
Okay, so then when we go and calculate how much curve there should be over a certain distance, and then we test it, it's not curving.
It is curving. Like
no,
when
no.
you're.
Okay, did you test?
You're not letting me complete anything. Yeah, go ahead.
Well, you said it is curving, right? But okay, okay, go ahead. It is curving. Continue.
Yeah. Okay. So in my point of view, if the world is flat, then we will know, like we're not able to connect with one point to another point. We're gonna go to the unlimited, infinite places.
No. You need to stick with the curving water topic.
No. Try to understand what I'm trying to say. So there will be an age where you will find the end of the world, right?
No.
So there's no end point of the world. That's why you are saying no. Like when you're talking, I was silent, right? You should respect me as well. Like
yeah, but you're strawmanning. You're just making up things about flat Earth that
you cannot say that. Like I can share my point of view.
Yeah, you did. You already said that. You already said you would fall off the edge of the world, and no, you can't do that.
Have you researched about the universe? They say if you go in one direction.
Can I tell what I'm trying to say, or like you guys?
Listen. I've listened to what you've said. If you research the universe, they say that if you go in one direction long enough, you'll appear the other side of where you started. So they already say stuff like that in your model.
Let's try to keep it very simple on the surface of the water curving, right? If the Earth's a globe, the surface of the water must be curving.
It is curving. Right? If you look.
Okay, so you claim it is curving. Have you tested the surface of the water, or does anybody that you know of have they tested the surface of the water?
Can I tell something?
No, you have to answer the question that I just asked you. Because you said the water's curving, right? I told you that we've tested the surface of the water. Okay, so you said that no, it's curving, right? So have you tested it, or has anyone that you know of tested it?
Well, if you look from the moon, the world.
We can't go to the moon. You can't go to the moon.
No, you have to let me complete what I'm saying. If I'm saying something, you just jump into it and you just destroy my whole conversation. So what's the point of
talking? But you said if we go to the moon, you can't go to the moon. You can't go to the moon, bro.
I'm unmuting myself. It doesn't make sense, right?
Yeah. This is the problem, right? So if you say something that's stupid, like if you go to the moon, which you can never do.
I think you are stupid. So what's the point?
This is the problem. Have you been to the moon? Can you go to the moon to check? Can you go to the moon to check?
Anyone can go to the moon to check if you have money.
Anyone can go to the moon, and you wonder why I say what you said stupid. Anyone can go to the moon to check, can they?
Wow.
Wow, bro.
I don't think you're smart enough. You're just trying to,
Really, you just said anyone can go to the moon to check.
You're doing here. I don't think you are capable enough to know this kind of shits.
Really?
You'll never know why world is round. You'll never know.
So do you think anyone can go to the moon? Do you?
Anyone can go to the moon if they are from NASA.
If they are from NASA. Well, how come NASA was interviewed recently, and they said that they destroyed the technology to go back to the moon, and that it would be a painful process to build it back again.
Oh, you're trying to make.
That's what NASA said. That's what NASA said.
I don't care what NASA say. I don't care what NASA say.
Well, you're appealing to NASA, and I'm telling you what NASA said.
Now you don't care
they said they can't go back to the moon.
That's what they said. Oh, really? So what about the SpaceX? What they so told? They also destroyed their...
Oh, so now SpaceX... When did SpaceX go to the moon? When did SpaceX... Not India. When did SpaceX go to the moon? When did SpaceX go to the moon?
That sounds so good. Bro, you're so intelligent,
You're starting to lose it, aren't you? So you said NASA, and then I told you that NASA said that they can't go back to the moon because they destroyed the technology.
Oh, bro,
which is kind of crazy. So then you said, yeah, really? Do you want to see the interview?
Who cares? If you have money, you can build another thing.
Okay, well, it goes against what you said. Right? You said you just have to work for NASA and you can go to the moon.
You care about NASA. You care about...
No, you do. You brought it up. You brought up NASA. I don't care about NASA. I care about the surface of the water.
You try to understand the whole conversation. You just stop me.
You said anyone can go to the moon. That was a kind of silly thing to say, wasn't it?
Okay, no one go to the moon, no one go to the Mars, no one go to the...
Is this guy just going to whine the whole time, bro? Don't whine. Let's talk about the Earth. Is the Earth measured to be curved or not?
So why he's not letting me complete?
Why are you whining? Let's talk about the Earth.
So he's very intelligent.
You can't talk and cry at the same time. It's not coming across.
You can talk. You can tell us. You can tell us.
Okay, no problem. Okay. So the Earth is measured to be flat. That's it. There's no curvature. There's none ever been found by anyone. It's a big concept. It's a lie. You were told a lie. You believed a lie. I'm sorry to hear. You have to hear it this way. But that's what happened.
Go to a university, then talk.
I know. The universities will also tell you that the Earth is indeed measured flat because they don't have any curvature measurements either.
I think you failed in your university. That's why you...
Okay, all right. So which university is going to show me Earth curve measurements? Can you tell me which one of them?
Anything. I understand your philosophy. So, yeah,
No, it's not a philosophy. This is about measurements. This is about geometry. Can you tell me who has measured any Earth curve?
Scientists.
So now you don't care. So can you tell me anyone who has measured the curvature of the Earth, please?
I tried to explain something, but someone interrupted me.
Yeah, name the scientist. Name the scientist. Name the experiment. Name the measurement. Name the day that it was done.
And talk about the scientist's personal stuff. Oh, I don't know.
Oh, it's a magical scientist, right? You just believe it.
Like when I start talking, that guy stopped at NASA, right? He didn't
You're whining, man. Like, let's talk about here on Earth. We're not going to go to some imaginary place where you believe somebody went.
I want to learn from you guys what you know. Let's see.
Yeah, that's what we were trying to explain to you, how things are measured here on Earth. And you immediately said, oh, we got to go to the moon. We go to the moon, we can see the Earth as a ball. But you can't go to the moon. You're never going to go to the moon. The selection process to get into the NASA program to become an astronaut is beyond absurd. You'll never get in there.
Who said it? Who said it?
Who says that? Okay, walk me through the process. Walk me through the process. Walk me through the process of becoming an astronaut.
Guys, stop crying, bro. We're gonna have to start muting you if you keep crying while you're talking. It's very annoying. Right? Just if you said you're here to learn, then you should shut up.
I'm not here to learn. I want to understand your philosophy.
Okay, well you said you're here to learn.
So I'm gonna let you know what the selection process is, and then I'm gonna give it back over to DJ to explain the curvature of the Earth. So the selection process for NASA: first, you have to be selected to become a pilot, right, in the Air Force or in the Navy. Once that occurs, from there you have to be selected to a top pilot program because you have to be chosen to be one of the best pilots in the Navy or the Air Force. From that, you are then selected to go to NASA for training. But from there, it doesn't stop. There's still another selection process in order to be considered somebody to be a astronaut to go up to the Kármán line, just the Kármán line, 62 miles up. So there's a large selection process where they weed out who they want in that astronaut program and who's allowed to say or do what they're going to do. It's not as easy as you think. You can't just throw money at it and go do it.
I can throw money in your mouth. I don't care.
Okay, well, why are you here? If you don't care, why are you here?
Like, you don't have to answer me. So, like, why you are answering my question? Like, I just
Okay, so a week answering your question. We can spend a week answering your question, and you're just gonna. What you're gonna do is you're gonna ask a question, and when we answer it, you won't acknowledge the question that we answered.
Just give him 1 second answers, like hello, and that's it, and let him figure it out, because it sounds like he's got TikTok mind. He can only go for a couple seconds, and then he loses focus.
You're just gonna answer a question. Right. You're going to ask a question. I'm going to answer it, or DJ or says who is going to answer your question, and you're not even going to listen to the answer or acknowledge it. You're going to immediately ask another question that's completely unrelated to the question you asked first.
Who are you talking to?
That sounds about right.
You're talking to me?
Yeah, you.
Yeah, if you listen to him, you would know that he was talking about you, but you've got a TikTok brain.
DJ,
you know what it...
Can you please stop yourself? Okay, I'm talking with Solo. Solo, listen. I have no question to you. I'm here to listen. That's it. Don't answer me. Don't talk. Hey, Tanvi, you said something. Don't. Just continue your conversation. And I don't want to DJ to bully me.
DJ the bully. That's a new one.
We need Matrix in here.
Shit, if he thinks I'm bullying.
I'm here. I'm nice. I'm nice, flat earther.
You're actually a glober, man. You're not even a flat earther.
That's right.
You're trying to go back to the globe.
Well, I'm trying. It's not working.
I don't know, DJ. Do you want to walk them through something? Do you have time?
He's not worth wasting my energy on.
Sounds about right.
Yeah.
Let's see. Maybe somebody else would come in and ask a question. Let's see, there's Doomer. I've never met him before. Matador. I may have met you or not met you. Midnight. OG Apocryphon's a Glober. I know that for sure. What's up, Babu? Ba.
Globe all day.
Hello, there. What are we?
Globe all day, really?
Yeah, we.
All right, so when needs to be muted, they want muted. They'll get it. Globe all day. So who thinks they live on a globe here? How would they prove it? We have O that showed up. O, do you think you live on a spinning water ball in a vacuum? Can you tell me how that all works? I guess not. Maybe he doesn't think he lives on a globe.
You know, since Tan wants to just listen, I'd kind of give a brief overview of why flat earthers are flat earthers.
Right. Well, before you do that, we do have some new people that just showed up. Mr. Kumar, welcome. Matador, are you new? Maybe not.
No, I'm not.
Anyways, any of the... Okay. Is anybody speaking to Babu?
Is there anybody angry in here today? Okay,
We've got a lot of new folks. Yeah, that is good. No one's upset. Everyone's very content to live on the flat Earth. They don't think they live on a ball. The people that live on the ball, they seem angry.
They get upset really fast.
Yeah, very quickly. Anyway, Doomer, Bay, whatever, Ba. Welcome, everybody. All right, go ahead, Swoldo.
They're all shy. They know it's going to trigger them if they ask questions. So. Like you, all of us grew up in school, right? We all learned the Earth was a ball. For many of us, it wasn't until like later on in the middle of our adulthood that we learned from somebody that the Earth could be flat. And we, of course, dismissed it immediately because it sounds stupid, like, water should be falling off the edge and a disc floating in space. But come to find out, that's not what flat earthers think at all. We put all of that aside first, right? We're just going to talk about the Earth in itself, and we're going to talk about the surface of water, because they say that everything is held on the Earth by gravity, right? Okay, cool. I'll agree with that. They say water is being pushed down on the Earth by gravity, and the surface of water is forming around the Earth in a ball. Okay. All right. Sounds about right. But the Earth's really big. Really, 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 really big. How do we know that the Earth is flat? Because it looks flat. It's just really, really big. Well, they tell you that the Earth is 24,900 miles in circumference. It's a pretty big number. 40,000 kilometers. That's a pretty big number. So you got a circumference of 40,000 kilometers, a radius of 6,371 kilometers, and then 3,959 miles radius. Those are big numbers. And then then it comes down to finding the distance to the horizon, right? So me, I'm 5 feet 10 inches. It's like 178 centimeters, something like that. When I go out to the beach and I watch boats go over the curve, right? They tell me that the horizon is 3 miles from my eyes, or about 4.8 kilometers. Well, that's not right, because when I've been out to the beach, I've seen boats 10, 15, 20 miles away, 15, 20, 25 kilometers away. And, no, that can't be right. Let me do some more research on that. So I do some research, and, sure enough, the horizon is supposed to be 4.8 kilometers away, or about 3 miles. Well, okay, if that's the case, maybe I was deceived. Maybe I thought those boats were further than what I believed them to be. Maybe they were 4.8 kilometers away or 3 miles away. So I then go out and try to find large distance bodies of water, like a 10-mile lake, or a bay, or, I can even go to the ocean and just watch boats go away and track them on the shipping radar. And then come to find out, sure enough, my eyes were right to begin with. I was watching things go away 10, 15, 20 miles away, 15, 20, 25 kilometers away. And boats, most of the time, weren't even disappearing bottom up. They were just going away and disappearing into, like they were getting smaller and smaller in size until I couldn't see them anymore. And that was really weird too. So that right there proves to me that the Earth is flat, because if water is flat, and 70% of the Earth is made up of water on the surface, the Earth can't be a ball. Now, what shape the Earth is, I have no idea. Is there outer space? No, you can't have gas pressure next to an empty system. That's impossible. You need a container in order to have gas pressure. Can you go around in a circle on a flat Earth? Absolutely. Absolutely. All navigation is done by the stars. You can't look at the ground and say, I'm at 35 degrees north latitude just because this rock is right here. This is my marker for 35 degrees north. So I hope that answers everything. All the planets, they're all in the sky. We're not saying planets are fake. What we're saying is the story you were told about them is fake. The idea that you think you can go up there and land on one and walk around, that's fake. Because space is fake. There's no vacuum of space. What's up, Thinker?
Yeah. So you actually saw something drifting off to the horizon?
Say that again?
You actually saw something drifting, something disappearing into the horizon, and it did not disappear bottom first.
Yeah, most of the time when you watch it, that's how it is. Whenever there's weird weather conditions, like high pressure or low pressure system, maybe there's like rain coming or something like that. Usually, anywhere from 2 to 5 days before that happens, you'll start seeing effects where it can give the appearance of bottom-up obstruction off in the distance. But the location of those boats will often be like 3, 4, 5 times further than where the horizon should be.
So where could that such a theory come from? Like
the globe?
No, the theory about the boats disappearing bottom first. So
it's not a theory. It's not a theory. Just before you go on, it's not a theory. It does happen. It does happen.
Yeah. Okay. Because people saying that the Earth is round. So how did that come about? How could that come?
It came about because of the celestial sphere when they were mapping out the stars. When they look at the stars in the sky, it's based on it's observer dependent. So the way that you see things, you have a spherical vision all the way around you, and so they wanted to map out the stars, and so they created a celestial sphere, and then they pressed the Earth up against the inside of that celestial sphere. That's how the globe came about. But it's all based off the celestial sphere in the sky. It has nothing to do with Earth.
Like everybody says that ships disappear bottom first, but you have actually seen that it's not the case. So why do people still say that that's kind of a fact?
Because they don't go and look for themselves. They just believe the story they were told when they were a child. Most people have never seen a boat disappear bottom up, except in like one of the 100 videos that have like 5 billion views on YouTube. I promise you, if you go to the beach right now and you track a ship going away from you, either A, it's going to disappear bottom up 20 kilometers away, or B, it's not going to disappear bottom up and you're just going to watch it go away.
So it gets smaller and smaller and disappears.
Yeah, everything converges into the horizon where the sky and the Earth appear to meet, and then the angular size of the object becomes so imperceivable that the Rayleigh criterion takes over, and everything just kind of blends together into the horizon. That's why you can't see mountains from 1,000 miles away, because mountains they shrink too when they get smaller.
Okay. So I was not in this voice channel before. So you were talking about measuring the distance to the horizon. How did you do that actually?
Well, it's a calculation based off the radius of the Earth.
Okay. Okay.
Here, I'll put the formula for you in the side chat just so you can see it.
All right.
And then we can test that distance by having a distance marker in the distance. Okay, so if we calculate that the horizon should be at 3 miles, then we could have a distance marker at 10 miles. Okay, and because if you don't have a distance marker, it's very hard to tell. How do you know that horizon's 3 miles away or further or closer? It's very hard to tell. But if you have a distance marker, let's say we have an oil platform out in the ocean 10 miles away. Okay, then we can tell if the horizon's in front of the distance of 10 miles or behind the distance of 10 miles. Do you know what I mean? Hello?
Thinker, you're on mute.
Yeah, I'm actually looking at the picture you've sent, so I didn't hear.
Did you hear what DJ said?
No, I heard it, but I was not concentrating. I was concentrating on the image you sent. I was concentrating.
Can you repeat yourself, DJ? I'm sorry.
When he's ready.
Oh, okay.
Tell me when you finish looking at the picture.
You can continue the discussion.
Yeah, so if the horizon should be 3 miles away, but we can see the horizon beyond 10 miles away, that's not possible if the Earth's a globe.
Well, we're trying to figure out, Thinker, because the horizon is based on the radius value, is whoever measured the radius to begin with, right? Since now that we know that the Earth is flat.
Like, the Earth is probably not, it's actually not perfectly round, so the calculations may be different depending on the place.
So from the equator,
a geoid shape.
Right. So from the equator, the radius is supposed to be 3,963 miles, and from the North Pole, the radius is supposed to be 3,950 miles. So we're talking about a 13-mile difference over 4,000 miles. So if you had something that was 4,000 pixels wide, right? If you drew a circle 4,000 pixels wide, would you be able to notice a difference between 13 pixels?
No.
Yeah.
That's going to be very subtle.
It's important that you understand that your claim about living on a potato or a pear is highly exaggerated. The difference in circumference around the poles versus around the equator is only 0.3% difference. So it is very, 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 very round. Okay, that's the claim. So it's almost a perfect sphere. So
significant.
Yeah, it's very insignificant. So the radius and the drop over distance that you should experience, which is approximately 8 inches per mile squared, is correct. And if we don't experience that, if we don't measure that, then the Earth is not a sphere. It's very simple.
You can even see in the side chat there. Okay, that's NASA's picture. They claim that that's a photograph of the Earth. Okay, and then we put it in Photoshop and put a perfect circle around it, and it fits perfectly inside of it. So they say it's almost a perfect sphere, but it's something like 0.3% off being a perfect sphere.
Yes,
So
it has tips. At the equator. It's got the Earth is a bit chunky.
Right. So anywhere on the globe, if you have, say, 20 miles of water, it's going to have approximately 266 feet of curvature over that distance, if the Earth's a globe. No matter the altitude, no matter where you are.
Well, no, don't say no matter the altitude, because technically, if the Earth is a sphere, the higher you go in altitude, the further you get away from the center, and that starts to make a bigger circle. So it would change the map.
Platypus.
So it
Platypus.
changes. Yeah.
Hold on a second. Hey, Platypus, we're talking to a new guy right now. So if you could kindly go on mute, that'd be great. We've talked to you 1,000 times.
Yeah. So I mean, I specifically said approximately 266 foot, which is correct at any altitude. So I mean, even if it's 4,000 foot altitude, it just changes the radius from 3959 to like 3959 point something. It's just a few points different. So approximately 266 foot of curvature anywhere, any large body of water, basically 20 miles across.
Also, bridges. I have a question. So, bridges which are significantly long, the constructors of the bridge consider the curvature of the Earth. So, why do they do so? Because the Earth has to be round if they do so.
Okay. I hear what you're saying. So you think that bridge makers account for the curvature of the Earth. Can you show us the amount of Earth curve that they measure between points? Excuse me. Can you show me the amount of Earth curve that they measure between points and how they account for it?
I have to research it.
Okay. It's very important you understand. You can't come in here and just, find something off of Google and then repeat what Google has made as far as a claim and then not expect us to ask you for the evidence, because that's what we're going to do. And it turns out you'll find that there is no evidence. There is no measured Earth curve. And at the end of the day, they can, draw plans to build a bridge over a curve, but when they actually do build it, there is no account that they make.
Even if they make a fraction of an inch accounting for what somebody believes would be Earth curvature, it wouldn't make a difference because of the huge tolerance and shifting leeway that they account for, for the bridge, right? The bridges move around a lot, a huge amount actually, when it gets warmer and cooler, different conditions. Okay, so if they say, oh, this is, we've accounted a quarter of an inch for the curvature of the Earth, it's probably not going to make a difference whether the Earth would be a globe or flat. The thing is, we can test the water underneath the bridge, and it's going to measure zero curvature. That's something that we can easily test.
And yeah, so to finish off what I was saying earlier, once you go out and measure that there's no Earth curvature, like DJ said, right? Then basically you can throw out every story outside of the Earth being a globe, right? There's no more outer space. There's no more distance to the sun. There's no more orbit around the sun. There's no more orbit of the moon around the Earth. Everything that the planets are doing in the sky is not what you think they're doing. Can we still see them all up there? Absolutely. When I look up in the sky, I see the sun move across the sky. That means the sun's moving. We're not. It's that simple. It really is.
Is that guy still here? What was his name?
No, he's gone. It was like Vin or 10 or something like that.
Okay.
Can I ask some questions, please?
Sure.
So, the question, where does the question come from regarding whether the Earth is flat or whether the Earth is a globe?
What do you mean, where does the question come from?
If I may say, where does the question come from? By that I mean, where is it that we have first learned about the dynamics of the whole system?
Where did we learn about the dynamics of the system?
Yes.
That's kind of an interesting question. Let me start this way. Do you ever experience the Earth as a globe? Meaning, do you experience the consequences of, depending on your latitude, having a wind that is several hundred miles per hour? Do you experience Earth curve in any way, shape, or form? Do you experience the vacuum of outer space? Do you experience any of the claims made that comes from the globe concept? In reality, do any of those things actually occur?
There is that idea that because the Earth is surrounded by an atmosphere that has wind and air in it, the weight of the wind and the air weighs down on us. That has shaped our skulls to be the way that they are. Had it been a flat Earth, we would not have felt the atmosphere on the top of our heads as we do.
I don't experience that. I don't experience weight of air on top of my head. You experience that?
Yes, when I travel from, let's say you're talking about the beach, but if you travel from the bottom of a mountain to the top, you can feel the change of the atmosphere, and the level of the sea affects you differently at that point.
Yeah, I know you're talking about a difference in air pressure. Okay. Do you realize that you cannot have air pressure or gas pressure of any sort without a container? As that's the way it's defined, even by NASA. Gas pressure is defined as the force of the molecules colliding with the walls of its container. That's what it is. So it doesn't have anything to do with weight, Air does not go downward exclusively. Gas moves freely and randomly in all directions. We have gas pressure.
Somebody mentioned earlier the vacuum of the space is not present. So I was wondering how does the vacuum of the space is defined by the flat Earth, because then there would be no pressure on the surface, because there would be nothing colliding at the top.
Right. So, number one, you have to understand, we don't claim anything called a vacuum of outer space or an ever-expanding universe, for that. That would be a volume, an ever-expanding volume for the gas to fill, because that's what gas does. It fills available volumes completely. So if we have gas pressure on the Earth, then there is no vacuum of outer space. If there was, the gas would fill that space. And there would be a 10 to the negative 17 torr vacuum at the surface of the Earth, making it impossible for any life to exist, because all of the liquids on the surface of the Earth would essentially evaporate, turn to gas, and there would be no oceans, no life. We have gas pressure, we have oceans. The Earth is obviously contained. There is no outer space as you understand it.
Okay, let's not get far ahead, but I mean, the air pressure is felt because of the container then.
Yes. So the Earth is contained.
So you're saying the flat Earth is contained within a big container?
It seems that way. That's what we have evidence for.
Okay. But has anybody seen the container?
No, but we have the evidence for the container, which is the gas pressure itself.
Well, so you are taking analytical evidences then that we are derived from the that are derived from natural phenomenons.
Yeah, the naturally observed phenomena is gas pressure. The necessary antecedent for gas pressure is containment. Physical containment.
Right. So you would, in that case, consider the waves of the sea do affect the movement of the planet as well?
No, there is no planet.
Because earlier on it was believed that the waves of the sea could be because of big rocks falling into the pool or the pond that it is.
Okay, I'm kind of losing you here a second. What do you mean by big waves and air pressure? What are you talking about?
No, since you asked that, do you have any evidence for the flat Earth to not be flat?
Well, the only thing that would disprove the Earth being flat would be Earth curve measurements. And there are no Earth curve measurements. No one's measured any Earth curve ever.
Hello.
Hello.
Hello, how's it going?
Great. How are you?
I'm good. How are you?
I already answered that.
So since there is like gas pressure, there should be an envelope of some sort. So you're saying there's a glass container or some kind of an envelope?
Yes, the Earth is enveloped in some form or fashion. It certainly, in my opinion, is probably solid. It could be liquid. Not saying it can't be one of those two things, but it has to be something to contain gas. Those are the only two things that we know that can contain gas, solids or liquids.
Good night.
Now here's the thing, right?
Hello, everyone.
Hey,
man,
hold on, bro. Hold on.
Hello.
Hey, Mr.
Hello,
Kumar.
everyone.
Hey, bro, I'm gonna mute you if you don't mute yourself. We were
Hello.
talking and you're interrupting. Mr. Kumar.
I took care of it.
All right. It was Mr. Kumar you're talking to, right?
Correct.
Mr. Kumar. Now, having a container around the Earth, right? Having a barrier around the Earth is not exclusive to a flat Earth. Now, there could be a container around a ball, right? Like how that would work, I have no idea, but there could be a container protecting us from the barrier of the vacuum. I mean, look at terrariums. Like there's ways to do things, right? But if you want to know whether or not the Earth is curving, you just need to go test for the curvature. If it's a sphere, there has to be curvature. That's what Sezu was saying.
Okay, let me shift my evidence from the air pressure to, I mean, it won't be called an evidence in that frame then, but what do you guys, my other question is, how do you explain the movement, I mean, of the tectonic plates that you feel? Does that not, like the air pressure and the tectonic plates together that you feel do explain the
you can have tectonic plates on a flat Earth.
Or is it like the, I'm sorry, what?
You can have plate tectonics on a flat Earth. You can have earthquakes, you can have volcanoes. If you're talking about the Earth's crust, the farthest anybody has ever dug is 7.8 miles. So to our knowledge, the Earth could be anywhere between 7.9 miles thick and 1 billion miles thick. We don't know.
Yeah, but why would things, so you're saying that the pressure does increase as we go down, but had it been a flat Earth, there would be nothing on the bottom pressing against it. So why would there be a pressure in the first place? The gravity causes the pressure inside the circular geoid
that's something you have to
sphere,
prove.
right?
That's something you have to prove, right? Because gravity is an effect, not a cause.
I think this guy's thinking of imagining a disk in space, by the way.
Probably. But we already proved that outer space is fake because you can't have gas pressure without a container. Do you agree? What do you think, Mr. Kumar? Do you think that we think the Earth is a disk floating in outer space?
I mean, I do not think that you think that.
Okay, fair enough. Let me ask you this then. Do you think gravity is a cause or an effect?
Okay.
If you don't understand my question, I'll explain it better.
Yes, I mean, it could be an event in itself, but it could also be a cause for an event.
Well, if you see things fall down, you call that gravity, right?
Yes.
So gravity is a measurement of an effect. What the cause is, we have no idea. So I don't disagree with you. I actually work in the oil field, so I know under drilling operations, pressure can increase the further down you go into Earth. But that doesn't mean that gravity is the cause of that. It just means that it's the effect.
Right. I was just trying to find some natural phenomena that could explain the curvature or the curvature of the Earth, rather than and then use that evidence to prove the circular shape of the Earth. So even in a flat Earth, there could be like a curvature that's present, but so that would be like, I couldn't use that as an evidence, but in order to prove
If
the
there was
whole
curvature
circular
present, the
nature
Earth
of
would
the
be
Earth,
flat.
even if there was a curvature, the Earth could be flat then.
No. If there was curvature, the Earth would not be flat.
Right. Okay.
Yeah, like what are you talking about, dude?
Sorry about the loud noise.
Did he just say if the
I
Earth?
do not think the Earth is flat for a second, because I'm very much sure with my knowledge of the Earth is like circular in nature, so I'm not even considering it. But hypothetically, if it were flat, is what I was trying to get to. I was wondering.
Right. You have a bias for whatever reason. You're not going to change your mind today.
No, I mean the evidences that I have found through the circular nature of the Earth, like the movement of the wind, and it connects the idea to the movement of the tidal energies actually causing the movement of the wind, and then shaping the mountains that cause the air pressure to rise over them.
Yeah, how'd you prove all that?
Leads me to the envelope.
Its pressure systems are generally caused by the sun, right? By hot and cold pressure systems, right? That's what's creating the wind, which is creating the waves and all that kind of thing. It's not something that would be exclusive to a globe, right? Something that would be exclusive to a globe would be the water curving over distance. But when we go and test over huge distances, there's zero curvature. Thousands of tests have been done now. Every single test shows that there's no curvature.
Okay.
So if there's no curvature,
some more concrete proof that could lead to
the. Do you agree that if there is no curvature, then it has to be something else that's causing all this?
I mean, to be honest, I was given these answers first, but I was they were very careful with the speech around. So you are saying that the curvature of the Earth could not prove the flat Earth, but I mean, I'm saying that the curvature of the Earth could not prove the flat Earth, right?
Say that again.
Yeah, right. I can understand that. So I'm saying that even if there was a curvature, the Earth could still be flat. But you're saying that if the Earth, if you could prove the curvature, then it could prove that the whole Earth was circular.
Yes. Let me explain this to you.
Not circular, but spherical.
Right. If the surface of the Earth measures zero curvature, then the surface of the Earth must be what?
Okay, can you say that again, please?
If there is no measurable curvature on Earth, then the Earth must be what? It's a simple question, right? If there is no measurable curvature on the surface of the Earth, the surface of the Earth must be what?
No, if there is no curvature, as you are saying, then that would lead to be a flat, right? I mean, it would be like an open plane.
Right.
It would be a plane rather than a sphere.
Right. Now, we're not disputing mountains and hills and valleys. What we're saying is the surface of water everywhere measures flat. Here's the kicker. If the surface of the Earth measures flat, as you said, because there's no measurable curvature, if the surface of the Earth measures flat, then whatever is happening in the sky can only happen over a flat Earth because you measured it flat.
Sounds logical. And another thing would be if the Earth is if the globe is a certain size, and we have gravity on the globe, then we could calculate exactly how much that water would have to be bending over a certain distance. And if that curvature is not there, once again, right, it can't be a globe. And most people don't realize how much curvature should be there. If we just have a 20-mile lake or a 20-mile section of the ocean, there should be approximately 266 foot of curvature over that distance, right? So anything that goes 20 miles away from you should be obstructed behind the curvature of the Earth by a huge amount. If you're at a low altitude, right? So you're standing on one side of the lake and you're watching a big boat, right? Let's say it's the Titanic, right? One of the biggest boats ever to exist. Let's say you got a 20-mile lake, you got the Titanic right next to you, and it's going to sail over to the other side of the 20-mile lake. By the time the Titanic gets to the other side of the lake, you shouldn't be able to see it anymore. It would be completely hidden behind the curvature of the Earth, because I think the Titanic was about 165 foot tall, or 175 foot tall. Okay, but over that distance, there's actually 260 foot of curvature. So you wouldn't even be able to see the Titanic. But what actually happens in reality is we can see zero curvature over a 20-mile distance. We can see the base of an object that's 20 miles away. And this is consistent.
Mm-hmm.
And that's where we come into the problem, right? That's how we became flat earthers.
So if you had like a person on the boat that could measure the elevation and that could measure the laser, there was two people who were like looking at each other across the surface. They would not be able to measure this curvature then? What I'm trying to get to
that's
is
exactly, yeah. So if just say you had a really, really high-powered laser.
No,
Okay,
what I'm trying to get to is that a curvature only measures, you know, the sharpness of the, as I'm saying, the sharpness of the bend. So there could be a bend, and then there could be a flat. Like there could be a bend on the surface of the Earth, and then there could be like a plane afterwards. Like being on a string.
On the land,
if you have like a
on the
string
land
that you try to bend, there could be something like that. So even then, you would have some surface of the Earth has a curvature, but the rest of it does not.
Yeah. But look, that's why we're talking about over the surface of the water, not over the land, because land has elevation changes, but water is level. Okay, so if you have a 20-mile lake, you're not going to have different elevation of water anywhere on the lake. Okay, if it's a globe or if it's flat. Okay, because it's called water level for a reason. Okay, so you're not going to have, the water's not going to be higher at a different elevation on one side of the lake. So we're talking about. Okay, so if they tell us that over 70% of the surface of the globe is covered in water, oceans and lakes and seas, etc. So that means that if gravity is real, right, and if the globe's the size that they tell us, then we can calculate that over any body of water that's 20 miles across, you should have approximately 266 foot of curvature over that distance. Yeah. So yeah, if you were doing it over land,
I mean,
then
you're
you would
doing
have
the
to
mathematical. That's what I'm getting to. I'm asking. You're doing the mathematical proof for the flatness of the Earth, and I'm asking any physical, geographical, evidences that you have measured that the surface of the Earth is flat.
Absolutely.
But I can't ask you that because it's not possible to measure the whole surface of the Earth. So I'm not even considering it because I know that the Earth is a globe because of the reason that you asked me how can you measure it, and I said that you can feel the pressure on the top of your head. And
well,
you
you
were saying that
actually
the
you don't
pressure is
feel
due to the
you don't
envelope.
feel any pressure
Like
on the top of your head from the air. Okay, and gas particles
Well,
move at random in all
you were saying
directions.
that because you're saying that because you are not actually, but I have considered it, and I feel like that is a more that provides me a more better answer. I mean,
Well,
how
it's
can you
not
say
true
that you have
though.
not felt?
Okay, so you don't feel gas pressure on your head or pushing on you. Okay, so gas particles move at random in all directions, right? If you look up the definition of gas particles right now, it's going to say gas particles move at random in all directions. They're not pushing down, right? They're going in all directions. Okay, they only stop going in a straight line if they bounce off another particle or they bounce off the wall of their container. Okay, otherwise a gas particle will just continue going in a straight line, whether it's up or down or sideways or whatever direction, right? They just move in random motion. Okay, we don't feel gas pushing down, right? Gas isn't being pulled down to the earth. Gas particles don't operate that way.
And I've been to the top of Mammoth Mountain in California, and I've been to the beach, and I can tell you right now, I don't notice any different. The air feels a little thinner, but I don't feel any pressure difference.
Why are there so many flat earthers in California?
They're everywhere, bro.
A lot in California and Australia, though, I've noticed. Like a large majority in California.
Well, not necessarily. I think if you look at the polls that people do, I think there's the greatest amounts in Brazil. According to polls that were done, I don't know how accurate they were, but they were proper government polls. So over 10% of Brazilians. But I mean, you're going to find more on Discord that are English speakers. You could probably find other servers that are speaking like French, like a French Flat Earth server, for example. They're not going to be on here because most of them don't speak English. So on Discord, you're going to find the majority of English people, right? You people from the UK, people from Australia, people from America, and then still a mixture of also Canada too, I guess.
I mean, that's what like the normal person would safely assume, but I would argue that the majority of flat earthers are from California and Australia.
Just because I lived in California doesn't mean I'm from there.
Yeah, I don't know how you came up with that conclusion.
Where do you tell people where do you tell people that you're from when you're on vacation?
Where do I tell people where I'm from and when I'm on vacation? From America.
Yeah, like if you went to New York, right, and someone in New York was like, "Oh, hey, you're visiting New York. What state are you from?"
I've been to New York. It sucks.
But what did you
I
tell
don't know.
the
There
people
could
when they
be
asked
like
where
a
you're
lot of the flirters who could be just not very vocal on the internet, so we're not seeing them. They could be like staying away from the internet altogether.
They try and insert themselves in loads of places on the internet. Like the weirdest place I've seen flat earthers was the Nerf gun forum.
You're going to find flat earthers everywhere.
from what
because
I understand,
there's
that a lot of
countless
the flat earth
millions
people
of
are
them.
just living inside
Well, it's not
their
that there's
houses
countless
and
millions of them. It's
apartments.
that they would like to recruit more members.
Nobody's
really?
recruiting anybody. Dude.
Okay, so this is the thing, right? You guys come here to us. We're not going into any of the other channels. In fact, I've never really even been in any of the other channels in this server. We just set up a room.
Okay.
And then people come to us because it's a super interesting topic. And if you have a look in the side chat, you'll see even on an unrelated server to the shape of the Earth called the English Hub, okay, we still have the most popular channel by far in the entire server. And
You
people
guys
come to
sit in your
us. You're not gonna.
AFK
We
all
don't
day.
need to go. Yeah, we don't.
make
We
you
don't. We
popular.
don't need to go into other channels or anything like that. People just come to us because they want to. Maybe like you, they want to whine. Right, and complain about flat earthers, or some people like Mr. Kumar
that you
actually
think that this
want to
sounds
ask
good,
some
but it really
questions. Well, I don't think that you're really in here for the right reasons. To be honest, you just seem like you just want to complain about flat earthers, right?
What
Which
was my
actually
complaint?
fits. Well, it actually fits.
I made an observation. Was it a complaint?
We're doing an event right now. It's where did the flat water hurt you? Right. So where did the flat water hurt you?
Can you tell me what my complaint was?
Yeah, you're just kind of whining. You're like, oh, flat
What did I
earthers
whine about?
they want to recruit more members, and I find them in Nerf
Hey, hold
gun
on, DJ. He said he made an
servers.
observation. He said he made an
Really?
observation. Yeah, let's see your observation, bro.
Yeah, post your observation. Doctor disrespects woman.
Where are you from? Where do you live, Swole Dog?
Anywhere in the United States.
So my observation is that a majority of flat earthers are in California. Swole Dog, where do you live? I'm conducting an experiment. I have a hypothesis, and your answer is crucial for my scientific experiment. Where do you live?
Texas.
What state?
Texas.
Don't lie. So.
Oh, really?
I'm
I know
also
he lives in.
conducting
He's always
another
told us he lives in
experiment,
Texas.
And then
bro.
the hypothesis for this experiment is that flat earthers are dishonest and lie a lot. I
Really?
made
Well,
this
so
observation
look, bro, you're
before
going
making
on
this
mute.
hypothesis.
You're an idiot. You're not welcome here.
Piece of
Shut
shit.
up. Yeah. All right, I'm gonna ban you, bro. How about that? Permanently. For trolling. There you go. Bye bye.
That was ridiculous.
Yeah. Pathetic. Continue on, Mr. Kumar, with your.
Right.
See, we appreciate you
Right.
because you're asking genuine questions.
Thank you. I mean, now that the disturbance is not there, I was keeping quiet because you were speaking to them. I mean, it's not a disturbance, it was just that if I had spoken, then it would have caused confusion. But
No, you're
okay.
good. I actually have an observation myself too, but I'll talk about that later.
Right.
Go ahead, Mr. Kumar.
I mean, if you want to share that, I mean,
Oh,
I had
I remember.
a good idea. I was just.
I'll be
sharing-
real
Yeah, I
quick.
remember-
I'll be real quick.
Yeah,
The,
go ahead.
the people who hate flat Earth the most, the more the person hates the flat Earth, the more degenerate they are as a person. So, the more they're degenerate, the more the idea of flat Earth disgusts them, and they come in here and they parade around like that.
Yeah, anyway, let's not worry about that guy. I've seen him around before. Anyway, anyone that calls them doctor disrespects woman isn't necessarily going to be productive in a conversation. But look, back to what we were talking about.
Is that
before
an
guy came
assumption
in.
or an observation or factual evidence?
I'm batting 1,000.
What specifically are you referring to?
My observation.
Oh, that people that are more angered by flat earthers are generally degenerates. Yeah, that's an observation. And that's like the law of averages kind of thing. It's extremely consistent over the years. We've
I shall
noticed
come.
that.
Not
Everybody.
I think I should
but-
work up on vocabulary before I come here because I would not be able to engage otherwise.
Yeah, we can. Look, you have great English, so I don't think you're going to have any problems communicating. But this is the thing, it's very simple. Okay, we can go and test a certain body of water. Okay, so have a look in the side chat. I'll just give you an example of what I'm talking about. Okay, so this is a big lake in Utah, in America, and it's called the Great Salt Lake. Okay, and you can see a yellow line drawn on this Google Map screenshot. Okay, so this is an observation that a flat earther went and made. Okay, so they're measuring from one point in the lake, 21 miles, which is 33 kilometers, across to another point, which is just shoreline to shoreline. Okay, now here's some basic math. Let's go over some basic math. So here's a screenshot.
If I may
from
say,
an
Earth, if you would consider the Earth to be a globe, then the spherical top is more flatter in comparison to the spherical side. It's not a sphere; it's a geoid. I mean, it's flatter on the top, and it's more circular. Curvature is more possibly seen on the side because it's like a disc. It's pressed down on the top and the bottom. So
But look at this. Look at this. Okay, so let's just quickly go over this. So they say it's almost a perfect sphere, but technically it's a geoid. Okay, so it's 0.3% off being a perfect sphere, to the point where we draw a perfect circle in Photoshop around the picture of the Earth that NASA gives us, like you can see in the side chat. It fits in perfectly. Okay, so anywhere on the surface of the Earth that you have 20 miles of water, right, because of gravity and because of the shape of the Earth and the size of the Earth that they tell us, you have to have approximately 266 foot of curvature over any 20-mile body of water. Okay, whether it's at the equator or whether it's at the poles or anywhere in between, because it's almost a perfect sphere, right? So much so that they don't even take that into account when they give you drop over distance formulas and calculations at university websites. So it's almost a perfect sphere, but technically they say it's a little bit fatter at the equator, a little bit squished at the poles, but it's only 14 miles or something like that. And over a huge distance, that doesn't make a difference to the drop over distance formulas. So if you have a 21-mile lake, like I'm showing you here, it has to have approximately 293 foot of curvature over that distance. Right, 21 miles is 33 kilometers. Okay, 293 foot is about 90 meters, maybe a bit more. Okay, 90 meters, 293 foot, that's like a skyscraper building. Make sense? Right, so this observation is done
your calculations are actually quite well put, but I'm unable to receive them through the internet. I mean, your voice is not really receptive for me. Possibly other people in the room can listen to you better.
Really, my internet.
I think I just need to train my ear better to the room, so that the gravity and the atmosphere works better here while I'm speaking to you.
Oh, well, yeah. So this observation would completely debunk the notion of gravity. If you're thinking gravity is pulling everything towards the center of the Earth. And the fact that we have pressurized gas debunks the globe model as well. Because you can't have
one thing
gas
that I'm
pressure without
observing
a container.
in this room is that people who try to prove that it's a flat Earth would not be willing to be proven otherwise.
Yes, we would.
It's harder for them to.
Show us any measurement of Earth curvature that's empirical.
What happens when you, as a globe, as a flat earther, start to believe that it's a globe? That it's a
geoid? I believed it was a globe my whole life. Yeah, so I believed it was a globe my whole life until I went out and actually started investigating it. Okay, and I went and did my own tests, and there have been thousands of tests that are being done right now, like the one that I'm trying to show you in the side chat, which you're pretending that you can't hear me explain. Okay, and we're asking people, if you want to present evidence, okay, so I'm presenting evidence even though the burden of proof isn't on us because we already experienced the Earth is flat. So if you have some evidence that you would like to present that's empirical, right, like measurement of drop over distance, please go ahead. We're more than happy to go over it and be proven wrong. Okay, but nobody in the last 8 years has managed to do that, even though we've had physicists and satellite engineers and professors come through here, right? None of them have been able to prove it's a globe, right? Empirically at all. So if you want to appeal to the future, right, which is fallacious, and say that if you were to present some evidence, we would just reject it, then I'm going to call you out on that, right? Because no one here is rejecting any evidence. You haven't presented any evidence. In fact, you don't have any evidence. Prove me wrong. Present some evidence. Not faith-based evidence. Actual empirical evidence.
Because you were
Floor's
asking
yours.
me my experience around me, I have not really gotten myself involved with the idea. I have believed the Earth to be flat or the Earth to be a globe, both based on the experiences of other people that have come into the company. But this is the first time actually I'm new to the conversation. I've kept myself away from the whole conversation mostly because I was building up the experience for myself through travel and other events. And
yeah, traveling's not really going to help you prove it either.
No, I mean,
I'm willing to bet. I'm sorry. I'm willing to bet that your firsthand experience, your knowledge, flat, stationary, and closed Earth. You believe that you live on a ball, but your experience is of a flat, stationary, and closed Earth.
Yeah, that's what they taught me in school. They said you experience the Earth as flat because you're so small and the Earth's so big, and you don't experience the Earth moving because you're so small and the Earth's so big. All right, so we experience the Earth as flat and stationary. Do you agree with that, Mr. Kumar?
You're saying that, do I believe that the Earth is flat and stationary?
No. Is your first-hand experience flat and stationary? Do you see any curvature? Do you feel any motion?
Look, I looked up at the sky and I saw the curvature in the sky. Now you're telling me that it was my eyes playing trick. I mean, the curvature of the sky is seen when you look up at the sky, right? So,
Bro, I've been playing my whole life.
I mean, the horizon is not on the surface of the sea; it's in the sky, right?
No, it's not, man. It's where the sky
in the world.
Bro, I've been in planes at 45,000 feet, and I've still never seen the curvature. Every time I flew, before I even thought the Earth was flat, I was like, wow, the Earth is really big. It still looks flat. I used to think that all the time. I've flown over 30 times.
Sheepdog, I'm not sure that's what he's saying. He's saying that the sky is curved. Well, I don't know what that means. What do you mean the sky is curved?
Yeah, I mean, that's the empirical evidence that you were asking. I mean, it's not empirical, but it's the evidence that eyes needed, and I was comfortable with that answer. But at the same time, I was told that never to speak of it again. So,
hold on a second. What do you mean that the sky? Can you explain to me what you mean by the sky is curved?
The sky is curved. I mean, you can see the bend or the envelope, like seeing a big, like being, yeah. Why wouldn't you say the sky is curved? Isn't it like?
I don't know. The sky is not curved. There's no curvature in the sky.
Globe. I mean, if you see a globular glass-made object, you can see the curvature there, right? So why wouldn't you see the same curvature on the top?
Oh my
from
goodness,
the outside,
man!
it's visible to you. Then why wouldn't you be able to see it from the inside as well?
I do not see any curvature of the sky. I don't even know anybody in this VC that would admit or even claim that they see a curvature of the sky. Now, if your perception is of, essentially a dome where the surface that you're standing on is, horizontal or planar, and then you can see essentially 180 degrees, from horizon to horizon, and you want to describe that as a dome or a sphere or a curve, I guess you could, but I don't experience it that way. My eyes see the sky. It's blue from horizon to horizon right now, but I don't call that a curve. You can't go, but your perception is one thing, but to say that you see a curve in the sky, I've never experienced that.
Well, why would you want to experience somebody else's experience? You wouldn't know you want to know what were the steps that I took to feel those experiences?
No, I'm. If you're saying that you think you live under
I mean,
a
I
curved
was 17-year-old when I experienced that, so my eyes were better able to adjust to the curvature then. As I'm getting older, I will have to really work up a lot to actually get to that level of experience again.
Okay, so you perceive the sky as being curved.
The curvature would take. I mean, you could, yeah.
You perceive the sky as being curved, no problem. Is your experience of the Earth that it's curving?
No.
No.
The experience of the Earth is curving. I know that it is. I mean, since the sky is the curvature, I know that it should be an envelope of some sort. So the same idea would not be persistent with the proof that we were speaking of before, where we were saying that the Earth could be flat, but as well it could be curved elsewhere. But if that were the case, the sky's curvature would be an envelope. So if it's an envelope, then it is not flat.
Okay, so what you're telling me is, let me see if I'm conform this for you correctly. If the Earth is a sphere, the sky will appear curved. The sky does appear curved, therefore the Earth is a sphere. Does that pretty much encapsulate what you're saying?
I mean, the sky does encapsulate the Earth, yes.
I just want to see if you agree. If the Earth is a sphere, the sky will appear curved. The sky does appear curved, therefore the Earth is a sphere.
Not the other way around. No, it's not a circular argument.
No. Yeah, that's a circular argument. So if you say that because I think that the sky looks curved, I live on a ball, that's what you're saying. That's circular reasoning.
You
also agreed. Sorry, I just wanted to cap this off. What you experience is a flat Earth with apparently a curved sky. That's my experience. I'm not going to gaslight you and say that's your experience, but that's what I experienced.
Okay.
I would lean more like this.
Sound irrational. It does sound irrational. You're right.
I would lean more like this, Mr. Kumar. If the Earth is a sphere, the Earth would be curving. Like if the Earth were flat, then the Earth would be flat. Like that's logic.
And you did also agree earlier that if we were to measure the surface of the Earth and it's consistently showing that there's no curvature, then whatever's happening in the sky is happening above a flat surface. Now, imagining the sky as a sphere, that's just it's a conception. It's an imagination. It's an imaginary way of conceiving the sky. Okay, because we all know that we have perspective. Okay, and the way that the celestial sphere works is that you assume that you're standing on an infinite plane, okay, and that you're standing in the center, right? And then you have a big imaginary sphere over the top of you. Okay, and as the stars move, and the sun moves, and the planets move, and the moon moves, right, they're going to appear in different locations on that imaginary sphere. Okay, but it's just imaginary. It's a conceptual way of looking at the sky. That's what the celestial sphere is. And long before people even suggested that the Earth might be a globe, right, the ancients conceived the sky like that big sphere, and they did that so they could make a map of the stars. Okay, so they would know how to map out the stars because that's what they used for navigation and all kinds of different things. Okay, and that's where the celestial sphere came from. Right, that doesn't mean that the Earth is also a sphere, just because you imagine the sky as that, or because the ancients imagined the sky as that, so they could make a coordinate system out of the sky. I think empirical measurements kind of are the thing that you should be looking into, because, as you agreed earlier, okay, no one can disagree with this, that if gravity is real, and the Earth's a sphere with a radius of 3959 miles, then a 20-mile body
I was seeing at the night sky, the curvature of the Earth was seen in the night sky, but no, I was seeing it in the morning sky, like just before the evening setting sun. You look, or even if in the afternoon, if you look at the sun, but the sun is overhead, you wouldn't want to see that. But if you like look at it somewhere around before the sunset happens, like I'm not saying about the sun
dips down. The sun dips down behind the horizon, and then it gets dark.
Right.
So remember what I said earlier. If the surface of the Earth measures flat, because you're looking at the sky again, if the surface of the Earth
try to look not towards the direction of the sun, but against the direction of the sun. With the sun behind you, you can look up at the sky, and then if you are able to, keep the glare of the sun away from you, because it can get to your eyes and it can burn them. So it's not like recommended to look at it directly. But if you have the sun at the back and then you try to look up at the sky, then you can, if you are in a flat surface or in a flat land, or climb to the top of your house and try to look up, and it's a clear sky as well.
I'm not disagreeing with that.
In those conditions, you can look up and see the.
You can see the sun. You can see the sunset again. Yeah, no. If the Earth measures flat, then whatever's happening in the sky can only happen over a flat Earth because you measured it flat.
I want to go over perspective with him really quickly. Right, you understand how linear perspective works, Mr. Kumar? How things as things move away from you, they converge with the horizon. Have a look in the side chat. I'm going to post a few diagrams. Okay, so it can look like something is going down in the distance. That would be like the concave, proof for the concaveness. Well, not really. This is just perspective. It will look like the ground is ramping up, and it will look like the sky is ramping down. And that's just the way our eyes work. Okay, it's not because the sun's actually going down, right? Or the ground's not actually going up. It's just perception. It's just the way that the human eye works. Okay. Right. Yeah, so that could be explained on a globe, or it could be explained on a flat Earth as well. Yes, you're right. So you're saying that the curvature that is seen on the sky is how the eyes are working towards this. But I'm not speaking about the objects changing in size. I'm not looking at the objects there. I'm looking just directly at the sky. And that would mean that the sky is completely the same object. It's not made up of different objects. So if there is a bend in one object, that is the sky at that point, then there's a bend in all. There's a bend altogether, yes.
If the Earth was bending, we would have measured it.
These are like good evidences, though. Can we even call them?
So I have something for you in the side chat, Kumar. I'm about to post it right now.
I'm gonna come back and give you something really interesting one day.
I hope so, man. Do you see what I just posted in the side chat for you?
Yeah, right.
The world you live in, this is how you see it. You see that, Mr. Kumar?
I must have had read about the sextant in the past, and that may have had caused me to venture further with that inquiry.
Never mind the sextant. Never mind the sextant part, right? So on the top image, right? And that's not a sextant; that's a theodolite. If you look at the image on the top, you see they're assuming a flat plane, and then they take elevation angles to the celestial bodies, right? But because of how lenses work, if you look at the image below that, this is how you perceive the world. You don't see an orthogonal view of the world. You don't see a Euclidean view of the world. You only ever see in perspective. This is what perspective looks like. Anyway, I got to head off. Y'all have a good day.
Yeah. Thank you. This is what perspective looks like. Okay. Yeah. Thanks for leaving. Oh.
Okay, you remember that. Okay, guys, I shared my experience with you, and I'll be heading off. Is there anything that somebody else would have to ask a question as?
Hello. Hello, hello.
Hello.
Yo, bro. Yo.
Earth is circle.
Who is saying Earth is flat?
Everybody, even you.
I think it is not, man.
You don't think it's flat?
Yeah, I think it's square.
It's a sphere? Okay. Do spheres have curvature?
Yeah, hello.
Yeah. So do spheres have curvature?
Yeah, I'm saying it's fair.
Okay, great. So if it's a sphere, it's going to have curvature, and we can measure that curvature. Can you tell me if anybody has ever measured any Earth curvature in the history of all mankind? Okay, so who did it, and how can we prove it? How can we validate that measurement?
Yeah, let me give you evidence, man. Hold on right here.
No, I just need to have the Earth curvature measurements. That would be the best evidence for a globe.
Okay, I will give you. Just wait a second. Okay, I will be right back. Just wait a second.
Okay. Yeah, ain't that the truth, Doug? We've been waiting for 10, 15 years now, right? I'll be right back with that Earth curve measurement.
Yeah. Now listen to me.
Okay.
Yeah, this is a guy named Eratosthenes from
Eratosthenes.
Yeah.
Right, Eratosthenes. Yep. He didn't measure any Earth curve. He calculated Earth curve based on a flat Earth measurement that he took, but he also pre-assumed that the Earth was a sphere in the first place. So the circular, the circle that he measured, he assumed that to be wrapping around a sphere. That's not a measurement. That's a calculation based on pre-assumptions. I need you to show me drop over distance measurement of the Earth curve.
Yeah. Just wait a second. Yeah. Hey, bro.
Yep.
Yeah. I have seen it. It's 8 inches per mile.
Yeah, I understand. So 8 inches per mile squared is the claim. Where did they measure that? Who's measured that? Because we've checked for that 8 inches per mile squared off over the surface of the Earth, and it's not there. It's completely flat. We have measured the Earth. There is no Earth curve. The surveyors, the ones who make all your maps, the topographical maps, the guys who build the large-scale projects, bridges, huge warehouses, that kind of stuff, they measure it flat. Sea level is flat. Everything is measured flat on the surface of the Earth. There is no curve.
Hey, bro, you know Al-Biruni? He's a Muslim scientist.
Yes, he also measured the Earth flat. He measured a dip angle from the top of a mountain to the horizon, which, by the way, is not the edge of a ball. So he measured the Earth flat as well.
No, he measured the radius of the Earth, if you know correctly.
Right, so no, he calculated it, but he did that using a flat Earth. He measured his height. At the top of a mountain, height is in respect to a horizontal plane, and then he measured a dip angle, and the dip angle in relationship to that horizontal plane to the horizon, which, by the way, is not Earth curve, is also a flat Earth. So Al-Biruni measured the Earth flat twice, and then calculated an Earth sphere radius using the horizon as a tangent point on a presupposed ball. So Al-Biruni also measured the Earth flat, or calculated it, I should say. Can you show me who measured the curvature of the Earth? Drop over distance between points.
Yeah, the definition of curvature is amount of curve at a specific point, right?
So I didn't ask for a definition. I want to know who measured drop over distance consistent with an Earth sphere radius of 3,959 miles.
All right. All right, I have a question for you.
Okay, is that a concession that no one has actually measured any Earth curve? If you're going to ask another question, I am assuming that you're giving up.
No. I'm just asking you, do you believe in flat Earth?
No, I know the Earth is flat. I've measured it myself. There is no curvature. There's nothing to believe in. The globe is a religion. A lot of people believe in that, even though they don't experience or measure any Earth curve.
Okay, bro. Just tell me what you think below it is. Below the Earth. What is below it? You know, if it is
Below the Earth? I have no idea. We're talking about a flat Earth. All the other claims that we would make would be pure speculation. I don't know what would be under the Earth. I don't know if there is an under the Earth.
Okay. So you are saying Earth is flat. I mean, it's like a plane, right?
Yes, a very vast plane. Yep.
Okay. So the plane is circular or square? What do you think?
I have no idea. We don't know the limits of the realm. We don't know where to find the limits of the realm.
All right.
So you guys believe that the Earth is flat?
Nope. Like I told the gentleman just a second ago, we know that the Earth is flat. It's been measured by everybody to be flat. There is no Earth curve measured on the surface of the Earth.
Yeah.
Bro, you can also say that you believe Earth is flat.
No, it's not a belief. You understand? You know what the definition of belief is? It's acceptance without evidence. So I don't accept without evidence that the Earth is flat. I have the evidence. I've measured it. I know it's flat. There's a lot of people that believe things. Let's take the globe, for instance. You have not been provided any evidence that the Earth is indeed curving, but you believe that it's curving. You don't experience any curve, but you believe it.
Wait, I have a question, a little question. I just want to get information. I am not here to win any argument, You got me?
Right, but I just have to be very specific. When you ask me if I believe something, I'm going to be very specific and say, no, I don't accept things without evidence. I do have evidence that the Earth indeed is flat, so I know that the Earth is flat. I just want to make that distinction.
And the other planets, they are flat also?
When you say other planets, you're assuming that those planets that you're describing are like the Earth in that it is a planet. No, it is not a planet. It is a plane. It is a horizontal, flat surface. The planets, the original meaning of that word meant wandering star. Now, do we have wandering stars that appear to be circular? Yes, we do. But circles are not spheres. No one can determine whether or not the wandering stars, called planets, have any spherical nature to them. There's no measurement of sphericity of the planets as well.
And the sun?
The sun, it looks like a big circle. The moon looks like a big cookie. We don't have any dimension. We don't have any 3D measurements of the celestial objects. They look like circles.
And if I dig a hole in the ground deep enough, I can go to the other side?
Other side of what?
Of your planet, of Earth.
What planet? It's not a planet, it's a plane. We've already covered this. There's no Earth curve measurements.
Oh, okay, our plane. You can dig in it and reach the other side?
Do you think this is possible? So in Russia, they have this thing. So in Russia, they have this thing called the Super Deep Kona Borehole. Okay, so they decided to try and do this, see how far that they could dig. They used all the best equipment that they had at the time. I believe this was in the 80s. They dug down and they made it 8 miles. Now, 8 miles is pretty impressive, but in comparison to the radius of the supposed globe, it's nothing. It's a pinprick. So they made it 8 miles and they couldn't dig any further. Their equipment would not make it any farther than 8 miles. So as far as we know, the deepest hole on the Earth through the dirt is about as deep as the Mariana Trench in the ocean. So we didn't gain anything. We know how deep the Earth can be. It can be about 8 miles. After that, we don't know.
Nice.
Hey, bro.
Yep.
I was asking that we can see stars from Earth, right?
Yeah, we can see lights in the sky. Yeah.
Yeah. This is our far distance view of eye, right? It's too far. We can see things too far, right?
What do you mean we can see things too far? I don't know how far away the stars are.
Yeah, but we can see them. And they are far away from us, right?
How far away are the stars?
I mean, billions of light years.
Okay, how did you get that measurement?
It's a fact. I don't have to.
You're telling me it's a fact, but sorry, friend, you can't just tell me it's a fact. How was that measured? I actually know how that was calculated, but I know that you don't. So you think it's a fact, but you have no idea how they got that number.
Yeah, but my question is not how distant far is. I am asking something else. That if we can see a star, and I mean, we can see things that are far away from us, right? It's not near.
You don't have any idea of. Is it possible that those things that you see in the sky are just small and not that far away?
What do you think? How much far is star?
I have no idea. I don't know how I would be able to determine the distance to the stars.
Okay, tell me. if a car is moving on Earth, right? I have seen this, that if a train is moving on Earth and it keeps going far away from us, slowly it moves down the horizon. Why?
Yeah. Oh, you want to talk about things disappearing along the surface?
Yeah, that's what I was talking about.
Okay, so things disappear on the surface as they get farther away from you and they decrease in angular or apparent size. What is the point that you're trying to make? Eventually, they will get too small to see. There is a limitation to our eyes and even the optic that we would use, like a telescope. Everything has an angular size limit, which it can resolve. This is all due to the Rayleigh criteria, right? It has to do with angular size with distance or angular resolution. This is a well-known factor. It has nothing to do with the curvature of the Earth.
No. Hey, bro, listen to me. It's not with our far distance view of eye. This amount value is called far eye distant view. Okay, it's how much limit your eye can see far things. I'm not saying how clearly it can see, but how far it can see things. Okay, and it's too much that we can see stars. So why
Are you assuming that? Can I ask you just really quickly? Are you assuming that the stars are really, 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 really big suns, and that they're just really, really, really far away, and that's why they look small?
Yeah, I believe that.
Okay, so how big are the stars in actual size, and how did you measure that?
I don't know how I measure that, but I can learn it from you.
No, actually, the idea or the size of the stars themselves are, for the most part, arbitrary. Somebody just made up the size of the stars, and then they said they're so far away that they look really small. It's all just made up.
So what do you think? Stars are near us?
It's hard to say near. I mean, the stars actually do very interesting things. So from the surface of the Earth, we see the stars in the sky. As we increase in altitude, especially when you get up maybe, past 120,000 feet, you cannot see any stars in the sky. You can see the moon, you can see the sun, but then your relationship to those becomes more horizontal than it does vertical. So the stars almost seem to be an apparent phenomena, not necessarily a physical phenomenon.
Sorry, I don't get it. Stars are what?
An apparent or an optical phenomena. We don't actually have any physical proof of the stars. We can't touch them, we can't feel them, we can't measure them, and they seem to disappear after we gain altitude.
Okay.
Alien, I have a doubt. Alien, can you hear me?
Yeah, bro, I can hear you.
Who was talking? So you were not talking. Who was the one who was saying the Earth was flat and those things?
Brother, you're going to have to get closer to your microphone or something because we can't hear you.
Yeah.
Sounds like you're in a big empty room.
Yeah, your voice is not that clear.
Okay. Oh, it was yes. Hello?
Yeah, we still can't hear you, man. Not very well.
Oh, okay. Isn't the planet expanding though?
Bro, your voice is not clear.
I'm not going to engage with you until you fix your microphone situation because I really can't make out what you're saying.
Hello. Wait. Can you hear me now?
That's a little bit better.
Hi, yes. Isn't the universe expanding though? Then why does the redshift and other microwave radiation support those theories?
Yeah, there's theories. People have made stories up about redshift and an expanding universe, but they're just stories. Can you tell me who proved any of that and how they did it?
Okay. You asked me a simple question. Who proved what you said? Give me some evidence.
Who proved what I said? Everyone has measured the Earth to be flat. And by the way, if you're going to come at me with a lot of attitude, I'm just going to mute you and move on because I want to talk to people who are calm and not irate about a simple question. You understand?
Yes. Okay. I'll be. Microwave radiation has been proven. It has been measured. The light has been redshifting. So aren't these proven?
Right. So the background microwave radiation, I always get those words mixed up, but I know what you're talking about. Let's say that we have detected some kind of radiation or a background radiation. What does that have to do with the distance to the stars and the Earth having curvature?
You were talking about stars, right?
Yeah.
At the middle, you can see stars, such stars.
I'm sorry, I didn't hear that. You're still kind of muffled.
Oh, sorry. Okay, continue. You continue.
Okay.
You can do it though. Oh, yeah.
Let's pretend for the moment that we have some kind of cosmic microwave background radiation. Okay? If we experience some kind of radiation, what will that tell us about the distance to the stars? Nothing. We would have to have a lot of pre-assumptions to connect cosmic microwave background radiation, however you want to say it, to distance. And we can't do that. I think it's important for people to know that the idea, and that's all it is an idea or a concept of a globe Earth and the solar system, the heliocentric model, and the ever-expanding idea of the universe is all based on assumptions that are not proven. It is only conceptual. It does not exist in reality. In fact, basically all of it is based on a Earth with a sphere radius of 3,959 miles, which means the surface of the Earth would be curving at roughly 8 inches per mile squared. And there is no such curvature measured on the surface of the Earth. So if the Earth is not curving and it is not a sphere, then the entire concept of the globe, the solar system, heliocentrism, and the overall idea of the vacuum of outer space and an ever-expanding universe has been debunked. It is now just a fairy tale like Santa Claus, and for anyone to hold on to this idea of space Santa Claus would be a bad idea, in my opinion.
Hey, bro.
Hello.
Yep.
Hey, says who?
Hey.
You were talking about. Yeah. You continue.
Okay, hey, says who? I was asking that. What is the far distance view of human eye?
Well, it depends. It depends on the conditions. Wow, bro, can you interrupt? Friend, I don't need you with your bad microphone to be yelling at me things that I cannot understand and interjecting in the conversation when he asked me a question. He said, says who? He did not say your name. Please go on mute. So, what is the distance that the human eye can see? Well, it sort of depends. It depends on the day, right? So if the conditions are very good, the human eye can see for If we're talking about a very large object that doesn't have too small of an angular size, we can see, I don't know, 10, 20, 30 miles, maybe. It depends on what we're looking at. But beyond that, most things get too small to see.
Yeah, that's what I was saying. That if you stand on a flat plane surface, not flat plane surface, I mean if the ground is leveled, okay, if you are standing there and you see far and a car is moving and it will disappear down the horizon, because to me, as I consider Earth is sphere, so it moves down on the other side of the Earth. And at the same position, if there is a mountain in front of you, then you can see more far, okay? Because there is a mountain, there is a high level object, then you can see more distance instead of just 30 miles.
Okay.
What do you want to say about it?
So, I actually have an observation over land, right? Now, this is over land, mind you. Water is a much better gauge to see if the Earth is curving, because the water is supposed to be equidistant from the center of the sphere, meaning it's level and there's no obstructions, right? There's no terrain, there's no topography, hills, mountains, valleys. I should have corrected myself. I have an observation of 112 miles across the surface of the Earth at a mountain, a 14,000-foot mountain called Pikes Peak. No, Long's Peak. I digress. So I can see 112 miles, and that was on a good day. But you're talking about angular size, right? So why don't we use everyone's favorite, which is a ship on the ocean that disappears when it goes far away from you. You want to try that?
Yeah.
Okay, because that's usually everyone's best example. Water is the best way to test whether or not the Earth is curving, because water maintains its level, right?
Yeah.
Okay. So if the Earth is a sphere with a radius of 3,959 miles, this is the claimed size of the Earth, okay? This is the radius. Then every distance to the horizon, that being, the Earth curve or the sphere that you guys think is what the horizon is, then every distance to horizon cannot be any more than 1.22 times the square root of the observer's height in feet. So to make this very simple, if you are 1 foot off the surface of the water and you look out across the water, the farthest you will be able to see before the Earth curve begins to make things disappear bottom up would be 1.22 miles. If you are, let's say, 6 foot tall, then because you increase your elevation or your height, that will extend your ability to see a little bit farther around the supposed curve, and that'll be at about 3 miles. And as you increase in height, you can see farther and farther and farther over the supposed curve. But the curve itself has to maintain that ratio or that relationship, which is 1.22 times the square root of the observer's height in feet. Now, I'm going to post something in the side chat for you to look at, and we're going to see if that holds true. We're going to see if the horizon, which is supposed to be the Earth curve. Wow, are you still butting in? I don't understand. I don't understand why you're butting in with your terrible microphone while I'm trying to speak.
I just fixed it. Can you hear me now?
It's a little bit better, but right now I'm speaking to the other gentleman. So, in the side chat, there is an image. Oh my goodness, man.
Bro,
so in the side chat,
they can't help it, I guess.
I guess not. So in the side chat, if you have access to the text chat on the side of this particular page, or this channel, right? This channel's text chat.
Yeah.
48 minutes after the hour, you see a picture right there. This is a photograph. It's a still that we got from a video. I'll link the video if you want me to as well, so you can see that all of this is above the board. We're not lying. We're not fiddling with anything. This is just an observation with a video camera. This is off the coast of Santa Barbara, California. So these two oil rigs, the distance from the shoreline for both of them, the one on the right is 6.21 miles. The one on the left is 9.41 miles. The height of the camera, which makes this really easy, is 1 foot. So that means that things should start disappearing because of the horizon being the Earth curve. That should be happening at 1.22 miles. It's very simple. So can you tell me in this particular photograph where the horizon is? Is it before, in the middle of, or behind the oil rigs?
All right, I can't see it.
You can't see the horizon?
Yeah, I can see.
So you can't see the apparent location where the sky meets the sea?
No, I can't see.
Are you serious? Is anybody else having a hard time seeing the horizon in this photograph?
Hey, wait a second. Hey, bro.
Yeah?
You listening me?
I hear you.
Yeah, sorry. I was seeing it from other perspective. You are talking about front. If I see into the front view, that's what.
No, I'm asking you about where the horizon is in the photograph. Is it before or after the oil rigs?
I mean, I can see it straight.
I'm not asking whether or not it's straight. Where is it in relationship to the oil rigs?
After the oil rig.
Okay, so it's after the oil rigs. So on a sphere, the horizon should be at 1.22 miles. This horizon here is in excess of 10 miles. Why is the Earth curve not where it's supposed to be?
I mean, you can jiggle up the calculation, man.
I have the calculation. This is the globe claim. 1.22 times the square root of the observer's height in feet. Our observer is at 1 foot. The horizon, being the Earth curve sphere edge, should be at 1.22 miles. This one is beyond 10. So the Earth is not a sphere. The horizon is not Earth curve. You were lied to. I'm sorry.
Hello, bro. Earth is not a sphere. It is like a
Have you ever
cuboid
traveled
shape.
to space?
That's why you are getting a different calculation.
Hey, do you think this fella and I could actually have a conversation without somebody busting in here and going, hey, bro, the Earth is not flat, or it's not a sphere? Just let us speak.
Hey, says no. Hey, says who?
Yes.
Hey, I was asking that have you ever traveled to space or ever,
Wow.
glided?
Why are you asking me
Have you
this
ever rode a
question?
unicorn? Have you ever rode a unicorn while you were wearing a cowboy outfit?
No, I have ridden a horse, but not unicorn with a cowboy cat.
Bet you have, but you haven't rode a unicorn, so it doesn't count.
I have never seen a unicorn, man.
I've never seen space.
Tusif, you and I just had a conversation on the topic that you wanted to discuss, which was things disappearing in the distance behind a supposed sphere edge horizon. I went through this entire thing. I showed you that the horizon indeed is not Earth curve, and it does not match the geometry of the sphere that you think you live on. And then you instantly changed the subject and wanted to ask me if I've ever been to space, which is a silly question. Can you please deal with the thing that we were talking about?
Yeah, okay. You showed me the calculation, and I don't believe in it. That's it. That's how it is.
You don't believe in the calculation, so you don't think that you live on a sphere.
I think we live on a sphere.
Well, then how come the sphere is not evident? How come there is no measurements for Earth curve? How come the horizon is not the Earth curve edge?
Bro, can I ask something?
Okay.
Bro, last year, one ship circumferenced the whole Earth. Means the ship started from the east coast of America and After completing a whole circle, the ship arrived to the west coast of America. If Earth is
That's
flat, then how
fantastic.
this happened?
Wow, that's amazing.
Yeah, I know. Do you realize that circles are 2Ds? So if someone goes in a circle, especially when they keep the center point being north, if this is going to be your center point, and end up back where they started, the circle works just fine on a flat surface.
I posted it for him how you can go in a circle on a flat surface.
Means you want
Circles
to
do
say
not
that
equal
the
sphere.
Earth is flat but circular in nature.
Yeah, circles are not spheres. Circles do not necessitate a sphere. You're going to have to get that kind of into your head. You know what I mean?
Okay, tell me one thing. If Earth is flat, then humans must be living on one side of the flat surface. Then what happens to the other side of the man who lives on the other side of the flat surface?
Yeah, space is fake. You don't have to go on the other side. There's no other side.
Do you think that Earth is like a heads or tails on a
Bro,
coin?
every flat
I mean,
surface have two sides, na? Two faces. Every just like coins have two faces, head and
yeah,
tail. In the same way, if Earth is flat, then there will be two faces. On one faces humans live. Then who lives on the other
pirates,
face?
pirates. Relax.
The humans
Nobody
live
here.
on the heads. The humans live on the side with heads, and horses live on the tail side.
Yeah.
Who lives? Horse. Horse.
Unicorns. Horses.
Okay, unicorns lives. Ever someone will cross this line of head and tail?
You will. You're
Is
crossing
it
a line
possible?
now. You're starting to cross the line right now. The troll line.
No.
Yeah,
I am on the head side only. If ever I cross the line and go to the other side, I will definitely bring a
Oh
unicorn.
my goodness. Thank you for calling Microsoft. May I have your social security number?
May I ask a quick question? Who are we speaking to? What's his name?
Pirates.
Pirates. So did you, not 2 minutes ago, says who ran the math by you. Did you have any contention with those calculations?
Bro, actually I have not seen the calculation and I am not that much good in mathematics. Where is the calculation? Have you shared the picture in the chat?
Okay. So when he didn't put a specific calculation in the chat for you, but he did verbally run you through how something would be calculated.
Means that Pythagorean theorem you are talking about, the picture in which circle is made.
That's what I was going to ask you. So I posted that to further support what he was talking about. So if you have any contention or disagreement with or uncertainty as to how that was derived, those snapshots walk you through it.
Let me check, bro.
Okay.
Hello. Hey bro, how you come to that conclusion that OA is equal to OB plus H?
Sorry?
How you came to the conclusion that OA is equal to OB plus H?
Let's walk it.
From this we notice that OA is equal to OB plus H.
OH. Yeah, exactly, right? So the line from OB is the radius, right?
Okay.
And OH is an X is the line to equal to the radius plus some plus H.
Okay.
Right? Well, there you go.
Okay.
So they're equivalent in that sense, plus some excess.
Okay. Okay.
Just look at the image, right?
அதுதான் நான் சொல்றேன். என்ன மாதிரி பேசுறீங்க?
Get the definition of a tangent line.
I'm
if you want
defining the
to.
terms level line and horizontal line.
Yeah, horizontal line is still a straight line, even in the example that you're talking about, sir.
Yeah, horizontal.
Right.
They're saying that horizontal is your
It's
straight
just
flat
it's
line.
claiming that it's
the
okay,
second
sir,
red box
Let me
is
talk
because
now.
the
Let me
Earth is
talk now.
curved.
Stop. It seems like you interrupting me now. Let me talk
Stop,
now.
Stop me before I answer.
No, you
Go ahead,
interrupting me now.
Stop me before I answer you.
No, because I'm about to answer you. It's my turn to talk. Yes, even in the example and even in the definition that you showing us, that horizontal line is still the straight line. They call it a tangent line because at that point you still have that horizontal line. There's just something dangling beneath it, which is supposed to be curve or a circle. So that point, right, still has a horizontal line where you actually getting that measurement from. Now, you have the burden to prove that that very thing that you explaining to us right now, which will be a curved surface or a curved line, we already established that you can't get measurements with curved lines. You guys need tangents. So, still need a horizontal. Now you have to provide evidence that you have a surface or a radius value, which will be curved, right? Which will be a curved surface where the tangent line is actually needed. Or else the tangent line is not actually needed and it's running parallel to that surface in order for you to get ground positions. So if either one, that horizontal line is running parallel to its surface, you're looking at the line of sight is that vertical line of sight line is actually intersecting with the horizontal line, which you guys are calling tangents, or it is actually a tangent and you could show us that the earth is actually curving. Now, go back to back to what you're supposed to be explaining to Burton.
I'm
that you
politely
actually
waiting for when
have.
it's my time to.
Yes. Not yet. Now, back to what you supposed to be explaining. I gave you your little definition. Now you have to demonstrate the Earth surface actually having a radius value. Can't just say we just going to calculate it, because you just said that based upon this definition, you guys are actually taking measurements of Earth curve. Show us it.
Show us that deviation of the surface away from that horizontal that's being established.
Here it is. The horizontal line is the one that's being measured through the optics of the theodolite. That's true. It is a tangent, a perpendicular tangent off of the vertical of the point of the theodolite. That's the horizontal line. However, the surveyors are achieving level, which is different than horizontal. Level, as defined in this manual for the surveyors, is a line along which all points are the same height or altitude. Because the Earth is curved, level lines are also curved. So we're establishing horizontals, taking optical measurements with horizontal lines, and then applying the radius value curve correction formula to create level from horizontal.
You wouldn't need to.
You wouldn't need to if the Earth was flat.
Oh.
Magical nonsense.
You wouldn't need to if the Earth was flat.
Hey,
but
listen,
since
dude,
you do
would
need
just-
to,
you
the
would-
Earth is not flat.
Dude, you wouldn't need to correct anything. You'd just simply measure the curvature. You'd be measuring that the Earth's surface is deviating away at a curving rate away from that horizontal reference.
Yeah. And you actually getting you're getting your GP or your geographical positions on that tangent line. So
My point
again,
is that
sir,
you wouldn't need to
so
apply
again,
the
sir,
curve
you
correct.
so again, sir,
wouldn't-
the only one. So again, sir, only
You're
that
not- you're-
tangent
you're
line.
pivoting
also,
away from my argument. Pivoting away
so
from my
again, so again, only the tangent line is where you're getting these geographical positions or the ground position, right? Being connected from that vertical line, and your so-called level line is just based upon the calculation that you refuse to explain, or you refuse to give us a natural observation for, or even a measurement for. Right now, you're just telling us, oh, well, we actually need this tangent horizontal straight line in order for us to get ground positions for. But we do have a dangling Earth surface there. We call it a level line. Great, but you're still actually getting the measurements on the horizontal line, which is supposed to be perpendicular to the Earth's surface. And your corrections is based upon.
That's exactly my point.
Your correction is based upon a radius value that you refuse to validate.
It's validated through the test.
Right. So affirming the consequence again, right? Circular reasoning.
If I aim the gun the right way and I hit the target, then the gun was aimed. If
circular reasoning and logical fallacy.
Did you just try the Texas sharpshooter fallacy again? Well, I don't mean again. You know what the Texas sharpshooter fallacy is?
No.
You shoot your gun, and then you draw the bullseye around where the bullets are the closest together. Right, so you shoot the gun at the side of a barn, and wherever the bullets holes are closest together, that's where you draw your bullseye.
in the formula 4 plus x equals 6, what is x?
Who cares? Is this a math test?
Somebody's got to be able to figure that one out.
Yeah, I'll ask ChatGPT. Can we stay on topic?
4 plus x equals 6. What is x?
Who cares?
I do. That's what I'm asking.
Is it relevant to this?
Yes.
Actually, it'd be 10. You do it in your head.
10?
4 plus 6 equals x. X would be 10.
No, the question is 4 plus x equals 6. What is
2?
X? Thank you. Can it be anything other than 2?
No, but that's mathematics.
Right. Mathematics. Kind of rigid.
Yeah, it is, but
So
we're
we
not
just
dealing
pro-
with straight arithmetic.
So we can prove what x is. Can we not?
Yeah, well, I mean, given axioms, right? So we start a mathematical system with some given axioms. So we could make mathematical systems where, that's not true. And we could do operations based upon that not being true. And deductively, right? I'll give you an example. Okay, this is the best way to do it. But I'm gonna use logic. Now, for a conclusion to be true, it has to have 2 true premises, right? So I could say Aristotle's all men are immortal. Aristotle's a man, therefore Aristotle is immortal. That would actually be a deductively true statement, but it's not true in reality. So you can make deductively true statements with mathematics that are not true in reality.
We started with a false premise there that all men are immortal, right?
Yeah, exactly. It's not a true premise.
But my premise is a true premise, which is that these civil engineers that are leveling the ground, they are coming up with level surfaces.
Well, I mean, technically the level line, right, is only level at the point of the measurement. That's what it says in surveying. It's only valid at the point of the instrument.
Right.
Yeah, and nowhere else. Can't extrapolate it out.
So when they want to make something that's perfectly flat and they factor in an R value in their calculation to do that, that proves the R value was correct. If they end up with a true flat surface and they factored in the radius, then the radius factor was correct.
I mean, what flat surface are we talking about?
Okay, if you want me to prove one, I can do that.
No, I'm asking you. Well, first of all, you couldn't possibly prove it because they'd be using spherical geometry and straight lines can't even be expressed. So I don't even know how that would even work.
Well, then it's of no use to ask me for an example. Then,
Because spherical geometry is non-Euclidean, so like straight lines can't be expressed because one of the axioms is that there's no straight lines. So saying, hey, there's something straight or flat in spherical geometry, it's nonsensical. It's incoherent.
Well, I'm talking about Euclidean geometry. I'm talking about flat. If you want to make a flat surface over a curved level surface, right?
I mean, if the way human beings make a flat surface in reality is we use a level, right?
Well, I mean, what kind of level? A spirit level?
Yeah, they make all different sizes. We would use that, or we would do leapfrog trigonometric height. We would do leapfrog trigonometric heighting, which is a surveying technique where you just leapfrog over heights.
But even a spirit level, it relies on a curved piece of glass.
What does that matter? Not necessarily, because some theodolites. Well, I mean, spirit levels, yes, they use the curved piece of glass, and they used to use mineral spirits, but it's a different type of fluid now. But so check this out. As you know, there's different size spirit levels, right? There's little torpedo levels, the 6-inch levels, 24-inch levels, 4-foot levels, 10-foot levels. But you can use each one of these, right? And they're all not going to indicate the same level. Now, the idea that you can take a theodolite and like level out to fucking a mile or 2 miles or 10 miles with a little bubble level inside your theodolite is absurd on its face. That's why they say in surveying, the level, it's only level at the point of the instrument. They say this in the field itself.
Right. Well, no, the horizontal.
That horizontal level line.
Wait, you're conflating horizontal and level.
That runs through the theodolite. It's 90 degrees from plumb, but they also say plumb line's curved, so plumb isn't even perpendicular to the surface of the Earth. So what are we
Who
even
says
talking
plumb
about?
line is curved?
Geodetic surveying.
Oh, I'm not familiar with that.
Oh yeah.
Are you familiar with the Laser Interferometer Gravitational Wave Observatory called LIGO?
LIGO, yes.
Interferometry. Interferometer.
Right. Right. Should they shoot lasers and they test the interference patterns in the lasers and they're looking for gravitational waves? And what I found
Yeah,
is
I'm
that,
familiar with it. I'm very familiar with it.
okay, cool. So then you're probably
I'm
familiar.
more familiar with it than you are.
So you're familiar with.
I'm not trying to brag. I'm just saying I'm very, very familiar with it. I know exactly what they did. I know exactly their technique. I know how many times they had to survey the frickin' place. I know what the addendum frickin' documents say. After the fact, after they surveyed it and everything was fucking wrong, they had to go back after they hired 2 more fucking survey people, and then they issued another fucking addendum document, right, where they had somebody review all this shit. Yeah, so the surveying.
You're talking about the construction?
Yeah, the construction of the LIGO was problematic, to say the least. And I also have the civil surveying diagrams, the ones that are filed with I don't know if it's a township or a municipality, wherever they have civil engineering diagrams. It actually shows that it's concave, which is crazy.
It's concave?
Concave, yeah.
The tunnel that they shoot that laser down?
Yeah, so they have their elevations, right? They have the civil engineering is like the blueprint, right? So the blueprint it's on a piece of paper, right? So the lines going across the piece of paper are just like in Cartesian coordinates, and it has the distances and the heights above sea level. And then if you follow the profile of the LIGO instrument, it dips down and then dips back up. So it's actually concave. I could show it to you if I could find it. Hold on a second.
Yeah, I'd like to see that.
They had all sorts of problems surveying their shit. I think they ended up using like a custom geoid or something. They did the same thing at CERN. They also did the same thing at the Proton Accelerator in Japan. So, with all due respect, right? So, this isn't like the first time many of us have heard this. Like, we've been hearing about LIGO and fucking neutrinos and everything going back 5-6 years. So we're well familiar. I mean, some of us haven't been around as long as others. But this is something that was brought up a lot in the past.
So if I understand right, so I'm under the impression that being that they needed a flat level surface for 4 kilometers in the construction of that
within a tolerance.
vacuum tube. Yeah, because there's almost like a meter of deviation, supposedly because of the Earth's curve, right? That they had to accommodate for.
No, they have a tolerance where the beam has to be so far away from the sides of the instrument, the sides of the vacuum tube.
Right.
Hold on, when I find the document.
They also had to hit the reflecting surface at the end, and it had to be at the correct height, 4 kilometers away. So the construction of this vacuum tube tunnel had to be straight, not swirly, curvy, and also at the right elevation at the end. But it turns out that the elevation at the one end is a meter higher than the elevation at the start.
Yeah, and the elevation in the center is lower than the end. So, I mean, what are you telling me?
Yeah, I haven't come across that. That's interesting. Yeah, if you could show me that.
Yeah, I have to find it. I got a lot of shit on freaking LIGO. Because people bring it up for all different reasons, right? Say, for gravity waves, true gravity, and all that shit, right? So that's one thing that people bring up. And then there's the survey, then there's the instrument itself. God damn it, I got a lot of shit on this. Then there's the instrument itself, like how it was surveyed. So I got stuff on that, so it's a bitch to find, so give me a second. I mean, you can keep talking. This is going to take a minute. I have to go through like shitloads of stuff.
All right. Well, hey, if I can find out from you that surveyors don't know what they're doing and their shit's all whack, that would be news to me. That their science is just garbage.
Why do you have to bracket and don't know what they're doing?
Yeah, who said that?
Yeah, like, the doctors know what they're doing. We call medicine an art. Okay, so things are more of an art than a science, right? So we have science, which is an idealized way we think the world works, but when we go out into the world, it don't work that way, right? So we have to fudge shit to get it to work, get it to match reality. We do this all the time. I don't know why this is like mysterious. Like, we do this all the time. It's literally called engineering.
It's good hearing you in here, Indio.
Hi, Flatsy. How are you?
Good. How are you doing? You have good time with family?
Oh yeah.
Good.
I'm a granddaddy, so I got to see my grandson.
All right. Yeah, we got to see a lot of.
He's like
our
9 months or something.
Awesome.
Let's say it again.
We got to see a lot of our friends and family and loved ones and all that. That really covers it. We got to see a lot of loved ones. Not everybody, but a good portion of it. So the kids had a good time.
Darn it.
I don't mean. Well, I guess it is. I guess while we're pulling that up, could we entertain the idea? Like, I'm interested. I'm of the understanding. You can set me wrong. Are we back to the drawing board on like some sort of model or representation for where the sun is and what it's doing after the Antarctica thing?
How do you think the globe does it? Can I ask you that? You think they take a 3D globe and then they model it all out like that?
I don't understand the question really.
How do you think where the sun position is? Say what sunrise time is, solar noon, sunrise, sunset, where it is, the angle, the azimuth, and elevation angle, right? How do you think that gets predicted now? Like if you go on Time and Date or SunCalc or the U.S. Naval Observatory, and you get sunrise, sunset time. How do you think what model do they use to give you that information?
I see. Like I think you might think I'm asking you a different question. So my question is more like, what do you think's going on? I don't mean like model that you're going to use to predict time and stuff. I'm just saying like one explanation. I mean, it used to be, as far as I understand it, is that there's no 24-hour sun in Antarctica because that wouldn't work on our concept of what the flat Earth is.
Well, I mean,
do we have a new concept that we're working on, or?
So the thing with the 24-hour sun, everyone conceded that there was 24 hours a day. Like the problem with 24-hour sun is we had 5 cooked videos, and what are we supposed to go by? And you had testimonies of like Amundsen, so he wrote in his notebooks the entire time he was stranded there that he didn't see the sun the entire time except for one day. Yeah, so that's what Amundsen wrote in his notebooks. He wrote that his whole crew was going fucking crazy because it was daylight all the time, but they never saw the sun except for one single day. And when the sun came out, everybody cheered, and it's like they had a party. That's what he wrote in like his blogs of his experience there. So what are we supposed to say? We're supposed to just go, oh yeah, there's a 24-hour sun because what?
Okay, well that's fair. If you were just like doubting, right. So we lacked information, but what I also have heard for a long time is that there can't be a 24-hour sun down there because of our concept of what the sun's doing. And I've heard people saying, yeah, if it turned out that there was a 24-hour sun, that'd be a big problem for us.
I don't think it's a problem.
So that's what I'm asking. It's like
because whatever the sun is in relation to the Earth is an inference, right? And whatever you make of it, it's going to be theory laden, right? It's going to be laden with theories about what the sun is relative to the Earth, how the light rays reach you, yada, yada, yada. It's laden with theory. So it's really not a problem. It's not a problem at all.
What about over there versus under? You said under the sun under. What if the sun's not under? And that's our whole point. And it's not under anything at all. It's over that way for whatever time. Yeah.
Yeah, so theory, right? So the globe theory is like, all right, the globe theory goes like, well, this is why we can see the 24-hour sun in Antarctica. And then I'm like, well, what's your theory why you can see it?
Yeah, that's the funny thing is that's why I brought this up is because they don't use the globe model to even predict it if that happens.
Exactly.
They use something called the equation of time, and it's referential only to the sky. It has nothing to do. It's observer dependent, meaning you could be on the back of a fucking a rabbit. It doesn't matter what you're on, because it's completely from the view of the observer. Wherever the celestial equator is, if you know the time of the year. You know the time of day, you can predict where the sun's going to be relative to the celestial equator. Has nothing, you could be on top of anything. Doesn't matter what you're on.
No, but I'm not asking about like the time. I'm saying just like why.
Well, you said the globe has an explanation, dude. You don't have any, like, then why don't you predict where the sun is?
No,
With it. Why don't you use that to predict the sun?
No,
then why don't you use that to predict the sun location?
Hold on. I'm saying it has an explanation for why you're able to see the sun over your head for 24 hours.
Yeah, but it's just okay.
Well, so what's your explanation?
The story is that I listen. First of all, I don't care about abductive logic. So abductive logic is for frickin' midwits, dude. Like seriously, that's how I feel.
So
Abductive logic, the best explanation based upon the evidence we have. That's more of a statement about human psychology than it is truth, right? So, what's your explanation? What good is an explanation if your explanation is non-scientific?
So, explanation.
Do you think that? Well, I mean, I could make some shit up. Would you be happy with that? Have you seen the physical demonstration of somebody doing it? Have you seen that? I'm sure you've seen frickin' Sacred post it.
Posting what?
Someone took a light in like a glass, I think it was a half silver mirror or something, and
oh yeah. Super fluid in the ceiling.
No, he didn't use super fluid in the ceiling. He used like a glass, or I don't know if it was a mirrored dome or a semi-mirrored dome.
Right, I heard him say that represents potentially some superfluid up in the top of the dome.
Well, I mean, I don't know. I mean, would that make you happy if we said superfluid? I mean,
no, that's just what he said.
I don't know what his thing is. The point is that they've demonstrated this in a physical demonstration. Now we could say, oh, look, dude, it matches like the observation, so this must be physically real, but that would be based with bullshit, right? And it's the same thing of saying, yes, the globe must be physically real because it matches some explanation that the globe gets. The point is, though, is that you have an explanation, but it's not a scientific explanation because you don't even use it, the so-called explanation, to model where the sun is in the first place.
No, I totally agree with you that it doesn't prove the globe.
Do you understand what I'm saying? You have the model you use is not a globe model.
The model we use is not a globe model.
Did you not hear the whole thing about the equation of time that I just told you? It's observer dependent.
Yeah, but because you're pivoting to the category of time prediction.
No, azimuth and elevation angle of the sun. The azimuth is the direction the sun would be relative to you, and how that in the elevation angle, the elevation would be how high it is above the horizon.
And we can't determine that using the globe?
I mean, maybe you can, but the way you do it now, by type, like I said, how did MC Toon or frickin' Duffy or any of the, how did they figure out that the sun was supposed to be up 24 hours a day? And what angle it was supposed to be above the horizon? They went to time and date and they typed in the location. But time and date uses this thing called the equation of time. In the mathematics, if you look at them, there's no globe in those.
But isn't that just for convenience?
Yeah. What do you mean for convenience? It's not because it's the spatial reference is the celestial sphere. It is only relative to the celestial sphere, where you are relative to the celestial equator. Where's the celestial equator in the sky? That's it. That's all of it.
Right, but that's the celestial sphere.
So you think
It's a sphere.
You're trying to take the celestial sphere and turn it into a physical ground sphere.
No, I'm not saying it proves the physical ground. No, I'm not saying that. But I'm saying we do call it a sphere because that's the way it appears.
And to a degree,
it appears.
If you cherry pick and you ignore things.
But my question is, like, I've been interacting with flat earthers and I ask them a thing like, well, where does the sun go at night? And they say it goes away. And I go, away where? And they go, it goes away in a circle like a clock around in the sky. And then I go, okay,
well, I mean,
is there a 24-hour sun in Antarctica? And they go, no, it can't be.
I get it, dude. Okay. Sun doesn't have a true spatial position. And you're not going to like this. Okay. But you have to like it because it's part of the globe model. So if you look at the sun, right? Say it's say you're in New York City, right? And it's freaking noon. If you look at the sun, and then somebody's on the Mississippi River, and they look at the sun, and somebody's in Florida, and they look at the sun, and you're all looking at the sun at the same time. If we drew lines of sight intersecting your lines of sight, they would not intersect the sun. You would all see the sun in a spatial position that's not common to all of you. And this has literally been demonstrated over and over again, and it's part of the globe model. So when you say, where's the sun? Okay. Yeah, it depends on where you're at. The sun has where it appears to be. You see an apparent sun, but you don't see, like, it's not an object like that. Right? It's not like looking at a building that's 20 miles away. Everybody's looking at the building. Sun isn't like that. And you can take the same time and date, right? And if you take time and date, and people have done this. They've done it in AutoCAD. They've done it in Blender. You take the same time, right? Same time of day. You map onto a globe the azimuth and elevation angles, and you try to intersect them, the lines of sight, right? Based upon the azimuth and elevation angles. I see the sun here. This guy's angle to the sun is there. This person's angle to the sun is there. Where do those intersect somewhere in space? They don't. And the more pieces you add, the more observers you add, the worse it gets. Now, this is why they say this. When you said, "Hey, it looks like a celestial sphere," that's why I said, "Yeah, kind of, but not really." They only do observations of the sky where it follows this celestial sphere. Is from 30 degrees below to the horizon. They won't do any measurements. So for celestial navigation, for astronomy, for anything, because things are displaced relative to the so-called celestial sphere. Above that, up to 80 or 70 degrees, from 70 to 90, they won't do any observations either. So it's really just like a ring in the sky. If you want to keep for real, I'm talking about practical use. I'm not talking about theoretical. I'm talking about when people go out, astronomers, navigators, when they go out and they actually do an observation, they don't do any observations below 30 degrees, and they don't do any above 70 degrees. When I say 70, from 70 to zenith, right? And the reason is because they can't get accurate measurements. There's problems. So when people say celestial sphere, in practical terms, it's really just a ring of the sky, where this so-called linear relationship to the surface of the Earth, this distance linear relationship with angles applies, but I don't even know if that's true because I've never actually seen any verification of that. But that's a long way of saying that everything in the sky has an apparent position, including the sun. When we say the sun goes away, that just means, yes, from your viewpoint, you see the sun move away. And then there's somebody else west of you where they can see the sun and it has a position. But someone's west of you and you see the sun and they see the sun and you try to intersect the lines of sight, you're not looking at the same place. And I know I bet you that's very hard to accept. But if I told you, you're not looking at the sun because light takes 8 minutes to get here, you'd be like, no problem. And if I told you, well, when you see the sunset, it's actually being refracted up over the horizon and the sun's already under the horizon, but you see it, you'd have no problem with that. You have no problem. I mean, maybe I don't know you good enough to. I'm just saying, Globers, if a flat earther says, yes, there's an apparent sun, that's a bunch of flat earth bullshit. But when we tell them about their apparent sun, all of a sudden there's no problem. The sun's in an apparent position, dude. It's not in a true position. It's apparent. So when you say where does the
Right.
sun go, it moves away from your viewpoint, but it's not like it's a physical object like a bowling ball rolling away.
What is it?
Fuck if I know. That's debatable,
$1
man.
million question.
Got it.
I mean,
So,
there's one theory
do
is
we
that
have
it's metallic fucking hydrogen. That was the prevailing theory, is that the sun was condensed matter. That was the prevailing theory until to the end of the 1800s.
So
what's
but I'm
weird
still-
about the sun? Oh, sorry, my bad.
Yeah, I was going to follow up with a question though about the Antarctica thing. Like, so my understanding is that basically, like when it was noon in Australia, they still had the sun overhead, apparent sun overhead in Antarctica, which was basically the south tip of South America, on the opposite side of the flat Earth. So, what's our? Do we have any? Have we made any ground toward explaining that?
I mean, we could just say the sun rays freaking reflected off the dome and bent around shit. I mean, we could make some shit up. Would that make you feel better?
Yeah. I mean, but
What good is the expert? And we could affirm the consequence,
we
right?
could start trying.
We could say the sunlight reflects off the dome to the other side of the flat Earth, and we'll see a 24-hour sun. We see a 24-hour sun, therefore the sun reflects off the dome, and it's a flat Earth. We could just do the same stuff you do. We could affirm the consequent, make all sorts of silly statements, but I hate to say this, we're not like you guys. We don't affirm the consequent. You know what affirm the consequent is, right?
Yeah,
P, then Q, therefore P.
Yep.
So
we were deep in
yeah,
that
so
in
I
the-
mean,
right.
yeah, so I mean, that's the problem with induction.
You know what?
Is that any inductive statement, period, any statement that uses inductive logic affirms the consequent.
Well, then why do you
As
say the
such-
Earth's flat? Then why do you say the Earth's flat?
Because we can measure it directly. We don't have to use induction. We can use deduction.
In what
Because
way
we can
did you measure
directly
it?
compare it to things.
Physical, empirical, touchable,
Physical.
tangible.
Like
not
what?
just math.
Such as?
No, so listen, okay. You look at the sun, you draw conclusions about things that are not the sun. Those conclusions have to be an inference because it is indirect, right? Look at the sun, draw conclusions about the earth. It's like trying to figure out what your house is built out of because you can see through the peephole door and you can see what all the other houses in your neighborhood are built out of, right? And going,
I get it,
well,
I
they're
get it, I
all
get it. But
brick,
what's-
so maybe I live in a brick house,
I
right?
get it,
You
but
see what I'm saying?
Yeah. But what about yours? Like, so what's different about your claim? How do you prove that the Earth's flat?
It's the only one like it.
Directly.
Can you show it to me? How do you prove it?
You have to directly measure it.
And who did that?
Dude, like, I mean,
Every
there's up to
surveyor
a million
ever.
fucking laser tests.
Every person ever who ever measures the earth measures it on a horizontal.
Yeah, there's up to, like, I mean, I don't know how many you need, right? So there's
what's-
over land, over water,
Yeah, what are-
microwave, radio waves, like
So
you
the-
name it. There's all sorts of.
So how does the argument go with the laser test? If laser does this, then Earth is flat. And then it does it.
No. You measure the distance between the laser and the surface of the Earth, and if it doesn't, and if it's in parallel to a degree, obviously it's not going to be perfectly parallel because we don't have infinite measurement precision, right? To within a degree, right? So within some degree of certainty, you can say, hey, the laser does not deviate from the surface of the Earth at a rate of curvature as predicted, right?
Therefore,
Yeah, therefore, it can't be curving at the rate it's predicted, right?
isn't that
But there's a
affirmative
whole bunch
consequence?
of other consequences that are necessary consequences to that. Because
Wasn't
if it
that an
isn't
affirming
curving, at the,
consequence?
if it,
Did you do the same thing?
No, it's not. Because you're doing a direct comparison of one thing to another. We're comparing the laser with the Earth, and then we're
Uh-huh.
measuring the distance between them.
And
Right, so we're
because-
doing a direct comparison. It's not. We don't have to go. We don't have to go like.
Do lasers always shoot straight?
Generally, yes. I mean, there's certain conditions where you can make it not shoot straight.
Such as when they.
I mean, you can shine it through frickin' glass or water or sugar water, or you can fucking shine it through CO2, butane,
or through what about atmospheric layers?
Yeah, but you can control for that. So you can measure the weather. And you can do other things, right? So you can measure varying distances, right? You do more than one measurement. And then you go repeat the measurement. Right? So the chances of you going on 2 different days, like say you randomly pick 2 days, like 3 weeks apart.
Can you show me some of these
and
tests?
the weather conditions are identical to get the exact same experimental result of refraction, right? That's a refraction beam. But the thing is, there's no basis for refracted laser beams anyway, in normal conditions, and that has been experimentally verified.
Can you show me some of this?
Yeah. Hold on. I couldn't find that fucking logo thing. I know where it's posted, but it'll take me forever to find it.
Because that sounds like if P then Q, Q then P.
No. We're just doing a direct comparison. It's more like if A equals B and B equals C, then A also equals C.
I wish you were here earlier because that's exactly the formula I set up, and they called it A affirming the consequent over and over.
No, that would be an identity.
No, you didn't. What he's explaining is a modus tollens. I don't know why you're trying to compare its difference. He's measuring the Earth directly. You coming up with a calculation without validating it to be true first.
Molin's tollens?
There's one, man.
What's Molin's tollens?
It's a form of a deductive argument.
You got to study these arguments, bro.
I just don't know if I heard the words right. Molin's tollens?
Modus tollens.
Yeah, modus tollens, yep.
Yeah, but it's not the same thing. If P, then Q. If not Q, then not P.
Right. When it's indirect. So if it's indirect or it's not validated, then you using something that is not indirect. In your example, you was begging the question actually. So it's actually you was begging the question fallacy, and you was trying to confirm it due to an observation for it to be true, which was indirect to the point because you haven't actually validated your premise to be true in the first place. So it was circular reasoning what you was using. And his point that he's using, he's actually coming up with a test based upon something that is directly to his premise. So he's not assuming that his premise is true. He's actually trying to test it directly, where he's forming a modus tollens, or modus, whatever you want to call it. So basically, he's testing it without assumptions at all. It's not like, well, this is my base premise, and I'm assuming that it's all really true, or it's a calculation I haven't validated. He's actually validating it through direct measurements with a laser test, where you just using the calculations and then you saying, well, if the calculation work, then therefore it is true. So that's the difference between a modus tollens and begging the question or affirming the consequence fallacy. Your argument, or if you want to say if somebody else's argument is indirect and his is direct.
So I posted 2 laser tests. These are like 30 miles. And so they're multiple tests. It's not like they just went out once, shined a laser, and was like, hey, go victory. No, multiple tests. So the one that was done at Lake Esalis's greatest laser experiment, that's 5 tests, 2, then 3 weeks apart. They brought meteorological stations, whatever. So they did this test. They shine the laser, starts at 10 feet. They pick it up at 4 feet. Okay. Now they should only be able to pick it up if they were on top of a 40-story building. Even if there was refraction, that would only, so-called standard refraction, right? That would only bring it down 5 meters. That would only, in case you didn't hear me, that would only bring it down 5 meters. So they should see it at 127 meters. Standard refraction would bring that value down to 122 meters, but they picked it up at 1.5 meters. This is like 2 orders of magnitude difference. The other one was done over Salt Lake, and this one is just fucking crazy because what they did was they kept getting further and further away from each other successively, right? So like they went like 11, and the other ones too. The other ones are multiple distances with a horizontal pin, but this is like they actually like, okay, we picked you up at 11 miles, we picked you up at 20 miles, we picked you up at 30 miles, and then they started doing variations where they were like 30 miles away, driving across the fucking desert, watching the fucking light go sideways, right, going from like left to right across their field of view, 30 miles away. But 30 miles away is like, it's supposed to be like 600 feet under the curve of the earth. This is like hundreds of feet. It's not like a little bit. Okay, so these results are orders of magnitude different than the prediction. Now, someone might come along, well, you didn't control for a variable. You can't say the laser was straight. So it's actually, you don't really know. But there's no evidence available anywhere that shows that lasers or any other light gets refracted at all. It's just something, it's an ad hoc hypothesis so that the globe can't be falsified. That is literally what it is.
We watch rainbows refract. Yeah, we can watch rainbows refract in the daytime, and nothing matches that rainbow. Is the rainbow the measurement of the Earth? No. Light refracting at the rate of a curve. It doesn't happen. Look at a rainbow. I'm just telling you, brother. The fucking curve's right in front of you. That's not the curve of Earth. Earth's not curving. That rainbow's based on a horizontal. And some of the rainbows are circle.
Yeah, look, just
standard refraction requires R. They don't have it. Sorry.
Yeah,
and I mean,
well, yeah, that's also circular logic or spherical logic, infinite circles.
Yeah, but they don't have the radius value of Earth, so how are they going to claim it for their refraction values?
Exactly.
I mean, that's actually whistling past the graveyard. How can they even demonstrate refraction exists at all? Right. So that is really the elephant in the room. How,
according to Snell's law,
evidence that it exists?
Two mediums and a hard boundary.
Yeah. It's supposed to be a well-defined boundary. Like what's the evidence that exists at all? And what is the evidence that's out there right now, right? If you go through the academic literature, there's no evidence for it. The academic literature basically says, yeah, we tried to model it, we can't do it. Right? And so we did some laser tests, and then because there's other phenomenon, right? If things were being refracted, that we would see this phenomenon called dispersion. You see it in astronomy. They actually make correctors, dispersion correctors for telescopes. They make those, but you never see this long distance observation, Mount Canigou is being refracted 2 miles up over the horizon. Well, why don't we see any of these dispersion effects? Why don't we see magnification effects? Why don't we see not magnification, but it actually appearing smaller because the optical path length is longer, right? So think about this. If you have something far away in a distance and you have a straight line to it, if it has to take a curved line to you for you to see it, it's going to appear farther away because the optical path is longer. Why don't these things appear farther away? Why don't, when they go up on top of Canigou, make a 275-mile observation where there's supposed to be all this refraction and curving light, right? How come it doesn't look like it's 300 miles?
It would
that's what it should look like. Well, that's what it should look like because the optical path. We judge distance based upon
at 100.
What is the length of the optical path? That's how we actually judge distance. And there's distance cues, but if the optical path length was longer, it would appear farther away than it really is. And there's dispersion. Dispersion is really the elephant in the room because this is how a prism works. This is how Demock's rainbow works, right? Is fucking rainbow in the sky. Because when the white light goes in, each wavelength has a different path that it takes, and it gets spread out in space and you have red here, blue here, green here, orange here, red, purple there. If we're getting these weird refractive effects, why don't we ever observe this? Why don't I look at, like, like I said, Canigoo, and it's blue on top and red on the bottom, like we do when we see dispersion of celestial objects? We've never observed this. And one of the Canigoo images is taken with an apochromatic telescope. That means the telescope has a dispersion corrector in it. So if say you saw dispersion, right? It can't be from the telescope because the telescope is dispersion corrected. It would have to be out in the environment where it's happening. But we don't see that happening. We don't see it out in the environment. There's no dispersion in any of the images. So we don't have to just rely on, well, our theory says that there's a spherically symmetrical temperature gradient and density gradient, so the rays of light have to curve. Well, yeah, dude, it wouldn't matter what your model is. It doesn't matter. Eventually, whatever theory you have or hypothesis, you actually have to demonstrate it with an experiment. You have to test it in the real world and retrieve the empirical data to validate whatever model you have. And that's the rub, because there is no empirical data. That shit's getting bent up over a curve of the earth. None whatsoever. Not even a single thread iota of it. Sorry about the rant, dude, but I hate having to beat this fucking topic over and over and over again because someone says the fucking magic word refraction. Like, dude, it's annoying because I know that there's nothing to it. It's really just fucking hollow.
Yeah, but when something becomes refracted, that means it's no longer physical.
True. Yeah, then everything becomes apparent, and you just throw out geometry, and you really can't make any geometric claims at that point.
I guess that's my point, is that you're having an apparent light that you're receiving at the end of the laser test.
Yeah.
I'm not saying that.
That seems redundant.
But I mean, if I ask for well, how do you know that where's flat? And you throw lasers at me, it's like, okay, so you have an apparent light position.
I'm not saying the laser's being refracted.
Well, since that's a possibility, how are we not doing an affirming consequent when we appeal to the laser?
So you're claiming that entire laser beam is being refracted up, and that laser beam is
Here's the thing, right? I guess it's annoying for us because you know what it really is when you boil all of this down. Flat earthers are just trying to chase down the claims of globers, and every time they're proven to be false, there's some ad hoc explanation that somehow flips the burden back onto us. For example, hey, the horizon is Earth curve. Oh, is it 1.2 times the square root of the observer's height in feet? That's where it'll be, eh? No, incorrect. It's not going to be a tangent to the point of the ball, right? Which would be marked with an X, labeled the horizon on all of the EDU websites that I can find. Okay? So since it's not that, even though that is the claim, what are we really talking about? You have no claim. Why are we talking about refraction? What do we need to? It was your.
Well, he asked for the evidence. He asked for the evidence that the Earth was flat. Like, what's our argument? And I said, hey, we can measure the height of a laser above the surface of water, and we don't have to assume anything, right? Because we can just take a tape measure, right? We can just say, hey, the laser's this high here, the laser's this high over there. And his argument is, well, refraction can confound the results. Yeah, but how much? We're talking about differences. Well, hold on. We're talking about differences of 2 orders of magnitude. We're not talking about a small difference in the experimental.
That's where we get on the back foot. Like the burden is on us for some reason. Again, if he wants to know about refraction, the bottom line is people who believe in the globe took flat earthers to the beach to point out how laser tests would prove that there would be 8 inches per mile squared. What are we talking about?
All the calculations for refraction are based off of Snell's law, And when you're looking at a distance over the water, like for instance, the Black Swan oil rigs, how sometimes they play peekaboo over the geometric horizon because when they say that, they're claiming those oil rigs aren't physical. They're mirages moving upward. All that is based off Snell's law, but the thing is, they're missing a component to Snell's law, which is the boundary. There's no boundary separating two mediums.
Well, you just contradicted yourself because it's not based off of Snell's law. But I get what you're saying.
It's refraction. Refraction. Snell's law is the law of refraction. So therefore, what they're claiming has to be based off of Snell's law, and it's taking little chunks and pieces and skipping over everything else and added an artificial radius value that has not yet been shown because it's not possible.
Okay, so let me just chime in on it. It's not based on Snell's law, and it is. It is based on the radius value, and it's not. It is based on Fermat's principle, and it's not. It is based on, like, it depends on who you talk to. Depends on which globe earther you talk to that's going to come up with their version of the ad hoc excuse. That shows you that it is an ad hoc excuse is because there's no uniformity in what the excuse even is. And if you ask them for the evidence, they can't point to where that evidence is. They'll point to you to a theoretical fucking a website that sells, light bends shit over the curve of the earth. Like, no, I want data that demonstrates it. You'll never get that. Ever, ever, ever. You'll never get one itty bitty bit of data, actual data where they tested it in verified the model or whatever it is they're saying, Snell's law, fucking R, 76R or whatever. There's no experimental data because science is supposed to be empirical. That's what I thought. It's supposed to be based on empirical tests. Where's the empirical tests? That's all. That is really what the bottom line is.
Right, but claiming something is refraction, but then saying it has nothing to do with Snell's law, that's like talking about entropy and then claiming it has nothing to do with the second law of thermodynamics. You can't separate entropy from the second law of thermodynamics because the second law of thermodynamics is the law of entropy. Like the same thing with refraction. Refraction, it's Snell's law of refraction. So anything that is claimed to be refraction has to follow Snell's law, and it's missing the main thing, which is a boundary between two mediums. But they
use multiple models. That's what the point I was getting at is they use multiple, depending on the globe earth that you're talking to.
Right.
So as far as refraction goes, we use a bunch of different models for refraction. Just period. Right? So there's the ray optic model, there's the wave model, you can even have a photon model, there's a quantum mechanical model, there's the Fermat's principle model, there's Fresnel's model, so there's a whole bunch of mathematical models. They're all used for different purposes depending on whatever the application is, you'd use a particular model. Now, I understand what you're saying, hey, you can't have refraction without Snell's law, but that's just one model. That won't cover what's called a gradient indexed medium, right? So there's a gradient that would slowly taper off. The model they use is called the principle of least time. That's what they would use, and it's actually Snell's law is actually a special case of that. So you can come up with a model of a gradient index material, but if you actually look into what would you call it? Condensed matter physics, where they try to actually make these in practice. It's fucking I wouldn't say impossible. They can make them, but they can't make them in bulk, right? So they can make a one-off because they have to use fucking fluorine fucking doped glass, right? That has 10 fluorine atoms in this freaking strand of it, and 9 in this one, and 8 in this one, and you know what I mean? They're super hard to manufacture. But these guys are oh, this is how it happens all the time. I just don't. There's just no evidence for that shit. But listen. I understand what you're saying. But as far as depending on what Goldberg, because they use, I'm sure you heard 76R, right? They use that because they can't, because they don't have a model. That's why they use it. It's just like a fudge. Oh, we'll just say the Earth is freaking, 16% bigger. Call it a day. That's literally what they do when they do the 76R.
Snell's law is the formula that's based off of you're talking about a boundary between isotropic media, which is like that's a standardized uniform case. But then when we're talking about atmospheric refraction, it's anisotropic. So that's why the Snell's law doesn't apply directly. It's like you said, it's sort of like on a phased gradient. It's not the same.
Yeah,
as
but when we talk,
refraction through
I
glass
understand. We understand that, but when we talk to Globers, they'll mention Snell's law. They'll argue Snell's law. They'll do it.
Yeah, Snell's law. I think that's an analog to that is when I talk to people that will say that you can't have gas pressure next to a vacuum, and they'll reference they'll reference the ideal gas law. But I mean, that's the ideal gas law, which is it's like a rule of thumb that's assuming a pressurized system. The gas law works in ideal situations where there's not a certain amount of thermal dysregulation, which is exactly what we have in the low pressure areas at the top of the atmosphere. So the ideal gas law doesn't apply in non-ideal conditions like that, where the gas particles work differently under extremely low energy systems. It's not an ideal gas. So they'll reference the ideal gas law, but it's like that's not an ideal gas.
Personally, I've never heard of
when you say gas pressure, gas particles. I'm sorry. But when he said gas particles work differently in low pressure versus high pressure, what does he mean by that? How are they behave? What do you mean by work? Because when you say work differently, that to me that means they behave differently.
Right.
What are they doing that's different?
Right, because they don't have consistent boundary interactions. They become basically.
Well, that's not. I don't think that's true.
What is that?
I think that right. What the gas molecules do or whatever are intrinsically linked to the energy or the temperature they're in, right? So they're never going to not be linked. What's happening down here?
Yeah, but regardless of the temperature,
what's happening down there? Yeah, I'm saying what you're saying, but so what's down there is the same thing that's happening up there. The law isn't different up there. So I don't get what you mean by it behaves differently either.
Yeah, so the ideal gas. So an ideal gas is if you look up, just literally look up the term ideal gas, which is what the ideal gas law that they referred to is. They're referring to the ideal gas law, which is about ideal gases. The definition of the ideal gas is it is a theoretical gas composed of many random moving point particles that are not subject to interparticle interactions. There are exceptions to the ideal gas law outside of those types of parameters, which would be particularly extremely low pressures. When you get to extremely low pressures or low temperatures, the ideal gas law no longer applies because we are no longer in an ideal gas situation. Ideal gas law is for pressurized, normalized thermosystems. When you get to the ionosphere, where we have basically radical ion gases that are just bouncing around, they're no longer boundaried. What's happening?
Oh my god, dude! I thought something was going on with my phone.
I took care of it.
What
is that? Goosh. Bye, Goosh. Goosh. Change your name.
Well, like when a gas gets into a really low pressured area, how does the behavior change?
No, I was going to ask a question.
So yeah, basically instead of having constant boundary interactions, they're just more like they're bouncing in space.
Yeah, no. And that's what I'm going to ask you about, the ionosphere. What's that about? Where's that at?
The outer.
What do you mean by boundary interactions? What does that mean?
Hey, you focus on the wrong thing, bro. Like I'm trying to figure out where things are different.
It seems the behavior of gas.
So listen, I'm just trying to identify where he's saying things are different. He said the ionosphere. I mean, I don't.
Are you about to ask me for proof that the ionosphere exists? Is this set up?
No, I'm just trying to figure out like where's this data coming from to say, okay, things are different. Clearly, you just said, well, the ionosphere. How did they retrieve that data?
You'll see. There it is. I knew it. There it is.
Okay, and go on.
Yeah, no, I don't need to entertain the does the ionosphere exist thing. I wasn't setting out to prove it either.
Why? No. You're saying that gas particles behave in a particular way in a particular area, and I'm asking you, how do you know that?
Yeah, I don't.
Well, he specifically said gas pressure behaves differently in low pressured areas.
We need your help, fam.
No, you kind of do because you're not getting to the crux of what he just said. He said gas acts differently when it's in a low pressure.
I forget. Okay, it's that guy. I forgot. Go on.
Okay, so basically the idea is that gas behaves more like an ideal gas at higher temperature and lower pressure. Because the potential
I hear what you're explaining. I'm just asking you, how do you know what you said? Are you telling me you don't know?
Well, the ideal gas law is a theory for how we
I'm not talking about I'm not talking about the ideal gas law. I'm talking about what you said.
That's what I'm talking
about. I know, but I followed up, right? So it's not like I'm asking a completely non sequitur question and now you're asking me. You already said you were
getting a lot of echo. Something's happening.
Right?
Can't hear you.
Like I'm asking a completely non sequitur question and now you're
Big time echo.
Hi, when you're hot micing. Hi, when you're hot micing. I'm sure he knows at this point because I was on speaker. So whenever you feel like getting unmuted, inbox me.
So you're asking me how I know the ionosphere exists? I don't. Somebody told me.
That's not okay. Well, I'll accept that. So then your claim is just a baseless assertion then?
No, my claim is about the ideal gas law. And I'm saying that you can't
but you said, but you said it doesn't apply to a place that I asked you, okay, well, how do you know what you said about that thing in that place? And you said, well, I don't know. So with that's where we are.
Yeah, okay. Great. So theoretically, if that was the case, that there was a place along the gradient of lower pressure that we do experience as we elevate, I'm sure you would agree, that if we got to a place where there was such low pressure, as is described in this concept that we call the ionosphere, the ideal gas law would not apply to a environment like that because it's not an ideal gas.
I hear you saying that, but
that's all I'm saying.
I hear you saying that.
That's all I'm saying. So I'm liking that. I'm making an analogy to where we can't appeal to ideal gas law to what would be happening in the upper layers of the atmosphere if there is a gradient to where it goes to such low pressures and low temperature.
Well, you can't compare something. You can't compare something. You know,
I'm saying in a similar way, we can't
to something that we've never. I'm sorry, you literally weren't talking when I started talking.
Amazing,
right?
No, I don't know. I thought I was. Amazing.
I don't think you can call an analogy by comparing something that we experience to something that we do not.
Well, we can, experience gas in extremely low pressure states, right? Or extremely low temperature.
No, gas behaves how gas behaves always. Now, you're saying it behaves differently in a particular place under particular conditions. Okay, so that's a baseless assertion. That's cool, I guess.
Oh, well, you're asserting.
I don't know.
Likewise, you're asserting that I'm sorry, I'm interrupting you again. My bad.
Yeah.
I hear you asserting that gas always acts the same way in all circumstances. How have you proved that?
In all experiences.
Oh, really? You have had all experiences?
No, all my experiences, all lived experiences. If anyone else has had a different experience, I would ask them what that was. Did you?
No, I don't do.
Okay, because if there was any human on Earth at all, ever, if I came across any human, I'd be like, oh, okay, well, seeing is that, water boils for me just like it boils for everyone else the same way, just like I'm under the same natural laws that everyone else is under. We experience the same things. I need to know how you're experiencing this thing differently. Explain it to me. I'm not going to just be like, Get out of my face.
I have a basic understanding. Like I know they can ionize gas in vacuum tubes, so we can put gas into an ionized state.
Yeah, in a tube.
And and we do understand that in that special circumstance, it does not operate according to the ideal gas law. It's no longer an ideal gas. That's
of course it wouldn't, because it wouldn't be a natural environment, would it?
What do you mean?
I mean, you put it in a tube and then you did some stuff. It's not natural, is it?
Well, you just put it in a reduced.
Well, it's simple to answer the question. I mean, you'd be like, yeah, you're right. That's not natural. I understand what you're. It's like that seems to be the appropriate.
It's not unnatural.
It's unnatural because it's not like that in nature. Now you're trying to compare something that is unnatural. Listen, you're trying to compare something that is unnatural to this explanation of something you've never experienced somewhere else. No, sir. Not for me. Sorry. You can do that. I'm just, I hope you understand how that's nowhere near good enough for me.
Sir, not asking you to do anything. I'm only pointing out that the ideal gas law, as defined by those who use it and practice it and defined it themselves, the ones who came up with it, even according to them, doesn't apply in non-ideal conditions.
I don't know what that has to do with the price of tea in China. I already told you that.
Then it's just a matter of you not being able to follow along. I don't know.
No, we are following along. You're talking about the ideal gas law not applying to a place that you've never been and don't. That's where we're at. How am I not following along?
Yeah, I've admitted that I haven't been.
Okay, so don't say things like I'm not following along when I am. Obviously, that'd be the kind of thing that breaks down a communication. That's why friends that's why they stop being friends, because of dumb shit like that. When I say something correct, just go, yeah.
Well,
okay,
I don't feel like, I'm feeling a level of hostility that doesn't feel friendly from you, sir.
It's, because of what you just did. And I'm explaining it to you. See, a bad friend wouldn't explain it to you. And we're not friends yet. Right now, we're just talking to each other.
Right. As far as I can tell, we're adversaries.
I'm explaining to you what would piss me off, and you're doing it, and you've also admitted to it, and it's recorded. Yeah. So I was
You're doing it too. Yeah, we're in the same boat.
No, I'm just being hostile because you're doing what you're doing.
Oh, it's my fault that you're being hostile.
Well, because you're doing what you're doing. Well, I don't care that I'm being hostile. I'm not being disrespectful to you. There's a difference. You're the one saying I'm being hostile, and I'm telling you why. Again, because I'm being transparent. But we didn't need to talk about the hostility at all. All we had to do was talk about the exchange and how you've agreed with everything that I've said. So just be a little.
Except that the idea.
I didn't bring up the ideal gas law. Don't do that.
You said that ionized gas in a vacuum is unnatural, and I didn't agree with that.
What do you mean? Where in nature is a vacuum natural? And I know you're not saying that it is. They are natural.
I mean, I can't say in space because you have an assertion that space doesn't exist.
So if we're being fair,
he thinks most of nature is a vacuum. You got to remember, dude. He thinks most of nature is a vacuum.
Yeah, I understand that, but he also understands.
I mean, vacuums exist all around us.
He understands that that's the point in contention right now. So at least he understands that he has to watch his wording. He doesn't want to commit a logical fallacy. I can feel him thinking. I at least appreciate him taking pause here and there, regardless of his belief.
I wonder if you can tell me what you think I'm saying regarding the ideal gas law.
I didn't hear you because I was talking.
Can you tell me back what you think that I'm stating regarding the ideal gas law? So
I just did like literally 5 minutes ago, and it was like a quick 2-sentence summary or 1-sentence summary. We just did that.
All right. Well, then let me ask this. Isn't it fair then for me to say to the person who goes, you can't have gas without a barrier? Couldn't I say, well, you show me the barrier? Have you been to the barrier? How do you know there's a barrier there?
Well, I don't think you can't have gas pressure without containment. If that's what you're asking. Because I've never experienced that.
Why not? Oh, because
I've never experienced that.
So if you haven't experienced it, it can't happen?
What I'm saying is, I've never experienced it.
But you're also saying it can't happen.
I nor any other human has ever experienced. That's like someone telling me, so you're saying flying, a human being with,
it.
I'm sorry, I was talking again, and then you started talking when I started to leave.
I thought we were talking back and forth.
I know, but I'm about to leave with an example now. That's like someone saying that someone else can fly, like a human being, right? And I'm like, well, I've never seen that. And they're like, so because you've never seen that, you're saying, listen, high pressure always goes to low pressure. In order to have gas pressure, it needs to be confined to an area. The only way we do that is with a container. That's how we achieve gas pressure. That's the only way I know that it's possible. So that's it. Someone else who comes along with the claim that you don't need that, and that's not the case. As a matter of fact, here's a worldview with that not being necessary. I'm going to say no, sir. Oh. Respectfully.
Can I say something for the record, Newt? You know they use the ideal gas law in the situation. You're saying they don't use the ideal gas law, right? Like the 3 seconds it took to look up atmospheric dynamics ideal gas law. And I get, in atmospheric dynamics, the ideal gas law is a fundamental principle. like what?
I didn't say that it doesn't work in atmospheric dynamics.
Then why, if someone brings it up, would that be wrong?
Because what we're talking about is the boundary between atmosphere and no atmosphere. Vacuum means no atmosphere. We're talking about atmosphere next to no atmosphere. And there's a gradient where there's a breakdown in the...
Does it go to zero? Does it ever go to zero?
No, technically no. 10 to the negative Tor 17. Like, we don't know.
So the atmosphere is the entire universe. So there's a gradient across the entire universe.
Yeah. Well, there's because vacuum means absence of matter, right?
In a certain sense.
Yeah. So I'm never.
In a
I'm not
certain
claiming an
sense,
absolute.
no, dude. Like, listen. Then we're just all like the gradients of every other fucking celestial body. We're all mixing in each other's fucking gas gradient, dude.
That's right.
Dude,
That actually is right.
Yeah, that's a cool story, man. So here's the funny thing this is the thing I always find funny talking to you guys is that you guys, you claim to have a scientific backing of what you're saying, but science is based upon empiricism, and all we get from you guys are stories. We get quote unquote explanations. Explanations are not science. The science is the data. That's the science part. Right? So.
Well, I could turn that around on you so easily, though.
Yeah. Full story. Anyway, so what Elijah was bringing up.
The story you just told me.
He wants the empirical. No, that's not a story.
It could be reflecting off the dome, and maybe that's why we should put the.
Well, you demanded that from me. You demanded that from me. I said I could make up any bullshit. I didn't fucking volunteer that. I didn't say it was based upon science. Just horseshit. I can make a horseshit.
You demand from me an answer for how there could be air pressure next to a vacuum, and I say, well, it's pressing against the surface of the Earth because of gravity, and you go, cool story.
Yeah, because like Elijah said, that's contrary to like all experience. We want the empirical data that demonstrates that that's the case, right? That you can have a vacuum next to a pressurized gaseous system without a barrier separating them, and they can be separated, gradient or no gradient. Because experimentally, if we do an experiment, because let's go to experiment now, we take a vacuum cylinder, right? Say it's a 100-foot cylinder. I evacuate it. It's a vacuum. There's a little port on the bottom. I suck out all the air. Now I go, okay. Now it's a freaking 10 to the negative 10 torr vacuum. I'm going to insert a little bit of air into it. And we're all on the surface of the Earth where the gravity is strongest, right? Is gravity gonna hold the inserted air to the bottom of the container away from the vacuum? No, it's going to reach thermodynamic. It's going to spread out throughout the entire cylinder until it reaches thermodynamic equilibrium. It's not going to frickin' sink to the bottom.
So where will it?
This is what we're talking about experimentally. You can't demonstrate it.
Where will the atoms of that gas molecule be located?
Yeah, all over the place. I mean, we don't know exactly. That's why we use statistics to get a probability of where it will be.
So we don't know.
Use the Einstein both statistics or frickin' the Einstein Maxwell statistics.
So be some non-local place.
Yeah,
we're still getting that echo. It's not me.
No, it's just statistical. We don't know.
Oh, well then, how can you claim that what it will or won't do? If you don't know.
Statistically, it'll be at a random place somewhere in the cylinder, but it won't statistically be at the bottom, right?
So it'll just find some random place to hang out.
No, it'll be in constant motion. It'll have a kinetic energy.
It'll never stop moving?
That's right.
How can you prove that?
Well, because when we actually try to cool things down so that they stop moving, they don't stop moving. No matter how hard we try.
But we're not talking about gas moving through space. We're talking about the atomic.
No, like experimentally, we can take rubidium atoms and we can laser cool them to form what's called a Bose-Einstein condensate, and even then they move around.
But wait, we're talking about gas.
Yeah.
Who's got that echo?
Yeah, I know. Rubidium atoms are gas.
Okay, so you've put a single rubidium gas.
They use ensembles of 20. They use like an ensemble. They don't use just one.
And they perpetually move around the vacuum chamber forever?
Yes. They have if it has a temperature, it's in motion. It's called the kinetic theory of gases. So if it has a temperature, it has you can do an equivalence of the temperature to a kinetic energy.
So it goes up and down, left and right,
every
all over the place with no regard for little g. It has no weight.
Well, they don't have any little g in any of the equations.
Oh, wait, so are we talking about equations or experimentation?
Well, there's no look, why would you even bring up little g? That's the point. Why are you even bringing it up? Because we know experimentally.
Because you brought it up first. You said, would it settle to the bottom? And then you said no. And I said, how can you prove that? And then you referred to math.
Because anywhere we measure inside the cylinder, the pressure is going to be the same. We measure at the top, we measure at the bottom, we measure in the middle. Right? Once it's reached thermodynamic equilibrium, anywhere we measure in this cylinder, it'll be the same pressure, temperature.
That's fine. But where will the
point. It won't be more pressure at the bottom.
But where will the molecule be?
Who cares?
You stated that it won't go to the bottom, and I'm asking how you can prove that.
If it has a uniform pressure and temperature, then it has the equal distribution. Right? Matter per unit volume. It'll be equal everywhere. We model it statistically because we can't know with precision where every single particle is. We don't have the instruments to do that. Maybe someday we will, but right now we don't.
Well, that sort of like shoots you in the foot then. If you don't have the instrumentation to measure where the particle is, then you can't say it didn't go to the bottom.
No, we can make an equivalent. We can get the equivalent, right? Pressure, temperature, volume, right? We can get the pressure or the temperature.
But you're telling me what the pressure in the cylinder is, not where the molecule went.
What is pressure? We're talking about pressure, dude.
Deflective force.
We don't care. I don't care about you can't say, hey, pressure is different than matter per unit volume, and then claim you're talking about vacuums, dude.
Well, vacuum isn't a pressure.
Oh, really?
Yes.
So we don't use a pressure gauge, right, to measure vacuum.
Well, not directly, no.
What do you mean not directly? What are you talking about?
No, we use a pressure gauge to measure pressure, but vacuum means absence of matter.
What is pressure?
Pressing force.
Okay, the force exerted on the walls of a container.
Well, that's not only that. It could be pressure. There's a lot of different kind of pressure.
So we take a pressure
Not only
gauge. What
containers.
happens in the pressure gauge is there's gas.
Pressure
The gas
means
has a
force over
temperature,
area, more
and each
specifically,
module
force
has a
over area.
freaking kinetic energy. And if you have X amount of pressure, you can
I'm
say
not recording myself.
X amount of particles hit the freaking pressure gauge over this unit time. So there must be this, and if we know the temperature, we can say, hey, there must be this many particles in this volume. The point is that if we measure the pressure and temperature and they're at equilibrium, they will not vary in the cylinder at all.
Wait, no,
right?
you
And we can infer that without counting the particles directly, because we know that the only way the pressure gauge is going to get a reading is if it's hit by gases, right? Otherwise, you're not going to get a reading unless you think spontaneous pressure or something like that. Like you fucking magic fucking gnomes are pushing on the pressure gauge. I mean, you can believe that, but we know that little gas molecules have to be hitting it, and so many hit it per unit time, right? We know if we know the temperature, we can say, hey, this is the kinetic energy of the gas. These gas molecules have to be traveling so fast, but we're getting this pressure reading. That means X amount of fucking particles hit it to get this pressure reading. Now we know how many particles are in this volume. It's pretty simple. It's not complicated. But the thing is, this is an experiment, right? So we can do this experiment. Like you can say, hey, you can have gas pressure adjacent to a vacuum and it doesn't fuck off into the vacuum. You can say that. But what can you demonstrate experimentally? That's really the question.
Well, that's what I posed to you. How can you demonstrate experimentally that?
We can demonstrate experimentally we can't do it.
Well, absence of a determination isn't the presence of one. So
yeah,
I'm
but
you, how can you experimentally show?
Like, all things aren't true until they're all.
Wait, please.
Well, no, because you're trying to like do this burden of proof bullshit, dude. Listen, all claims aren't true until proven wrong. That's not how it works.
No, you said that if we put a single particle in a chamber with no pressure, that it would not go to the bottom. And I asked you how to demonstrate that. And then you referred to math.
No, I didn't say single particle. I said if we inserted gas into the bottom of a vacuum cylinder at, say, 100 feet tall, it's an arbitrary height, doesn't matter how tall it is, get 1,000 feet tall, get 1,000 miles tall, doesn't matter. We know if we insert the gas doesn't settle to the bottom. We know this from experience. We know this empirically from doing it.
Where's that test? 100-foot tall vacuum chamber.
Oh God, dude!
And the gas doesn't.
It's a Gedanken experiment, dude. Like we don't actually need to do it. Like if you really want to do it, like do you really need it to be done? Something we already know.
If you're going to say that that's what happens, you experientially.
Just use your common sense, dude. Just use your common sense. We make vacuum chambers for all sorts of purposes, manufacturing chips, blah, 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 blah. They don't have a little mixer in there trying to mix up the fucking gas off the bottom, okay? Because all the fucking gas that's up, because you can't make an absolute vacuum. So there has to be some gas particles in there. They don't have a little mixer mixing the fucking gas around.
Right. And
but you're saying air is vacuum. Why don't you just make a vacuum chamber, right? And you don't even have to have a high vacuum because you could just take the sample and stick it at the top. All right, and if you stick it at the top of the vacuum, there'll be more pressure at the bottom. You just wait for everything to fall to the bottom. You wait for all the gas to fall to the bottom. Like, why do you even need a vacuum pump? Just fucking make a chamber, and all the gas will fall to the fucking bottom, and there'll be a vacuum on top.
Well, if the chamber was tall enough, that's exactly what would happen.
Oh, Jesus Christ.
Well, let me ask you this. Let me change up the parameters a little bit, see if it holds true.
Why does anybody even make vacuum chambers? Why make them at all? Let's just fucking make a fucking super tall fucking structure. where all the gas magically falls to the fucking bottom.
So we have
Yeah,
a
but there will
Come up with our
always be gas at
thermodynamic
the very
theory.
top. Okay, I think Indio, I think you might be confused here because I think you're saying that outer space is a perfect vacuum, and I don't think anyone here is making that claim.
No, that's not what I said.
If the gas chamber was one,
obviously I didn't say that, dude,
Let me ask
because
you this one.
I did the theoretical. I even asked, does it ever go to zero?
No, and I'm saying it does not. It will not go to zero.
Why would
There will
you
always
ask
be
me
pressure.
15? Why would you ask me 15 minutes later if I think it goes to vacuum? Or
Big
think
Tech,
there's a perfect vacuum?
the pressure on the moon is not absolute zero.
You have no idea what the fucking pressure on the moon is or anything about the moon, dude.
Let me ask you this question.
I mean, you hear your speculation.
So now this theoretical
Or like
gas
even
chamber,
outer space, not even the moon, just empty space.
There's
in
no
the solar
fucking
system.
outer space, dude. That's the thing of contention.
Okay, we're getting the echo from Indio because his light got when I talk.
Yeah, you are.
Indio, you're creating an
I
echo.
had a headset on, so I don't know how the fuck
So I don't know.
Well, you need to maybe turn down your volume because
All of our voices are being picked up at your mic.
Yeah, but it's hold on a second.
Maybe your echo cancellation's off or something like that.
Test.
Let me check.
Is that better?
No, it's still there.
No, it's check.
Hold on, let me reconnect my headset.
All right, check. He's muted now.
Mm.
The question I want to pose, so theoretically, if this vacuum chamber is...
I don't know how you can get an echo when it's an earbud headset, dude. Like, there's no way the mic can hear within my ear. That's impossible.
Oh, shit.
Oh, it's better now.
Let's freaking go.
The reconnected. Okay, so now theoretically, the vacuum chamber is 100,000 miles tall. Vacuum chamber 100,000 miles high. It's absolute vacuum. There's nothing in there. Theoretical. And then you somehow are able to let one oxygen gas molecule into that vacuum. Will you be able to sense that oxygen at the top and the bottom at the same time?
Can you guys
Obviously not, and that wasn't my hypothetical, dude. You guys always have to change shit, straw man, and do a bunch of bullshit. That wasn't the hypothetical.
Well, it's a thought experiment. Yeah, we hear you.
I hear you.
So the thought experiment is important because the question is, will that gas, if it was in the, let's say it's next to a significant, it's in the same type of system that we're in now, whatever causes things to go down and accelerate down, we would call it little g. It has weight. So it has weight. Where will that gas molecule go? Would it not get attracted? Would it not be caused to go down just like everything else falls in a vacuum?
No. It has a kinetic energy.
So where
you are aware of the phases of matter, right?
Yeah.
Where will go? Just bounce around forever.
Yeah, but
Wouldn't
there's
it be
some
losing energy
gases
when it
that
interacts
fall,
with
right?
the boundaries?
So not all gases.
Well,
just fall,
it'll reach
right?
thermodynamic equilibrium. So, like, it'll pick up a temperature from the cylinder itself if the cylinder has a temperature. If the temperature of the cylinder was absolute zero, eventually it would come to a stop. But your idea is that it's going to roll around on the fucking floor. No one's ever seen a gas molecule roll around the floor.
Why do feathers fall in a gas chamber?
Why wouldn't
Can I
they?
ask this guy a
I mean, in a vacuum chamber.
Yeah, go ahead, Alpha.
Yo. All right. Yo, Big Tech, are you there? Can you hear me?
Yep.
Okay.
Why do you think the Earth is a globe?
Oh boy, we're starting all the way from scratch.
Yeah.
Okay, we were having a conversation here. We're just ditching it, going to a different one now. Everybody in agreement with that?
What do you mean, everybody?
He's on break. I'm fine with it. It only lasts a minute.
Okay, before we leave this topic, Indio, do you know about sulfur hexafluoride?
Yes, I know what sulfur hexafluoride is, dude. This ain't 2016, bro.
All right, Big Tech. How do you know the Earth's a globe? Should be easy.
Looks curved.
When have you seen it curve?
Saw pictures of it.
From where?
People who went up real high.
Okay. When you have that picture in your hand, what do you have to compare it to?
Everything else I've ever seen.
That doesn't make. That's very ambiguous. Okay, let's do it again. When you have that picture of the Earth looking like a sphere, when you go outside, what do you compare it to?
Why would I? What do you mean? What are you getting at here?
Well, the images of the thing you're standing on, right?
Okay.
Okay. So if it's the thing you're standing on, where do you see the Earth looking like that image?
Where? In the globe.
Yeah, where?
On my grandfather's desk. He has a globe.
Okay, but that's paper mache, whatever.
Yep.
And that's not the thing you're standing on. So what we're trying to compare it to, those images, right? Because you think, well, that's the Earth. Well, the Earth that you're thinking of is the one you're standing on. Now, when you're looking at that image, right? Where does that image compare to what you're standing on? Should be easy.
Okay, then what's the answer?
I don't know. You tell me.
You stumped me.
I'm not the.
Hold on, Alpha. I'm gonna dumb it down. Okay, he's asking you the picture. How do you evaluate it? How someone says, "Hey, this is a picture of the thing you're standing on." So you print out the picture, you go outside, you go get a picture, you go get the ground, you go get a picture. Like, how are you evaluating it that image is authentic? That it is actually an image of the thing you're standing on.
Right.
How does that work?
I don't. I don't.
Excellent. So interesting, right? So the image that they're telling you that the Earth is a globe, and the reason why you think it's one has nothing to do with the thing you're standing on, according to a comparison from the thing that they're showing you to the thing you're standing on. There's no way to compare it to the reality.
Yeah, I haven't been there, so I haven't had that view.
No, it's not about being.
My view.
Yeah, it's not about. Yeah, but it's not about being there. It's about being here. So they're showing you something that's extraordinary, right? This spheroid Earth. Now, the spheroid Earth that they're showing you, they say, "Hey, dude, you live on this thing. We check. We're showing you images of it from where we're at," and you're like, "That's awesome. I believe you. Based on you telling me this story and showing me these images, I don't need any further information or evidence. I'm going to believe you." So it's a faith-based belief system that you have because you didn't compare the image to anything in reality. You just believe that it is so because of an image and a story. Is that true?
Okay. Yeah.
Really? Okay. Well, in that case, there's no real reason of a justification for you to think that it's a globe. You just blindly believe that it's a globe based on a really cool story.
Okay.
All right. And on the other hand, when we talk about flat Earth, we have the evidence to back up the claim. Now, I heard you saying earlier that, they're measuring the Earth, surveyors, right? Civil engineers, I think you used the word. But you're saying that they're measuring the Earth when they're taking the curvature of the Earth into account. Is this true?
Yes.
Okay.
So.
How do you know? Oh, belief.
Yep.
So looking into this, have you ever talked to a surveyor and asked them specifically, is it possible that every time you survey the land, that you take the curvature of the Earth into account when you're getting the raw data extracted from or collected from the field research? When you're out there, you're looking upon the land. Yes. You've talked to a surveyor, and the surveyor responded back to you, I take the Earth's curvature into account when I'm surveying the land.
Yes, that's what he told me.
Who did you speak to?
I talked to him on Twitter. He could be lying to me.
Well, it's not about him lying.
Pretending to be a surveyor.
It's not about him being an imposter.
It better not be Jesse. Hold on. Is it Jesse?
Yeah. Kozlowski?
No, the other Jesse. Path of Light.
Path of Light?
Jesse Gordon.
Look up his name again. Let me see. Hold on a second.
Okay. So there's amateurs. We're not talking about amateurs. Some people are not professionals. They don't do this at their job. Real surveyors, people who do this professionally, will tell you that they're not taking the Earth's curvature into account when they're doing their planar surveying. Now, the geodetic surveying that you might think they're extrapolating the Earth's curvature from is a calculation superimposed off of the raw data that they're getting from planar surveying. I was trying to tell the chat to look at what I was texting, but it was pretty cringe when you were saying that's what they do. You're incorrect. Professionals don't do this. They don't take the curvature of the Earth into account when they're surveying the land. You're just wrong. And whoever's telling you this is probably an amateur and doesn't know what they're talking about.
What's the name of the person that you said you thought it might have been? Jesse? What's his Twitter handle?
Jesse Patholite is another guy. I don't know if he uses Patholite as a handle.
What if I brought him in here, the surveyor?
He has been.
Hold on. Jesse Patholite is not a surveyor. He's been in here hundreds.
No, I don't know.
He's been in here hundreds of times.
So the surveyor that I was speaking to, what if I brought him in here? I wonder if he can join.
What's his name? Who is it?
Path of Light. No,
he's not a surveyor.
Sorry. Hold on. No, I said what you said. It stuck in my head. It's a different P name. Phantom Thoughts. That's his handle on Twitter. Phantom Thoughts.
Yeah, please. Bring him in here.
Yeah, let me hit him up and see if he's available.
Excellent.
Yeah, can we take a side bet real quick? $50. He does. Yeah, he's never heard of curvature of the plumb line. I'll bet $50. Any takers?
Yeah, because
never even heard of it.
If he's doing rise over run and he's saying he's accounting for the Earth's curvature, he's in a whole lot of fucking trouble. So I want to hear him say from his own mouth, being a professional. First of all, we got to find out if he's a professional or an amateur. Some guy who just got a theodolite and is winging it. He said, "Honey, hold my beer. I'm going to talk to these flat earthers." Like basically a Jesse Patholite individual. I'm going to take this dude apart 9 ways to Sunday if he's lying. I guarantee it. There's nothing he can do but tell you the honest truth about what he does in his profession. And they do not. No surveyor takes the curvature into account when they're actually surveying the land, extracting the raw data from their measurements. They don't do that. Zero surveyors do that. So I'm kind of interested now. It's piquing my interest.
Yeah,
hopefully he does get the guy in
DMs, see if he's available. If I remember right, I think he said he worked for Caltrans. He does surveying for roads and bridges and stuff like that.
Excellent. Well, then he's not going to lie. And if he does, it's his ass. He's going to reap the fucking whirlwind. I guarantee it. So all we got to hear from him and him to you is the truth. The truth, the whole truth, and nothing but the truth. So help him.
Let me ask you a question about the surveying. So can I infer from what you're saying that when all of these textbooks and manuals give a curve correction formula to be used when calculating distances, you're saying that this is garbage, like lies?
No, let's not misconstrue what I said. Geodetic surveying is a superimposed application that uses the Haversine formula to actually extrapolate the rotundity of a spheroid model. Did you hear what I said?
Yes.
Hello? Okay. So they're not actually measuring curvature. The measurement is being done over planar surveying.
But my question is different than that.
I know that, but do you understand the implications? So what's happening is yeah, I know. It's a bit tough for new people to actually think about this. So whenever they're doing the surveying, this guy sets up his gear, right? Total station, whatever it is he's using. Once he sets up his equipment, he's not going to think about the Earth's curvature over distances that he's going to use because it's for accuracy. He has to shoot for short distances, right? It depends on the accuracy of the model of total station or theodolite he's using, right? It has to have a tolerance range within a certain amount of parameters. Like you can't just think that you're going to use a theodolite to use it for whatever distance. That's not how it works. Do you know that?
No, that's might be above my pay grade.
Well, it's not too hard, man. Think about it. So if you're using a device specifically designed for what its use case is for, there's nothing that is going to allow it to use it outside of those working parameters effectively, right? Because you want to extrapolate the most accurate data that you can possible within a tolerance. Does that make any sense?
Yeah, but it sounds like you're asking me if they're accounting for the curve of the Earth when they're setting up the theodolite.
Yeah, when they're performing their actual distance measurements, they're not accounting for the Earth's curvature. Now, this is what could happen, right? The device could have already, the new devices that are out now, already have the calculation baked into the devices, like, the computer chip. It could already be doing that superimposed over that information that's taken over the raw data. So that can happen already, because they already have models that do that probably. But the actual surveying of the land over distance is not going to be doing it, taking the curvature of the Earth into account. Specifically, not distances that they're actually going to be utilizing it for.
So actually, I'm referring back to some DMs that I had with him, and he actually addressed this point.
Sure.
And I'll read you what he said. He said, obviously, we don't use pencil and paper and calculator to correct for curve in every measurement that we do when we're on a production mode on the job. But we do use pencil and paper to calculate in our classes and on our license exams.
What does that have to do with the calculation?
So this leads me to, it sort of begs the question, so why would they train them to do this calculation in the license exams? Are you saying, is this like part of the bamboozling that's going on or something?
Oh, dude.
They have to...
Go ahead. That's straw man shit, dude.
They're extrapolating the WGS 84 model as in like the Oblate spheroid model. So in order to fit this specific model, because they're working off of, it's almost like, let's say if you took away the Earth as a sphere, if you took that away, you would still be working with line of sight distances that the surveyors would be accounting for between point A and point B. They're not going to be accounting for curvature. It's not needed, specifically for what they're going to be using them for.
So I just found it.
Do you agree with? I know, but do you agree with that?
I'm not sure I comprehended what you just said. I was reading through his DMs right here.
Dude, it's simple. I'm speaking English. And I think you're busy trying to figure out how to debunk what I'm saying versus accepting the very plain understanding.
I'm trying to refer to what he's told me and listen to you and contact about getting him in here. So you have to forgive me.
I don't see why. Do you think it's possible that he's going to tell you over, let's say, a couple miles that he's going to need the curvature of the Earth to be taken into account? Do you think that's going to happen?
Well, what he told me specifically is that all their GPS, which he GNSS, it's corrected orthometrically for elevations on every measurement that they make using a geoid ellipsoid model based on the globe.
Yeah.
So he doesn't account for it himself. The models are baked into the cake with the system that he's using.
Okay.
But on the licensing exam, they have to demonstrate understanding of how all that works. But now they have tools to simplify it.
Okay. So you just said you agreed with what I just said.
Okay.
Everything I said is exactly what you just told me that he said. Nothing different.
He doesn't understand. Okay. That's why it's not your fault. It's kind of esoteric, but they're making measurements, right? So you have lines of sight that are straight. So you have a triangle. That's just a regular triangle, but their coordinate system requires a curved surface because they have the celestial sphere, which the whole coordinate system, latitude and longitude, is based on. So they have this reference ellipsoid, which they're going to project these points onto, right? The actual measured points. They're going to put them onto another surface. The same way that you would scan a 3D model, right? So you have a 3D model in a video game that's just a wireframe. Well, where'd the texture come from? Well, you have to map the texture to the freaking wireframe, right? So this is what they're doing. They're basically mapping their measurements onto another surface.
Yep. It's that simple.
An imaginary surface on the WGS84 reference ellipsoid.
Yes, exactly.
Why do they do that?
Well, the macro sense, and the macro sense, it's the Earth, taken into like the idea that you live on an oblate spheroid, so they can't just measure the curvature; they have to extrapolate it in a mathematical construct. So it's born out of that. It's not born out of a measurement system. They're not measuring the Earth anywhere. Surveyors do not do this practically. They're not practically measuring the curvature. Nobody does. They would tell you more something along the lines of, it's so minuscule, we don't need to take it into account, the curvature. And it sounds like an explanation that's added after the fact. So you're taking it as, well, of course the Earth's curving, but they're not taking it into consideration because it's so minuscule. But that's what they're telling you, although they're not.
But that's not what he said. He said
they are taking it into account.
He said they are taking it into account, and their tool has it's like automatically calibrates for it.
No, I know that. But you're not getting
the measurement, going from the measurement to the reduction. So they're taking the numbers that they measured. So they made an actual measurement, and they have data values. But they need these data values to go onto a reference ellipsoid. Their machine, right? Their theodolite, GNSS, GPS, whatever, right? It's doing the calculation for them, but it's just a calculation. It's not an actual measurement of the sphere.
Yep.
All right. So what's the problem?
They could literally presuppose any shape and map their measurements to that shape. Literally any shape. A duck.
So let me tell you.
Whatever.
Okay, but if they did that, like if they
Hold on, Big Tech. Let me just tell you, because I don't have too much time. So let me just tell you what this means. This actually means that when they're surveying the land, unbeknownst to you, and probably a shocker, is that they're measuring flat Earth. Because the reference plane that they're actually referencing is going to be mean across the plane. So when they're doing their planar surveying, they're extracting the raw data from their line of sight measurements. And when they're doing this, they're going to get that information. And then, well, of course, like you said, and I already understand, the instrument is already putting that calculation superimposed over that data measurement. Yeah. So they're measuring. I'm gonna say that they're measuring the Earth as flat.
Okay, and I know what you're going to say, Big Tech, is that if there was any shape, you'd have distortion. They're not using straight lines. This is why I brought up curved plumb lines. They're not using straight lines to project their measurements that they make onto a reference ellipsoid. They're curving that line.
Why
would not a straight right?
Why would they do that?
Because it's not a ball, dude. Why would they do that? Because it's not a fucking ball.
So they curve it because it's not a ball.
Well, it doesn't match. It doesn't match the sky ball. So when they do the measurements on the Earth, right, then they compare it like, hey, this star should be at zenith, but it's not at zenith. So gravity must be tilted here. But we can't have a tilted fucking plumb line because then we project it onto a reference ellipsoid, it's sideways and it has to intersect it at 90 degrees. So we're going to curve the plumb line so that the plumb line, it's like, say you had like your measurement surface and underneath it you drew a freaking circle, right? But your plumb line, instead of going straight down into the circle, it's tilted. Well, it has to intersect the circle at 90 degrees to do it right. Otherwise, the distances will be all fucked up. So the only way to do this correctly is to curve the line. So you curve the line so that it intersects the ball that's underneath at 90 degrees. This is literally what they do. Now, the orthometric height, which you were talking about, so that is the reference ellipsoid with the EGM Earth gravitational model. So it'll automatically do all this plumb line curving in software.
So you're saying it's because the celestial sphere.
Correct the
Yeah, the
mundo.
coordinate system.
So let's
That's right.
one thing-
What's your
The globe is like a
wait, I got a really good question. I got a big question.
No, hold on. Before you ask the question, because I'm about to head out. But unbeknownst to you, like you sound like a pretty okay dude. You know, you're not too dim with it, right? But if you're actually contemplating the fact that they're actually not measuring curvature, because this should be like alarm bells should be ringing. There should be red flags going up. You should be asking the very obvious question: why aren't they measuring curvature? Listen. Your mind is trying to do all these mental contortions to think about other things, and then you have a question in the hopper. I get it, but if you're not realizing the real reason why you should be asking why they're not measuring curvature, that's gonna stick out like a sore thumb every time. Now you're gonna ask everybody who thinks the Earth's a globe this question: how do you measure the surface of the Earth to be curving? Curvature measurements. Now, everybody's going to want to run to a different explanation or some kind of a theory. Stick to that question and ask them honestly and sincerely. You're going to get the answer every time. They don't know, or I'm not a scientist, or it's a calculation. It's never a measurement of the surface curving as an oblate spheroid. Anyway, I'm going to leave you with that, but because it sounds like you're not too far off from getting it, but
So my question is, what is a celestial sphere?
The sphere of infinite radius, the stars.
How do you measure that?
I mean, it's not our claim.
You're the one invoking the term.
Well, you're asking about surveying and how it's done, right? So I'm telling you what they do. So the celestial sphere is where the coordinate system is, latitude and longitude. It's actually not locations on the ground. This is easy to prove, and this is how you prove it. Try to find your latitude and longitude on a cloudy day. You fucking can't, right? Because you have no, you're hot mic'd alpha. So you can't find latitude and longitude if you can't see the star, the planets, the moon, right? They don't even have an existence. The coordinate system doesn't mean anything. That proves that the coordinate system, latitude and longitude, is in the sky. It's completely sky-based. So,
right.
If we have
what is
Polaris,
latitude derived off of? Latitude is derived off of the elevation of the Polaris.
Yes, kind of.
No, well, I mean, if Polaris is 42 degrees in your sky, you're at 42 degrees latitude.
Yeah. That's it's circular, right? So like,
right.
It's not like it's measured on the ground at 42. You could, if you didn't see Polaris, you would never be able to find your 42 longitude.
Right, but
latitude, rather.
Latitude is all based off of your elevation angle to Polaris. If you're at 90 degrees latitude, Polaris is at 90 degrees. If you're at 27 degrees latitude, Polaris is at 27 degree elevation.
Yeah, and longitude is based upon where the sun is. So the sun is longitude and latitude is the celestial sphere, Polaris, basically. I mean, you can also like
off latitude because the sun goes around Polaris east to west.
Yeah. I mean, well, it's a coordinate system, but the thing is, they map this coordinate system to the ground. So if we go someplace and we go, hey, I look in the almanac, the star is supposed to be at zenith. I set up my astrogeodetic theodolite, right? So it's a theodolite that looks up. I look through it, and then like I center the frickin' star, and then I look at the instrument, and my instrument's tilted. It's not at zenith where it's supposed to be, and it's tilted in another direction. So what they say is the Earth is a sphere, but there's lumpy gravity deflecting my theodolite in my level line. Right. This is the excuse. Okay.
I'm still still
Well, this
concerned
has
with
been
this
around
term.
since the 1400s.
But celestial sphere, why is it a sphere?
Because that's how they imagine it to be. Because the model is of a sphere, is of a celestial sphere.
What model?
It's all due to perspective.
The astronomical model invented by the Babylonians in, I don't know, fucking 300 BC or something.
So it's a sphere.
Oh,
It's a spherical coordinate system. No, it's a spherical coordinate system.
Right, but you only ever see one half at any given time.
Why would we end up with a spherical coordinate system on a flat plane?
Because we can't see, because the stars we can see from anywhere. We can't, like, I can't set my coordinate system like, okay, say I want my origin coordinates to be New York City. Well, if I'm in the Rocky Mountains, I can't see New York City. So how am I going to know where I am relative to New York City, where I can have a coordinate system based upon New York City? No, I need a coordinate system based upon some spatial reference that we can all see, right? So like I said, longitude, we all see the sun, so we're going to make a system based upon the sun, right? If I want to know how far east-west I am, if I want to know how far north-south I am, I'm going to base it upon some star in the sky. We've chosen Polaris. We could literally make any coordinate system we wanted using this. You need a spatial reference. So here's the funny thing, and like, I don't know if this will blow your mind or what. We have tried to make a coordinate system based on where the starting spatial reference is the ground. So there was, in 1927, they started what's called the North American Datum. So they surveyed, they started at a center point in America in Kansas, and then they surveyed without reference to the sky, except for the original coordinate, right? So the original coordinate, I think it's called Meade Ranch in Kansas. They did astrogeodetic surveying for 6 months to get its position in the celestial sphere coordinate system, and then they surveyed east to west, right? So that was our datum until they came up with a new one in 1983. When they made the 1983 one with the reference ellipsoid, which is completely based upon the International Terrestrial Reference System, which is based upon the celestial sphere and blah, blah, blah. When they compared the two, they didn't match. And in fact, there was like a systemic error. So if you start at like maybe the Ohio River Valley, right, there was no error. Like if you go east or north-south, right? So it's not a straight line. It's not like a longitude. It's kind of squiggly. But as you go east, everything is closer together than it should be. And then if you go west, and when I say closer together, means the further east you go, the more close together than it should be it gets. It doesn't like stay the same. It increases the error. So as you go west, they get further apart. That means all the distances, right? So it's not like, it's like stretching a rubber band, right? So close to where it starts stretching, it's stretched a little, but at the ends, it's stretched a lot. So this systemic error exists going from, like I said, from the Ohio River out going west. So the point is when they used the ground as their spatial reference and compared it to using the sky as a spatial reference, they didn't match each other. And they've known this since the 1400s. It's not new. And I'll give you the reference for how we know they've known this. It's called Determination of the Figure of the Earth. It's a book. You can get it on archive.org, right? And it gives you the history, surveying, all the crap. Determination of the Figure of the Earth. It's exactly what it says. And all the different techniques and methods and errors and fuck-ups and all the problems they had, yada, yada, yada. But they've known since way back when, and the reason was they surveyed Italy or something, and they started at like the end of the boot, and then they surveyed up until like up the boot of fucking Italy. And then when they got there, and then they took their celestial coordinates, they were off by something like 1.5 miles or something. And they're like, what the fuck, you know? And back then they used chains and shit. So they knew the distances because they actually used a physical fucking chain to measure the distance. But the distance wasn't right. So this celestial sphere It doesn't actually match the contours of the Earth, right? But this is hidden by interpolating data points. So when you do the double projection, the celestial sphere to the plane to the reference ellipsoid, the first one is a straight projection of rays. The next one are curved rays. So it's like one is a projection, the next one's a mapping. So a projection is a type of mapping, but it's not the only type of mapping. You can map one surface to any other arbitrary surface, but you just make some rule, and their rule is it's got to intersect the reference ellipsoid at a particular point to maintain the coordinate system. Now this seems like all fucking mumbo jumbo esoterica, and I guarantee you the surveyor from X don't know any of this shit. I've talked to plenty of surveyors, and they don't know any of this shit. In my experience, surveyors are basically end users, right? They're like cab drivers, right? You wouldn't have a cab driver build a car. They know how to drive a car. They know how a car operates, all that shit. But they're like end users of the car, right? Like they don't really know how anything actually works. He might have taken a test, and he can do the formulas, the Haversine formula, sine, cosine. He might be able to find the orthometric height by subtracting the frickin' geoid from the reference ellipsoid, right? He might be able to find all that, which is actually simple addition and subtraction. I don't know who couldn't fucking find that. But the point is that if it's a globe, why don't they just go measure curvature? Why isn't it just straightforward? Just go out and measure curvature. Why does the books, the first books on geodesy, why are they like 2 volumes of total volume? It's like 1,700 fucking pages. I'm on 2 volumes, all fucking formulas. Like, why isn't it I just take a theodolite and I just do measurements and measure the curve and that's what it is? Why is there all these fudge factors? That's the elephant in the room, is why are there all these ad hoc fudge factors? Because they have a bias. They said, Earth's a globe because the sky's a globe, and we have to make them fit. We're going to fucking do anything possible to make them fit together. And in case you weren't looking, I'll post it again. This is from a geodetic, I think it's called, where I got this from was, can't remember the name of the book. But see, if you look in the chat, right, Big Tech, if you look in the chat, the image I just posted, the diagram. If you drew horizontal lines along the actual plumb line, this dotted line is the plumb line. If you drew horizontals, like 90 degrees to this plumb line in a bunch of different spots, level would be in all sorts of different directions. And where it says ellipsoid normal, so if I set up my theodolite like right there on the ellipsoid normal, that's where I should see the star right above me as zenith, but I'm actually seeing it away from that, or I'm tilted away from that where the star should be. And like I said, their excuse is, fucking lumpy gravity or whatever. There's no evidence for any of that. And they have to say things, absurdities like plumb lines are curved. That's an absurdity. I dare you to build a fucking building thinking plumb lines are curved, dude. That shit will tip right over. That's probably how the frickin' Leaning Tower of Pisa was made. They're like, plumb lines are curved, build the Leaning Tower of Pisa.
What's the number on it?
Dude, you're unmuted, Alpha. See, and all the shit we just did and all the crap we've been going through, the fucking down every rabbit hole, minutia. This is why people cling to the globe because they don't want to because the amount of effort it takes to examine it is beyond what they want to do. So they would rather just default to that because it's simpler. Just say, oh, this Earth's a globe, fuck it. I don't care. Fucking I'll just believe the space pics. It's just easier. Too much baggage comes with flat Earth. You gotta care about truth and critical thinking and shit like that. Like you can't just it's not for the weak of heart.
I just heard back from my friend. He's not on Discord. He's trying to join. He had his VPN on, and that's making him verify his email. And it said he tried too many times. So I don't think.
Oh yeah, that's okay.
You're introducing me to some new concept. I've never heard of. I mean, it's very interesting, this idea of a curved plumb and lumpy gravity, and that's all. It's all sort of wild. I'm not sure.
It is sort of wild. It is wild, but I mean, just think about it practically. Just like we as human beings, right? We could have said the Earth was anything, and we could sit here. We had 500 years. We could make mathematical models to make anything work. There's an arbitrary number of mathematical models that'll work for any number of arbitrary data sets. Like, it's not difficult. Like, we do this all the time. We do it in engineering primarily. Like, I'll put it this way. If you're an engineer, you'll make a model to get some result for your product, whatever. But so they use models of that time is flowing in a negative direction. They don't think any of that shit's real, but it works, right? Their model works and it makes their fucking electronics work. So it's fine. It's only in physics and science where they reify their models and think that their models are the reality. And this is actually, if you really want to go back, this is actually a philosophical viewpoint. So the viewpoint where you reify your model is Platonism, right? So it's a Platonic worldview, right? Where you presuppose that, the idealized forms exist in reality. These abstractions are actually real and shit. But because they work, right? Because if it didn't work, it wouldn't be real, right? So we say, oh, our model works, therefore that must be how nature is. I'm sure you've heard it. The mathematical universe and all this crap, right? That is actually a philosophical, metaphysical viewpoint, but they don't present it like that. I'd have no problem if scientist says, well, it's not really real. But, I'm a Platonist, so that's how I think of it, as if my mathematical model is reality. But they don't say that because it's just because they wouldn't get any funding. I mean, just to keep it real.
Can I ask you? I want to ask more questions about surveying, but also, I guess I should leave it as a follow-up question because I asked how you measure the Earth is flat, and you reference lasers. Is there any other one?
I mean,
the Earth is flat.
I mean, LiDAR. There's some LiDAR data, though I'd have to find it. I mean, people have done all sorts of. As far as direct measurement, lasers is really the only way that's been done as far as directly measuring it. There's other things which you could infer a flat Earth, which I wouldn't call direct measurement. So there's 10,000-mile radio transmissions, 800-mile frickin' chirped radio. There's NATO had a frickin' VHF system that frickin' went at 600 miles. That was just declassified a month ago. So there's all these other indicators. There's frickin' 340 kilometer Wi-Fi connections, 2.4 gigahertz microwave. I mean, long distance observations from frickin' airplanes of 500 miles, of mountains, which would be 11 miles under the curve of the Earth. There's lots of them, right? And that would be done in infrared. And then there's there's been tests done in multiple ways. Visible light, infrared, mirrors, lasers, fucking microwave, radio wave, like.
So those are all light tests, actually.
Yeah, they're all electromagnetic radiation. Yeah.
So we're it's all basically inferring off of light, so like optics.
Yeah, but you know, there's ships at the bottom of the sea, and there's plane wreckage right now, and there's dead people, based upon the idea that laser targeting, the laser goes straight, and that's where the bomb goes. Right. So as a practical matter, the military uses this technology, pencil beam radar for the fucking, what is it, Mark 7 Sea Sparrow missiles, a pencil radar beam. So like, we don't, as a practical matter, we, as far as we assume that they're going straight, we can hit fucking targets, right? So, and then there's actual testing. So they've done tests. One test was so the Air Force wanted to know, they were trying to quantify, because the one thing about lasers that have fucked them up, targeting system, isn't refraction. I mean, it's refraction in a way, but it's not like the bendy around the curve refraction. It's turbulence. So it's basically turbulence or moving air or pockets of warm and cold air, right? So they're basically bubbles or pockets or what they call them inhomogeneities or discontinuities in the air will cause the laser to shimmer. You know, twinkle, twinkle, little star and all that shit. So they wanted to quantify this. So they did a 3 laser test from one Hawaiian island to the other, and they tried to pick it up in a telescope that was 3.4 meters wide. Well, if you use the model of refraction, because of this dispersion effect I was talking about earlier, the lasers, because there are 3 different frequencies, they should have been separated at the telescope by 20 meters, right? So the lowest laser should have been under the top laser 20 meters. But when they actually did this experiment, so the funny thing is they did the experiment first, and then, well, I should back up. So this experiment was done by the United States Air Force, Boeing, and the University of Dayton. 2 of the people from the University of Dayton were participating in the experiment and writing the results as part of their master's thesis, right? So they could get their degree. So they did the experiment. Then when he wrote his master's thesis, a guy that participated in it, they didn't do this beforehand. They did this after the fact. He did the calculation for refraction, how much the laser should have been separated, and realized this experiment should not have worked. If refraction was a thing, he used the U.S. Standard Model of refraction, 1976, U.S. Standard Atmosphere, modeled it all out, got the ray tracer, all that shit, said, hey, this beam should be 20 meters higher than this beam. This experiment should not have worked because the telescope's only 3 meters wide. How can you get a 20-meter stick through a 3-meter wide door? Right? It doesn't happen. But they did do the experiment. They picked up all 3 lasers in the telescope. They ran them through fiber optic cables, and they measured all the speckle pattern of all 3 lasers simultaneously. So they did the experiment, but they never thought, oh, we got to take refraction into account. If they did, they probably wouldn't have done the experiment. Probably would have fucked all up. Anyway, the point is that the idea that lasers aren't going straight, that's just an idea. The only time I've ever seen any experiment, right, any of these laser tests that have been done with the laser not going straight, it actually bent up. Right? And the reason it bends up, and I actually saw this, I also saw this during, they had wildfires. They had forest fires in Singapore, in Malaysia. So a dude in Singapore was like, it was like a video on the internet. It wasn't a flat Earth video or anything like that. It was just a dude. He's just shining a fucking laser, like a blue laser, off his balcony, and the laser was going straight up. He was shining it horizontal, and it literally just did like a 45-degree angle.
Wrong.
What do you mean wrong? What's wrong? Okay. Anyway, the point is that they've also done it at the Salton Sea. They've done, like John Dees, who's freaking, he has a PhD in physics, teaches at the University of Brighton in the UK. He's done a bunch of tests. He got the same thing before he was a flat earther because he was doing like laser tests. So it's like there's a claim on the table that lasers bend down and around the curb or whatever, dude. That's just like I said before. There's no evidence for that. There's no evidence lasers are bending around. Yeah, there are conditions where they can bend, but the thing is, you have to believe that it's the general case. You know what I mean? It's happening all the time. It isn't happening like one up. Otherwise, like flat earthers just happen to be going out under the perfect conditions every fucking time, right? Every time. Flat earth, oh, we're gonna do a laser test today. Good thing the weather's just fucking right. We can see over fucking 600 feet of curb. Good thing, because we did it last week. 2 weeks before, it was the same thing, even though the weather was completely different, even though we got the same result. So that's the thing. You have to, you can't just make generalized claims. It has to be nuanced. The nuance is that you actually have to say that the general condition of nature is that when I shine a laser, it bends down around a curve. Not sometimes, all the time. And that there's no, not that it bends down around the curve, that it bends around the curve and makes the earth seem flat all the time. And that it never, whenever you take a laser out, it never shows any curvature, ever. Because there's no globe earther laser tests. I'm sure some globe earthers tried it. I remember, this is a few years ago now, we had a guy, he was a university professor at the University of Washington. He came into the Discord, the other one, and he said, hey, I'm going to get a couple guys from the university. We're going to go out and we're going to do some tests. And they're in Washington State, so I guess they can shine them across fucking Puget Sound or something. He never came back. But you think he's going to come back and say, oh, yeah, we measured it and the earth was flat or fraction or something, right? They're never going to tell us if they go do a laser test. They'll tell us if they got the result they wanted, but they're never going to tell us if they get the contrary result.
Because they can't have the contrary result. They won't allow it. That'll be called a mess up or pseudoscience if they actually measure something. They call that pseudoscience. But if they hope and dream and calculate, then they're good to go. We're good.
I mean, do you really believe, Demok, or anybody, any flat earther in this chat, or anybody in this chat, that no glober ever has gone out and done a laser test in the last 10 years? Ever? Come on, man. One of them's tried it. Someone's tried it.
I bet a lot of people sillily like it. Builders, architects, and all kinds of people have tried all kinds of weird shit that wouldn't work, but would if you were on a ball. You see what I'm saying?
So big tech, check out. This is like the ultimate experiment. This isn't mine. This didn't come from me, so I can't take credit for it. And the person that came up with it, he's not around. I mean, he's alive, but he's not around anymore. So this is the experiment. You make a bathtub that's a mile long. So the top of this bathtub, right, from the bottom, right, the top curves the same way the Earth is supposed to curve, right, like 8 inches per mile squared. So the lip is not straight. The lip is curved, the lip of this bathtub. So what you do is you fill up this bathtub, and if water is conforming to gravity and forming a ball, then the water, when you fill it up, won't spill out. But if it's flat and the water's flat, when you fill it up, the water will spill out the sides before it reaches the top of the center, right? Because in the center, there'll be a hump. Right? So you'll never be able to fill it up to the top of the center. It'll always pour out the sides.
Yep.
Is there an image for this I'm supposed to look at?
Yeah, it's a cup.
No. I can post the video where the dude proposed it. But it's got a 3D graphic. No one's ever done this test. But this would be like, I think would be definitive. I mean, a mile might not be long enough to be definitive. They could just pull that lumpy gravity shit. So I don't know. That's a flat spot. I mean, I don't know how many times I heard that's a flat spot.
Well, you have the horizontal wall, and then you have the earth curve material inside the horizontal square that's perfectly horizontal, and you sit one in the other, then you fill the earth curve one up, right? And when that one doesn't work, you see the horizontal line versus the earth curve, so you can say, yes, this is not a horizontal line. In fact, it's the earth curve. And then when the water doesn't conform to it, you'll say, see, this water didn't conform, in fact, to that, and it, in fact, matches this horizontal as you fill the pool up afterwards and match the horizontal with it. And then it doesn't spill out. See, gravity doesn't need that fourth wall. You remember that fourth wall secret? That fourth wall in the aquarium? That 8-inch wall at the end?
The fourth wall, yeah.
Yeah, you don't need it. You only need 8 inches worth. Yeah, you don't need a fourth wall.
So, hey, I posted a video, the video of that, like, proposal for a test, which would actually be a final experiment. But so it's pretty cool. It only lasts like 4 minutes. But I disavow the cringy music and cringy narration. So a dude in the chat just asked Majan, I don't know if he's a flat earther or a glober, any reason why celestial navigation isn't at the forefront of your mind when citing flat earth proofs? Because it doesn't prove anything fundamentally, because it's inferential, just like the sun. Looking up, dude, is the wrong direction. Any conclusion you reach would just be inference, like a inductive inference. So it won't prove anything, and you just have a bunch of affirming consequence. I mean, I could bring some up. The navigation without the celestial sphere. So it was reported by the Royal Meteorological Society that there was a dust storm across the Atlantic that covered nearly the entire Atlantic, and no sea captain could see the sky or even the horizon. The entire Atlantic was covered in fine powdery dust. So the HMS Britain navigated, by dead reckoning, 2,000 miles. Now, if the Earth was a globe, this would be impossible, because that's dead reckoning uses planar triangles. And if you had a bunch of planar triangles, you tried to navigate on a curved surface, you'd end up fucking lost. You couldn't get to where you wanted to go. You would have to use spherical triangles. There's no way you could use it. If the distance was short, I'd say, hey, no problem. But if you look in any nautical instructions and motorboating, whatever, it says, yeah, you can use dead reckoning. But if you use it for more than 300 miles, you're going to get lost, because the Earth's a globe. Well, how do you do it for 2,000 miles?
Earlier, India, I don't know if you were listening or not, or if you were in the chat, but our friend here, what's his name?
Some friend you know, you don't even know his name.
Big Chum or something like that. He was saying when they do their surveying, right, they apply the formula to account for the Earth curvature, and they get the correct distances between 2 points. And asked, how do they know the distance? He said, well, they measure it out with a wheel, whatever, you know.
A wheel?
So really? Argument. Okay, so that confirms that applying the radius value to your measurements is correct because you get the correct distance. And I said, compared to what? But anyway.
Wouldn't the ground have to be pretty smooth for your little wheel to work?
You got all this topography, right?
Yeah, so dude. Like, what? A wheel? Dude, like, you know how they got like the measuring things for like football fields and shit where they measure out the lines? They got their little wheel. Like, is that what he's talking about? They got a little freaking.
I think so. Yeah.
I was being a bit pedantic with that answer, but I mean, like, we could get sophisticated, we could triangulate, we could secure the distance between the base of an object and the measuring point of the theodolite, right? And then if it's
need to know something first, like if you just got an angle, then you can't figure out height or distance. You need a distance or a height.
So what we would do is,
angle.
So if we were, if we established, level plumb at one point and the other, and we had a vertical object, let's say it's a tower, it's like a couple 100 feet tall, and the tower is 3 miles from my location, and I have a vantage point on the base and the top, I'm going to expect one distance at the base and one distance at the top if the Earth's flat. And then I'm going to expect a different distance if the Earth's curved, because that perfectly plumb vertical tall tower is going to be tilted away from me if it's curved. You follow?
We follow, but like,
okay.
See, the thing is, we always come back to this. Things get compressed in the distance. So as you look further through more and more air, objects get compressed vertically, and like it's like you guys say, oh, some made up flat earth or bullshit. No, it's not. Something called flattening of the sun. When the sun sets, it appears to flatten and turn into a line, right? So this is observed all the time.
It's refraction.
Well, I mean refraction, but that's not But it's not. Look, I think you misunderstand when I rail on refraction. Yes, there's refraction in the air. No, it don't work the way y'all think. It don't work bending shit over the curve as a spherically symmetric atmosphere. It don't work like that in reality.
It squishes and widens as it goes through the denser layers of the atmosphere when it gets low.
Yeah, I mean, squishes and widens, but the air isn't like that. That's the thing. The air isn't just a gradient. There's pockets of air. That's it. Like, this is what you guys like aren't comprehend. Why do the stars twinkle? Think about it. Why do the stars twinkle? Why do they say the stars twinkle? Because there's turbulence in the air.
Yeah, it's turbulence in the air. Yeah.
Yeah, because you're looking through discontinuities, as I would call it, or inhomogeneities of the air.
But so say you'll have the sun. Because the sun only gets squished at the last moment.
It's wibbling and wobbling. It's not uniformly curving. It's wibbling and wobbling, right?
But the sun stays nice and perfectly round until it gets right at the horizon, then it squishes because it's going through a dense gradient of atmosphere. That's the idea.
Okay, that's no. It's not the density of the gradient. It's that where you're going to have the most amount of convection is going to be near the surface of the Earth. So you're going to have the most amount of turbulent air. No, because it's not density as in like spherically symmetric where it's just a vertical density. The density is also going to be horizontal. This is what you guys aren't getting. There is a horizontal. It's not a gradient. It's random fucking pockets of air. This is in the literature,
Random
this is in the peer-reviewed academic literature for surveying and everything, dude. It's in the literature.
No, I'm not disputing that. I'm just saying when I watch the sun go down over the coast, and I'm in California, I've seen it 100 times over the West Coast. It right at the last moments, it gets all contorted. Not until then, though.
Yeah,
fine
but
until the last
in your model, you're not even looking at the sun. You realize that you're not even looking at the sun in the globe model.
It's not even there.
Do you realize that you're not even seeing the sun?
Well, yeah, in the last moments, yeah, exactly.
No,
it slows down.
Way before that.
Okay, fine. Yeah, well, the light's
So the sun is supposed to be like when the top of the sun, right? Say the top of the sun, where you can see the sun, touches the horizon. The sun is supposed to be 0.83 degrees under the horizon, which is bigger than the sun. But that's bigger than the sun.
Okay.
Right? So that's a sun and a half. Right? So when you see the sun at the horizon, the sun's not there. The sun's under the horizon already. You're seeing the projected image of the sun up around a spherically symmetric Earth caused by a spherically symmetric density gradient.
Yeah.
That's absurd.
Why?
Okay, because you would see other optical effects. You would see dispersion. You would see magnification. You would see shit getting smaller, shit getting bigger, not just swishing into a line.
It also gets bigger.
Well, I mean, every Glober's been saying the sun doesn't change angular size at fucking sunset for, I don't know how long now.
Well, it doesn't change angular size in the way that you would expect if it was going far away. That's what we're saying.
Oh, okay. No, they say it doesn't change at all, which is horseshit because that's actual horseshit. It actually does shrink. But anyway, whenever some Glober's posted a video saying, "Hey, why doesn't it just fucking change in angular size of this video?" Then I go in the video and I freaking measure the pixels. It does, like every time. So before we got off on the sun, Steve, there's more evidence of this vertical compression than just the sun, right? So there's a couple of pictures that have been taken, right? So one is across taken in infrared. So it's infrared. They take a picture across the Gulf. It's called the Gulf of Leon. 140 something miles to this mountain called Mount Ventoux. They took a picture in visible light. They take a picture in infrared. You can see in visible light the mountain is compressed compared to the picture in infrared. Then on top of that, right? On top of that, you can see features on the seashore. Specifically, there's windmills, right? A row of like 20 windmills. And you can go onto Google Earth or Google Maps or whatever, right? And you can say, hey, from one end, from this viewpoint, the windmill farthest on the left, the farthest on the right. You take you take the radius of the circle. You say, okay, what angle is this, right? So this distance between these two should subtend, like fucking say half a degree. How many pixels? Count the pixels. Oh, it's 200 pixels. And then you can take that, right, that distance, that pixel distance, and you compare it to the vertical. There's something like a 15% difference, right? So if you take, this is a mile horizontal, is 200 pixels, and then I flip it and go, well, 200 pixels should be a mile vertical. Well, they're not. Then when you look at the mountain, like this mountain isn't even a mile tall. Like why? Like this is not a mile. It's not an equivalent, right? So that's the point. We know from other reasons, right? Other things other than just the sun, that things get compressed in the distance. And that's not consistent with a spherically symmetric atmosphere either. And that's just one off the top of my head. The other one's San Jacinto. So San Jacinto is a 137-mile observation in infrared. And then if you take the picture in visible light, you can't even see the mountain at all. Whip out the infrared, boom, there it is, right? And if you measure, there's a bunch of different peaks all around. And if you measure the vertical versus the horizontal, it doesn't match. Like that's off by 10%. And even on the same mountain, it isn't even consistent on the same mountain. So we know things get vertically compressed just from the air. But it isn't because things are being lifted up over the curve of the earth. That's something that's like that claim. There's no evidence for that. There's no even in the literature, like you can look at the academic literature, like there's nothing. It's just like shit they put in textbooks, right? They put in textbooks, they put it on websites. But if you look at the literature, it doesn't say any of that shit. The only way you'll find any reference to it is like in astronomical journals where they have their models for how far stars are displaced because of refraction, and like that's just a consequence of the model. It actually goes infinite at frickin' 90 degrees.
India.
When I say 90 degrees, oh yeah, go ahead. Sorry, I was fucking rant forever, dude.
So if you were going to make an easterly path, and come back to the same point, what kind of shape would that path have to be?
What?
So,
if I was going to make any path and come back to the same point,
like an easterly or westerly path, and you arrive at the same point.
Yeah, I mean, depends on what your spatial reference is. Depends on what you're using as your spatial reference.
And in this case, we're just like imagining that you have a central point, and that every single you have to make a consistent 90-degree angle to that point, all the way consistently. That's what consistent means here in this context. All the way around, back to the same point you were at. I can only imagine there's one shape that would fit that description. And that would be a circle, right?
Yeah, a circle.
And if that's possible, all the way from the Drake's Passage to, I don't know, like Greenland, North Pole, or whatever, then to me that sounds like the known world can only be described as circular, right? The known world.
Not necessarily, dude. Not necessarily true. I'm not actually one of the people that believes that Earth is necessarily symmetric with the celestial sphere. I'm not even convinced it's a celestial sphere, quite honestly, because of the declination of the magnetic declination, right? So you get a compass and it doesn't match the celestial sphere.
Yeah, but I can't imagine what else it would be if that path always has to take the form of a circle, and it will always be consistent from Drake's Passage to the North Pole. I mean, it only sounds like between those 2 points can only be described as circular.
Hey, sorry to interrupt, but my buddy who's the surveyor made his way into the server, and he can see the VC, but he can't join. It says it's locked for him. Do you know what he needs to do?
He probably needs to like pick a role, maybe, or something like that.
Is there a mod in here who can?
Or there might not be. He might not like. It might. Well, listen. He might have to be here like a certain amount of time. I don't know.
Right.
Has he got his?
So we're mods, but we're only mods in this chat. We're not mods on the server. I don't come to this server super often, so I don't fucking know how shit operates over here.
Can he type in the text chat and stuff like that?
Let me see. It's just literally his first day.
Heretic is here, so Heretic knows what's up. Ask him.
If you can't,
the Heretic's in text chat, so you have to talk to him in there.
If you can't type in chat, it might be that he's not mobile phone verified, which you have to be.
Needs rank 2 is the word on the street. I don't know what that means.
I think he's on PC, and he had to put in his email to register. Rank 2.
He needs rank 2 to talk in this chat, so he's probably got to go spam some text channel.
Okay.
I don't mean literally spam. Don't do that. Probably get kicked out of here.
I think you can also sit in one of the public VCs, and that'll get your rank up as well.
Oh, I don't know how that shit works, dude.
Anyway, before he gets here, which will be imminent, I imagine, right? I can only imagine that sort of relationship could be described as a circle from between those 2 points everywhere on the surface of the Earth for every person.
Yeah, like if you have a central point and you freaking keep it 90 degrees from you have to trace a circle. I mean, that's not really mysterious.
Now,
assuming you're equidistant, right? I mean,
yeah. So I don't mind where that central point is. It could be Antarctica, Brazil, wherever, right? But all I wanted to establish that this would have to take some sort of form of a perfect circle for the known world. Whatever is beyond that point could be rectangular, triangle, whatever you want, right? Now, the next stage is like if the known world is going to take some sort of circular dimension, to allow for bearings, easterly, westerly direction to the same point, then I imagine that the only way, and this is going to sound similar to a previous argument I made, the only way Earth could be configured in terms of its land masses is radially, right?
They're completely asymmetric.
I mean, that preserves the most amounts of distances between land masses.
I mean, how do you know the distances?
Oh, flight path.
This is a recurring problem. Like, don't ask me, like, you don't think we can measure distances? Because it's a typical response. I go, how do we know the distances? You don't think we can measure distances? Well, we don't.
Yeah, okay. Well,
we don't, right? And so we have our radius, right? We go, okay, I'm at this latitude longitude, I'm at this latitude longitude, do the Haversine calculation. Oh, I'm 2,000 miles apart. Like, you don't know you're 2,000 miles apart.
Okay, right.
Right?
Well,
you don't really know that, right?
That's fine, because if you're going to take the position that we don't know distances, the distances may...
You don't, dude. It's not... This is objectively true. It's not like my opinion.
Yeah, that's fine. I actually
Who measured from New York to France?
It doesn't matter. Like, I agree that distances may be incorrect, right? But on that basis alone, okay, so it's different. Like, I've got to go down the whole thing because I expect someone to say yes. We do know that there's a similar path between South Africa and Chile as there is between Europe and Central America, right? And that flight paths confirm that, and shipping confirms that, and all those sorts of things confirm.
Yeah, that's cherry picking shit, though.
It's just an example.
When you say flight paths confirm it, how do they confirm it?
Well,
when they projected a spherical coordinate system onto a frickin' Mercator map, was that the confirmation?
Forget projections of the Earth. It's just the idea that
how did they confirm it?
Traveling at the same speed will be able to reach different locations at similar times, right?
Okay, and if they turn around and they go in the other direction, what happens?
It might knock an hour off or so.
Dude, the differences are huge.
What, between North America and Europe?
So, okay, say the Sydney to Santiago flight. It's 11 hours 45 in one direction and 15 hours in the other direction. But if you look at the bigger values, right? So the lowest I've ever seen the Sydney Santiago in one direction was something like 11 hours and 30 minutes. But the other way was like 17 hours and fucking 50 minutes or something.
Yeah, but
right. So that's a huge difference, dude. And if you're going to infer your distance based upon the speed, right, speed and time, then you're like, what the fuck, dude? This is a huge difference. How far are they apart? But then there's other factors.
Like, my English is actually so bad.
Okay, well, take your time.
I'm gonna type it for you. Wait.
We've got other new people as well. We got Fantastic in here. I don't know if I've heard the Nile speak. That should be fun. Eastomania, something like that. Welcome. Got Ryan Gordon in the house. Fresh in here. Welcome, everybody. Full house. Busy Sunday or Monday or whatever it is where you're at. Well, to all the newcomers, welcome to 24/7 Flat Earth. The Earth that you live on is indeed flat, stationary, and enclosed, as measured, as experienced. If you disagree, by all means, tell us why you think you live on a spinning water ball in the vacuum of outer space. We'll have a discussion about it. No problem. It's fascinating how it can be this quiet in here, and we have a lot of new people, but they don't say anything. But if we are talking with someone, and all of a sudden 10 people pile in here, and they just start saying, hello, I have something, I have a question, Flat Earth is stupid, you guys are retarded. When it's hot, it's hot. When it's not, it's not.
Probably the main problem here is just I'm not sure if
Hello.
I'm able to explain my opinion. Nice.
I'll give it a shot. Go right ahead.
So, what does it mean that Earth doesn't match reality?
Earth doesn't match reality? Okay, so the globe does not. Yeah, the globe does not match reality, meaning that the measurement of the surface of the Earth is flat and planar. There is no curvature found. And then, of course, there is the stationary nature of the Earth, meaning we all experience it to be very still. It doesn't move. Although the claim is that it's experiencing multiple different accelerations. One of them being the axial rotation, meaning it spins like a top, and then it orbits the sun, and then the solar system orbits the great attractor, and of course the galaxy is flying through space. So there's 4 different vectors or 4 different accelerations that we should be detecting in some form, and we're not. And then, of course, the experience of gas pressure that we have. Well, if we can breathe the air pressure on Earth, that ipso facto means that the sky is not a vacuum, because the gas on the surface of the Earth would be filling the available volume, which apparently is ever expanding, according to the Lord. So our experience is of a flat, stationary, enclosed Earth, and that does not match the globe at all. So let's just pretend for a moment that the Earth is really, really big, right? That's the claim. It's so big that you can't see or detect the curvature. Okay, fine. But the motion is going to be a big problem. So I would ask you, is your experience in reality that the Earth is moving?
Mine?
Yeah. Do you experience the Earth moving?
I'm not sure. It's just like probably I've never realized it.
You've never thought about it, right? But If you're sitting down in your chair, is your house moving? Is the earth moving? Think about it. You're in reality right now.
You know, I thought probably more about like Earth has ellipsoidal shape, and I watched a video from the ISS many years ago, and they said like is the ball is the most stable form in the universe. It is just everyone strives for the shape of a ball, so probably it's pretty fair. I mean, that our planet has something similar like that, but about Earth move, I don't know. We're just too tiny if we will compare. I mean, our planet or nation with others stuff.
Right. So that's what you're told. It's a great way for them to gaslight you. I don't know if you know what gaslighting means, but it's a great way for them to tell you why you don't experience what you should be experiencing, which is the motion of the earth. The earth does not move. It's not even necessarily something you have to think about. It is definitely stationary. So if it was moving, let me give you an example. Wherever you live, if you're closer to the equator, it's even worse. But wherever you live, depending on the latitude, and you're on a spinning ball Earth, then you would have a wind speed in the several hundreds of miles per hour. So why do you not have a wind speed or a breeze outside somewhere in the ballpark of 600-700 miles per hour?
Honestly, no clues.
Right. Well, that's because the Earth isn't moving. It's a very simple answer.
Well, probably have a point.
Yeah. Because the Earth is supposed to be spinning inside the air. And the air is not attached to the Earth. You can prove this by sticking your hand out the window of your car. Air does not stick to things, right? So if something is moving through the air, there's going to be a really stiff wind. If the Earth is not moving through the air, there will be no wind. Well, we have no wind, so no moving Earth. The only wind that we do have is from the differentials in air pressure, the hot and the cold, and they move around on the surface of the Earth. That's where we get our wind from.
So if it's flat, it has to be like a dead end, right? It has to be.
Yeah, probably. Yeah, somewhere.
Okay. So what do you think? Like, which country is like in the ledge of Earth, flat Earth?
Which country is what?
Like they're gonna fall from the map?
Fall from the map? How would anybody fall off of a map?
Like you think it's flat, right?
No, I know it's flat. No. It's measured flat. Everybody measures the Earth to be flat.
What do you mean? Can you explain?
So everybody who measures the surface of the Earth, like let's say the surveyors, there are, in my opinion, they are the best source for flat Earth measurements. The people who measure the surface of the Earth for the topography and the terrain, and distances and angles and dips and dives and hills and valleys and mountains. They measure the Earth as flat, and all of the valleys and hills are in relationship to that flat plane. Sea level is flat as measured. So everybody measures the Earth flat. That's a fact. Where the edge is, I don't know. And I don't even know if the edge of the Earth is something that...
Right?
Okay, well, let's just play with the idea that the Earth does have some kind of limit to it. There's no way to say that it would be a limit where you would fall off of it. Fall off of it into what? What we do have is gas pressure and water. So if we have gas pressure and water, this Earth probably is more contained inside of something, not something that you can fall off of.
I don't know. I think it's cube, bro. It's neither flat.
Well, okay, you think it's cute. I'll ask you, do you have any Earth curve measurements that you can show me and that I can validate?
No.
No, I think that's really cute that you don't have any Earth.
I'm just saying.
Right. Yeah, well, I mean, I'm not playing. So if there's no measurements of the curvature of the Earth, then it's not a ball.
But there is no measurements for like the sphere.
Where's the measurements for the sphere Earth? Where can I find those?
Yeah,
Where are they?
There's no measurements, bro. But everyone is saying it's sphere, like scientists and.
No, no scientists say that.
You sure?
Yep.
Okay, let me Google it actually. ChatGPT say that actually.
Okay, so ChatGPT, is ChatGPT a scientist?
No, but it's like.
No. Does ChatGPT do science?
I don't know.
No. Do scientists measure the surface of the Earth to be curving? Because I have not seen any scientist, I've never heard a scientist perform any experiment and claim and show that they measure any Earth curves. In fact, it seems like it's outside of the purview of science. Science only handles cause and effect relationships in the natural world. You know, we do experiments and stuff. Measurements of curvature, terrain, stuff like that, that's mostly geometry, if not all geometry, and a lot of it is trigonometry.
I don't know.
And that's what
Actually, I think it depends on some details. For example, we don't see or we can't feel magnetic fields. We don't even feel them in general, but it exists. And maybe it's something similar to the feeling of the Earth moon.
No, they're not even closely related. We can detect the Earth's magnetic field. You can do that with a compass. I can detect the magnetic field of the Earth. What I cannot detect is any motion whatsoever. In fact, Einstein said there is no optical experiment that we can conduct to prove that the Earth is moving.
Yeah, but I'm talking about exactly often feeling, because you know, compass just. I mean, um. Well,
here's a simple test you can do. You can download apps for your phone. They're tied to, there's an accelerometer in your phone. It's a little ball bearing inside a little cage, and it detects acceleration. So you can download the app, and you can put that on your phone, and you can set your phone on the ground, and you can see if there's any acceleration of the surface of the Earth using your phone. You'll see nothing. It does not move.
yeah, but I wanted to talk like the compass wasn't invented probably right away. So maybe for now we just haven't any special stuff to try fix it or just maybe find it.
There is no experiment that we have conducted so far, and I don't even really want to use the term experiment. We don't have any naturally observed phenomena of the motion of the Earth. We don't have any ability, any device, with all of our technology, to detect any motion of the Earth, with the exception of earthquakes. We can detect that.
Yeah, I'm talking about it.
Yeah, so earthquakes are not Earth's rotation.
So, do you think Earth is stable?
Yes, the Earth is stationary. I don't think that. I know that. I've stood on the Earth. I think you have too, and it doesn't move. It is stationary. It is stable.
But it's stable apart of what exactly? The sun?
Can you say that one more time?
Well, you said in your opinion the Earth is stable, but I wonder, it's stable about what?
I guess I don't understand.
Earth is flat.
It's not my opinion. The Earth is it's not my opinion. The Earth does not move. There is no evidence of it moving. Not any.
Then what about
Yes, it is.
There is actually.
It is.
Okay, terrific. So we have people coming in saying, yes, yes, it is. Great. Can you show me a measurement of the Earth's rotation?
It says using
Yeah.
GPS or satellite technology.
Thank you. Can you get me a measurement? Sorry, sir. Can you get me a measurement of the Earth's movement?
What do you mean measurement? Like meters?
No, I mean, can you get me a measurement of the surface of the Earth moving? What did you do to
we
test that?
We're moving around the sun.
No, I know that's the claim. How do you prove that?
Satellites can see from skies.
Okay, satellites. What's a satellite?
What do you mean? So if you don't believe in satellites, how do you believe in rockets?
I didn't say I didn't believe in satellites. I just want you to tell me what a satellite is.
You don't know what it is?
I want you to tell me what it is. You brought up satellites. I didn't. So tell me what it is. How does it work?
I don't know how does it work, man.
I'm asking you. You brought it up.
Yeah, bro. It sends signals.
It sends signals. That does not.
Yeah.
That's not how satellites work. I'm pretty sure. What do those signals do?
You can watch TV on your.
You can watch TV because of satellites. So, are you going to tell me how the satellites do what they do, or are you just going to tell me what they do and not explain it?
They send magnetic waves.
Magnetic waves now. Okay. Let me ask you this question. Is a satellite in outer space?
Mm-hmm.
Okay. How do you know that?
It's from space.
We can see it.
I saw the videos and shit.
You saw video. So you saw it on TV, so you think that satellites are in outer space, something that you saw on TV.
Bro.
You can see
It's
it
like
with-
NASA, bro. It's like NASA. They can go.
NASA. Now we're on to NASA. I thought we were on satellites.
with a
Yeah, it's
telescope,
same.
for
It's the
example.
same, bro.
I've never seen a satellite with a telescope, and I have used a telescope many times.
You should try, sir.
Okay, I already have. I just told you that. I guess you're not listening. I have
You
done
are
that.
saying you believe NASA sending their like rockets to skies?
No,
believe
we're still on satellites. Now you're on to rockets. You got to stay on one topic at a time.
Say, bro. It's actually.
So you guys believe that NASA is sending some kind of technology into the sky, space?
Yes.
You said you.
Okay. No, I didn't say that.
You don't?
You said you saw it like.
No, I said, I saw a rocket launch. But I don't believe that NASA is launching technology into the sky, being tethered by a force, non-force called gravity, around a sphere Earth. The thing that you would need for the beginning of all of this tale, this big fantasy Santa Claus tale that you believe in, is a sphere Earth. Sorry, friend. I need you to go ahead and help me with the base of this claim. Apparently, there's some technology being tethered by an invisible, non-material force, non-force called gravity, and these pieces of machinery are... Excuse me, I'm not done. These pieces of machinery are going around a sphere Earth. So what we need, first of all, is a sphere Earth. Can you guys show me any measurements of Earth curve, please?
First of all, are you denying gravity?
Okay, so if you don't have any Earth curve measurements, just say so, and then the entire story falls apart.
I'm just asking you a question.
I'm asking you a question, but you don't seem to want to answer it. Do you have any Earth curve measurements? I'm asking you about your claim of satellites. We've already kind of discovered that there's a story behind the satellites that you believe in.
Listen, I don't have it at the moment.
Okay, so if you don't have any Earth curve measurements, then the Earth must not be a ball, because everybody else measures the Earth to be flat. So the first biggest part of your story, what is gravity? Why don't you tell me what it is?
No, you just say a non-force.
No. Well, yeah, no, I didn't say an unknown force. I said a non-force force, which is what it's claimed to be. It's a non-force force. It's actually a geometry. Can you tell me what gravity is so I can believe in it with you?
It's a force.
Is it? Okay, so gravity is a force. So you deny Einstein now. You think Einstein was a hack?
No, I'm...
No?
Okay.
Because Einstein says that gravity is not a force.
You deny Isaac Newton?
No, gravity is just a force, a physical force.
A physical force. Okay, can you give me a sample of this force?
When you drop something.
Yeah, that's not a force, friend.
It is.
No, it isn't. See, this is how we have a problem here. That's called an acceleration. When things go down, that's acceleration. It's not a force.
It's a physical force that attracts to the objects.
Okay, a physical force that attracts two objects together. Great.
Yeah.
Can you show me evidence of this and how they discovered it?
Grab something and throw it.
That's people throwing things. Now, see, you've applied the force. So when you throw things, you're applying a force to the object.
Just let it go. Just drop it. Like.
Oh, let it go. Okay, so now there's an acceleration. Is that acceleration due to any force?
Call it acceleration if you want. It's
not force, it's acceleration. It's gravity. So you are saying that when things go down, that's gravity.
Yes, because the mass and the mass of the Earth is bigger than yours. That's why.
Oh, how much?
To the Earth.
Great. So what about when things go up? Is that still gravity?
No.
No. What is that then?
Wait. What things goes up? For example.
Well, currently, like the air that you're breathing right now, it's moving freely and randomly in all directions. It's going up, down, side to side. It's doing all kinds of things.
No. Wait.
What about when I let go of a helium balloon? A helium balloon goes up. So is that gravity?
The Earth goes around the sun because the sun has the sun.
I know, friend. You slow down. You're making a different claim now. You're talking about the Earth going around the sun, which is a claim, but you have to prove that. We'll get back to it. What about when a helium balloon goes up? Is that gravity?
With that, sorry, my English is a helium
balloon. You know, like at little kids' parties, and they blow the balloons up, and sometimes they let them go, and they go up. Is that gravity?
Well, I mean, what do you because that gas is how do you say this? it's a principle of.
No, but wait, you said to drop something. So we grabbed something and we dropped it. We let go of it, and it didn't fall to the ground. Now you're making up excuses as to why.
The gravity, helium has less, how do you say this, less mass than the air. So
mass. What is mass?
Wait, the air descends and the helium is pushed to the sky. That's what happens.
Pushed? What's pushing it to the sky?
Because the air goes down.
No, the air we already discussed is going freely and randomly in all directions. That's why you can breathe.
No, air.
No.
Air is. Do you know that air, like air, uses space? Like it has its own mass.
What is mass?
I can't explain everything.
Well, these are the terms that you are using. I would like to know the definitions of the terms that you are using, and I know that English is not your first language. But if you say mass, what is mass?
Wait. First of all, I'm here just learning English, so that's why I can explain everything. I'll try. But it's just a measure of how do you say this in English? Material.
So it's a measure of the amount of material. So if I show you a citation from the physicists that say that is incorrect, what are we going to do?
I will learn.
Okay, you're going to learn today.
Okay, tell me.
Just a second. I'll get it for you. Unless somebody can beat me to the punch. Just a second.
La, 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 la.
Bear with me. I am driving and I'm trying to do this at the same time. So, trying to
What are you
avoid
trying to
it.
find, says who? What are you looking for?
Oh, the citations about the amount of material does not equal mass.
By the time the truth surfaces, it doesn't feel like a twist. It feels like yeah. I'll see what I can find. Yeah, I'll try to bring it up. All right.
And who made that? How do you call it? Citation?
Oh, you'll see. I'll give you the citations with the links. These are all from physicists' textbooks.
I can show you a clip of a physics teacher saying that they don't even know what mass is.
Here we go. Probably going to have to do this in small sections. Otherwise, I'll get flagged for spam.
The citations about mass.
Yeah.
Yeah, I pasted them in there already.
Okay. The amount of matter not equaling mass.
Yep.
Yep. Okay, so in the side chat, we have some citations for you that tell you that the amount of matter within a given area or volume or whatever does not equal mass.
What masses?
Sorry, did you ask a question or?
No, I'm just reading.
Okay.
Sorry. It says in scientific context, mass is the amount of matter in an object.
What?
Yes.
Where?
No, it says in ordinary language.
In common usage, the mass of an object is often referred to as its weight, though these are in fact different concepts and quantities. In scientific context, mass is the amount of matter in an object.
Yes, keep reading.
Though matter may be difficult to define, so now we have to define matter if you want. But it
Whereas
says,
weight is the force exerted on an object by gravity.
but in scientific context, mass is the amount of matter in an object. So,
no. Where do you see that?
Oh, DJ, pass that.
That's from Wikipedia.
Ah, shit. You pasted something that doesn't agree with your argument. Fuck.
Well, we have conflicting statements because you'll find Britannica stating that it's that mass is
But says who? Did you pass the citation?
resistance to acceleration.
Yeah.
So I guess just mass is just whatever you want it to be at the time, whatever purpose you need it to serve, right?
I know you're being facetious, but from an engineering point of view, it's pretty accurate.
Yeah. Because these are just conventions. They're just ways to think about things. Doesn't mean that they have actual physical property. Right?
Usually mass is
material. Right. Yeah, go on, sorry.
Usually mass is conflated with weight, but weight is also arbitrary depending on the medium which it's in. So mass is not defined, weight is arbitrary. Neither of these have any ability to attract or repel anything. Concepts, these are concepts.
Yes.
Okay, so concepts don't do things.
Sorry, what? Could you repeat?
Concepts do not do things. Concepts only exist in the immaterial mind.
Yes, that's a definition of concept. Yeah.
Yeah. So
I can show you.
Concepts cannot have any actual consequences in the physical world.
No, because that would be a definition.
That would be reification.
Reification fallacy. Yeah. I can show you a physicist telling you that you can think of gravity as a force. It doesn't mean it really is a force.
I mean, force is a concept of humans. So
is gravity. Unless you're talking about a phenomenon, an occurrence that
you can use that concept to explain things. Because if we start saying that
doesn't mean it's true. Doesn't mean it's true.
You're just using a term for something that is true.
It's a little bit more
magical fairies. Replace that term with magical fairies. You're going to get a different result?
No, because everything could be a magic. How do you say it? Magical fairies? Gravity is just one thing.
No, gravity is only geometry. It doesn't exist. It does. The description of what gravity is supposed to be is conceptual only. There is no force of gravity. There is no gravity ever detected. It's just an idea.
The chat is just. So, what is gravity for you? Just how do you say geometry?
There is no gravity.
There is no gravity.
Nope.
And I love this guy. And when I drop something, why does it fall?
They're still trying to figure it out.
It's more dense than the air. That's why it goes down. Now, if you take an object, let's just say like a block of wood. If you drop a block of wood in the air, it's going to go downward. If you take that same block of wood and you go into a pool or a lake and you take it to the bottom of that pool and let go of it, it's going to go up. It's all about the object and the medium that it's in. That will determine whether or not it goes up or down. That's it.
How do you measure the dense? That how do you say this in English? Dense.
Well, density is another property. It's a description of material, right? So air is not very dense. It's particles in the gas are fairly spread out, right? If you go to water, it's more condensed. There are more particles within an area. It's more viscous. It's a heavier fluid. These are ways we describe it.
So we can describe. We can use the concept of mass with that definition.
No.
Yeah.
Because mass is undefined. Mass has two actually definitions. One definition is the amount of matter within a given area, which we found out doesn't actually equal mass. The other thing is a resistance to acceleration, which happens to be the same definition of inertia. So you have two definitions that still do not actually equal mass. Like I said, it's always conflated with the idea of weight. And weight typically is describing, let's say, the amount of acceleration something has within a given medium. In this case, most people weigh things in the medium of air, and they give it a value about how much it accelerates downward.
But weight is a force that the gravity of the Earth attracts.
So a force causes a force. I thought gravity was the force. Now weight is the force that's caused by gravity. So a force causes a force.
No. I mean, I said that the weight of objects are caused by a force, which is gravity.
There is no force.
There's citation in the side chat there that was getting read out by, I don't know if it was you or somebody else. Let me get back to it. It says, whereas weight is the force exerted on an object by gravity. Is Wikipedia wrong about that?
It is right, but you're not taking.
So weight is a force. Is weight a force or not?
Technically, you can say it. But
is gravity a force?
It's fundamentally a force.
So,
it's
so the force of gravity causes the force of weight.
They're different.
So a force causes a force. So we have weight as a force caused by gravity, the force.
It depends on mass as well. Gravity does not depend on mass.
Well, now gravity doesn't depend on mass, so we're throwing mass out all of a sudden?
Maybe.
No. You guys got to get your story straight. Which one is it?
What?
Well, you guys are disagreeing now. You have to figure out which one of you is correct.
I said weight is just a force that is attracted. It's the force. Wait.
Do people just prove your Earth is flat or something?
Well, somebody was telling me that there's magical technology being tethered by a force, non-force, as I described it. Now you guys are arguing about it. It's a force, but it's not a force, called gravity, and those are hurling around the globe Earth. But now we don't have a globe Earth because nobody had any Earth curve measurements, so there's no globe. And if the Earth is not a globe with a mass that creates the force of weight that is a force, right? You see how this is all messed up?
Weight is the force
The thing is, your mass remains same everywhere, but your weight depends on the mass of the planet.
Well, how much mass does the planet have?
It depends.
What do you mean it depends? It doesn't have a fixed mass?
It has a fixed mass. It changes.
Okay, so it changes the weight? The Earth does?
Yeah.
Can you show me an experiment validating that, please? I want to see that in an experiment.
I'm saying that. The mass.
I don't want you to say it. I want you to prove it. I don't care about what you say. I want you to prove it.
Listen to me.
No, I'm not going to listen to you. I don't want you to repeat yourself again. I want you to show me how you can prove that.
I'm asking
you can prove what? The mass of the Earth?
Yeah, sure. Let's do that. How big is the Earth?
How big?
Yeah.
17,000 miles, I think.
70,000 miles what?
The diameter of it, I think. Not really.
The diameter is 70,000? No, it's not that. That's incorrect.
17, I said.
Oh, 17,000 kilometers diameter?
Yeah, maybe.
I don't think that's right either.
You can say Earth is 6. How do you say this in English? Quadrillion? 4 trillion? I don't know how to say this.
24,901 mile circumference. There you go. I helped you out.
Okay, so you have a claimed size of the Earth. How are we going to get weight from that? You know what? In fact, let's see if that's correct. So we have a radius, we have a circumference, we have a diameter. So we should be able to measure and see if that's correct. Can you guys show me how we measured the surface of the Earth to have curvature consistent with those figures?
I mean, you don't to calculate the mass of the Earth. You cannot. You have to use gravitation.
Well, how would you be able to calculate a mass? Remember, we don't know what mass is. Is it the amount of material, or is it weight, or is it resistance to acceleration? Which one is it?
Mass is just a fundamental physics concept that measures the quantity of material in an object.
So now we're back to it's the amount of material. Okay, fine. So we have an amount of material. We're back to an amount of material, even though we've shown citations that that's not correct. But we'll go with it, no problem. So how much mass is the Earth, and what units are we going to use? In fact, we should go back to the first question. So we know how much to calculate. Can you guys measure the surface of the Earth for me and show me how much it's curving? And if it's consistent with the size that they're giving us, then we'll go ahead and calculate it.
What? Sorry, what?
How are you going to calculate the amount of mass, whatever that is, of the Earth without knowing its actual dimensions?
You just yeah, I know where you're going. Because you use the, how do you say this in English? You use the surface of the Earth.
Yeah, the surface of the Earth. You measure it to make sure that you have an actual figure to deal with. So, who has measured the surface of the Earth as a sphere with curvature, that meaning drop over distance, consistent with the figures that were given? Who has done that?
The satellites.
So you're going to say that it's impossible to measure the mass because we don't know the surface of the Earth.
I mean,
because the Earth.
No, actually, we have measured the surface of the Earth. It measures to be flat.
Who said?
So that means that all of the figures that you have about the diameter, the radius, the circumference are incorrect, and so now you don't have mass. Now what are you going to do?
The fundamental gravitation law states that gravitation.
Bro, you're chanting. I need you to get me the size of the Earth. I don't need you to divert from this. I want you to get me the size of the Earth so we can calculate mass, whatever that is.
5.97 times
get
10. How do you say this?
Get the outer surface from the satellite imagery and sensors and fill it with the mass.
No,
can you listen, bro?
Of the
like I said, we need the dimensions of the Earth so we can calculate how we're going to make these little machines orbit the Earth. So where is the ball Earth that we can measure so we can get all of our math right?
But
you realize you actually have to have the dimensions of the Earth correct to send up satellites in the first place? I need you to measure the surface of the Earth first.
You want to know the surface of the Earth?
Yes, give me the Earth curve measurement so that we make sure that we know how big a ball we're standing on.
I'll try in English. 510 millions of kilometers.
510 million kilometers of what? Surface area?
Sorry, how do you say this in English?
No, we want the methodology by which it was measured and the result that they got.
510 million square kilometers.
Okay, so that's the claim.
Yeah, you're giving us the result.
I want the measurement. Who measured that?
Who or how?
Both.
Let me check.
And when?
We have that surface because of the radius of the Earth.
Friend, I need to know how they determined there was a radius. That means that somebody measured a drop over distance because it's supposed to be a ball. Who measured the drop over distance of the Earth so that we know that we're on a ball of that size?
We did the. Oh. The Earth is. It says that the Earth is almost I swear. How do you say it?
Please don't give me another number or a claim without you giving me Earth curve measurements first.
It says that we measure the radius of the Earth because it's almost a sphere.
Thank you. How did they do that?
Yeah, there must have been a way that they got those numbers. Did they just pull them out
Are
of
you
the air?
are you asking
Make 'em
how
up?
do they measure how do they measure?
Yes.
Because they
Yes.
don't
How
know
did they
how.
get those values, friend? How did they get the numbers? They can't have just like guessed it.
Well, it says Eratosthenes. How do you say it?
Eratosthenes. Great.
Yeah.
So what Eratosthenes did is he made two assumptions. Number one, he assumed the sunlight was coming in parallel. Number two, he assumed that the Earth was a sphere in the first instance. Then he apparently measured two shadows of sticks, meaning he measured elevation angles on a flat Earth. And then he made a great circle. And then he... I don't know why you're talking through me. Like, you're rude, man. Why are you doing this?
Sorry?
Why are you being so rude? I'm just curious.
Rude? Why?
Well, I'm trying to describe to you what Eratosthenes did, and you're laughing and talking through me, and I'm just curious as to why you're being so rude.
Well, first of all, I know what Aristophanes did, so yeah, and
Okay.
I just make a compliment of you that you're so cultured.
Yes. Well, yeah, okay. So instead of cultured, you can say educated or informed, right? Cultured doesn't quite fit, but I understand what you're saying. I appreciate the compliment. So if we know what Eratosthenes did with his two assumptions, and then he made two assumptions and measured angles on the surface of the Earth, meaning that he used the Earth as flat to get the angles, and then created a great circle, and then assumed that that circle was the circumference of the Earth, why would we think that we live on a ball if everything that he did was either assumption-based and flat Earth measurements?
It wasn't because he liked to fine wine and sweet violin music.
Because in China, not long after that, the Chinese did the exact same measurement or calculation. We're going to call it a calculation. They assumed the Earth to be flat and that the sunlight was divergent, meaning it had a radian or separated angles, right? And they measured a flat Earth. So Eratosthenes and the Chinese, depending on their assumptions, still are not measuring Earth curve. They're making calculations based on assumptions. So the only way for us to know if we live on a sphere is to measure drop over distance consistent with a radius of 3,959 miles. And there are no measurements of that. In fact, it's quite the contrary. All the measurements that we do take are measurements of no drop over distance. And if there's no drop over distance, then the Earth is not a sphere. And if the Earth is not a sphere, then we cannot calculate whatever mass is.
Their heads exploded.
Maybe. It's a lot to take in all at once. I'm sure you guys still think I'm wrong, and somewhere there's a magical scientist, a priest of the globe that will save you with something. But don't worry, we've already checked. We've been checking for, I don't know, 10, 15 years. Huh, they ran away. That's interesting.
Yeah, they forfeited.
T-Dub, I think that's a dub.
I think so.
Hello. Hello.
What's up, Paradox? How's it going?
Yeah, it's good, man. All good for me. What about you?
Sorry, say again.
Yeah, everything good, man. What about you?
As best I can be. Don't worry about it.
I see. Amazing, man. So, T-Dub, bro, I have a question, man.
Yeah, shoot.
Yeah, so how can a person distinguish between science and pseudoscience?
One has validation via the scientific method, and the other does not.
So who's supposed to test those methods? We ourselves or the scientist?
The method is agreed upon and developed series of steps which allow for very little to no bias, and it is formulated in such a manner that you will only get one of two results, where X causes Y or X does not cause Y. and that is it.
I see. Cause and effect.
Yep. Yeah, pseudoscience is defined as a set or system of beliefs mistakenly regarded as being based on the scientific method. If something sits beneath the title of natural science and and there's no scientific method involved, sorry, and there's no scientific method involved, then you can safely call it pseudoscience. It's masquerading as natural science when indeed it is not. And it's an insult to people, that are actually utilizing the scientific method in order to gain knowledge. Does that mean there aren't other ways to gain knowledge? No, it doesn't. There's other means by which you can gain knowledge. And some of those things, like, they do have the title of science, right? That's fine. You can call it science if you want. Because science has etymological roots in the meaning for knowledge, right? It just means knowledge, right? The acquisition of knowledge.
Yeah.
Like there's computer science, right? They call it computer science. You can get a degree in computer science.
What do you think about tectonic plates? Do you think it is a pseudoscientific concept?
Tectonic plates?
Yeah.
Well, if it has any scientific validation, I'd like to see it.
You cannot see it moving. You cannot see them moving. It takes millions of years.
Oh. It takes millions of years, does it? Oh, that's interesting. Who's old enough to... Yeah, nobody's old enough to have witnessed it then, I guess. How are they coming to the conclusion that that these plates shift?
They looked at Mount Everest and they thought that these mountains are there because India collided with Asia at some point of the time in the past.
So it's just a theory.
Theory backed by scientific experiments. On models.
What experiments did they perform?
Maybe not experiment, but models. So they run mathematical model regarding this. Probably.
I see. Like a computer simulation.
Yeah, like a computer simulation. You know about Pangea, right? Supercontinent.
Yeah.
Yeah.
I think they're just taking a wild guess. Plus, they think they live on a ball. It's funny how they decided to call it tectonic plates instead of bowls.
These aren't balls, right? They are just these are just plates, surfaces.
Right, but if they're surfaces of a sphere, then they're bowls. They're sections of a sphere. So they'd be like, if you took them off the sphere, it'd be a bowl. You could pour your cornflakes and milk in it and eat out of it.
No, it won't be a ball. It would be more like broken eggshells, pieces of broken eggshell. Like, you know how they curve?
Yeah. Well, generally, I call things like that, a shape like that, a bowl, and I call flat things, plates. Well, they're relatively flat. You know what I mean? Yes. They may have lips, and at the edge, but generally they sit on your table nice and flat.
When they're modeling seismic plates and things like that and earthquake activity, they're just taking data and then they're inputting it into a spherical Earth model, right? You could take the same data and put it into a flat Earth model or any type of model. That's what.
Yeah,
but it's not really proof of a globe in any way. Same with the Pangea, theory as well. While there may be some interesting coincidences and maybe some merit to it, I don't necessarily disagree with it to some extent. I don't agree most likely with the entirety of their claim of how it came to be or it happened or anything like that. There's definitely some interesting points, when you look into it. But it doesn't necessarily mean that the Earth would have to be a globe at all.
So how were the mountains created, according to you? Because that's how they explain the creation of mountains through tectonic plates. Hello?
I don't know. I don't know that it even has an answer. I wasn't around when they formed, so I couldn't tell you.
Yeah. T-Dub, man, if you see the side chat, the GIF that I've sent, we can observe that the outline of South America
I saw that,
yeah, matches pretty well with Africa, the outline of Africa. So it makes sense to believe that at one point of time they were the same continent. Don't you think so?
I don't think so. I think that's wishful thinking.
I see. But do you even accept these maps? Do you believe in these maps?
They might have a rough idea.
Yeah, which maps are you talking about?
World map, man. World map.
Yeah, which one? Which one? There's hundreds of different ones that have completely different layouts, right?
I don't think so, man. There's a standardized map used everywhere.
Oh, really? Okay, post it.
Wait, let me send it. But you know, man, what I'm talking about.
Yeah, I know exactly what I'm talking about, and I know what you're talking about, but I don't think you know what I'm talking about.
The world is a cat playing with Australia. Have you seen that meme?
Mm-hmm.
This one that I posted on the site.
Right, and do you think that that's accurate? Do you?
Yeah.
No.
Yeah. Yeah.
Well, actually, no, it's not accurate. All the continents are completely wrong sizes on it. Okay, so have a look at this. Right, so it's really, really far off being accurate in any way. Now, this is just one of hundreds of different projections, which all are wrong and all have huge distortions depending on which type of projection it is. Right, this isn't the official map that's meant to be the real map. Okay, obviously all the continent sizes are completely wrong on it because it's a spherical coordinate system based off the sky, basically flattened out, right? Inverted and then flattened out as a terrestrial projection.
Yes. That's why distortions exist.
Right. Yeah. So this isn't the official world map or something like that. It's commonly used, but there's hundreds of different projections. Okay, none of them were made because someone went out and actually mapped the entire Earth, right? They didn't go around in planes and ships and doing surveys and things like that and come up with this, right? This is a spherical coordinate system flattened out into different types of projections that have different uses, right? This was originated taking angle measurements to the sky, to stars and the sun. So Obvious just posted, right, a picture. Okay, that's all the different projections, or most of the different projections. Huge variations, right? They're all wrong, right? All maps are wrong. Okay, and we don't want to mistake maps as the territory either. That's a fallacy, right? That's incorrect logic to do that. Okay, maps are useful. Maps are tools, right? But there's no perfect map or anything like that.
So how did the Europeans reach Australia and colonized it, according to you?
Yeah, so there's a big lake, right? And then they're on one island. Call it a continent if you want, right? Then you get on a boat and you sail. Okay, and then they found another continent. There we go. Mm-hmm. Yeah, it was already colonized, by the way.
Void, relax, man. Hey, Void, relax. Just sit tight.
He's muted, bro.
Yeah, it's probably an appeal to be unmuted. Well, just hold on.
I see.
Why would the Earth have to be a globe for someone to discover a different island? Or a different continent, whatever you want to call it.
No, I was just trying to debunk your claim that everything is false. And
no, I didn't say everything's false. This is mainstream facts that all maps are wrong. You can go on YouTube right now and type in all maps are wrong. Okay, you're going to see probably hundreds of different videos explaining, right, why all maps are wrong and how the map isn't the territory. You shouldn't mistake the map for the territory. The maps are tools.
Should we unmute Void?
They keep joining and leaving over and over again?
Might be text muted as well. Probably just trying to let us know. Hey, unmute me. I want to talk. You can always remute.
Yeah. Void. You're out of the void.
How do magnets work?
Magnets, I don't know, they create a magnetic field. I haven't gone deep into the study of magnets, to be honest.
Because of the North Pole and the South Pole and the magnetic field of Earth.
Yeah, that's what I just said. Yeah, well, that's just magnets, right? Not you said how do magnets work. It doesn't have anything to do with the Earth, right? You can have a magnet, right? You can have just a little magnet. It still has a north and a south pole and a magnetic field. Right? It doesn't have to be the Earth. Right? The magnetic field on the Earth doesn't match up with the globe anyway. It's not like where true north is or true south is. That's where the magnetic pole is.
So according to you, all the world's governments have this conspiracy theory that portrays Earth as spherical instead of flat, right?
No, nobody said that, bro. You just don't put words in our mouth. Okay, I don't think people at the government are necessarily all lying or anything like that. I think they genuinely believe the Earth's a globe because they probably never checked, right? The government is just a huge organization of different people. Okay, they probably learned the Earth was a globe growing up, just like I did, just like you did, and they probably never tested it.
Bro, they have $1.5 trillion of military budget. They send like all sorts of satellites in space. Not just the US. The Russians do that. North Koreans do that. The Chinese do that. Iranians even do that. You're telling me the countries that are hostile to each other, are arch enemies to each other, want to kill each other's leaders, are somehow collaborating with each other. They have like ballistic missile technology that require you to know aerospace technology, and they are required to know if the Earth is spherical or flat. You're telling me they spend hundreds of billions of dollars every year.
Can you remind me, what does ISS stand for again?
International Space Station.
International, right. So, do the Russians board that sometimes?
No, it's a collaboration between the Russians and the Americans.
There you go. You just asked why.
The arch enemies are friends when it comes to space.
Obviously, they do.
Okay, put Russians aside. Let's take North Korea. North Korea is completely isolated. How about that? Or the Iranians? Iran is how hostile to the US and Israel, to your current world order. They have no incentive to cope up with your bullshit. So they spend billions of dollars every year in this technology. You're telling me they're money laundering? This is the biggest financial fraud in history. Then this is the biggest financial fraud in history. Trillions of dollars have been wiped out. That's
governments would never commit financial fraud. How could you suggest such a thing?
No, they would obviously do that, but this is another one, right?
Oh, how could they do it when they would obviously do it? But how could they do it? You're kind of contradicting yourself there.
So not only the Americans are committing financial fraud, the Iranians are committing financial fraud.
Governments committing financial fraud? How could you suggest such a thing? Governments collaborating with other governments? Crazy. Well, the water still measures flat when we go out and empirically test it. Okay, no, you can use a spherical coordinate system.
Iran and North Korea, they have no incentive to align with your government.
Okay, so pick any satellite that North Korea owns, right, and validate it that it's in space. Go ahead.
They have zero incentive to lie to anybody.
What have you confirmed about what they're claiming?
I've seen rockets.
North Korea would never lie, would they? Yeah, you really trust North Korea with all your heart, don't you?
No, you need. No, even if you don't send satellites in space, even if you're using rocket technology, you need to know the curvature of Earth. You need to know if the Earth is flat or spherical. You can't have rocket technology or aerospace technology without it.
Really? Why not? What would prevent you from launching a rocket up on a flat surface?
because like it needs to break the Earth's leave the Earth's atmosphere. So you have to
really?
calculate
How can you confirm that where does the Earth's atmosphere end?
So why do you even believe that Donald Trump is the president of the United States?
Answer the question. You just said it has to break through the Earth's atmosphere and leave the Earth's atmosphere. Where does that happen? What height?
Look, I'm not a rocket scientist. I don't know the specifics of it.
Clearly, you don't know what you're talking about.
No. Are you a rocket scientist?
No. Studying
this. This is like basic knowledge, man. This is baseline.
You did.
Okay. If it's basic knowledge. Yeah, if it's basic knowledge, right, and you don't know the basic knowledge, so why?
No, I don't know. I know the basics. You don't.
Why are you using it to make an argument when you don't even know the basics? You don't even know where you just.
No, I don't have to specifically know how far Moon is from Earth. I don't need to fucking know that. It's like
really? You don't even know that?
No, it's like 600 something thousand kilometers away. I don't need to fucking know the specifics of it.
It's not
even 600. No, sorry, 6 million or something. I don't know. I don't need to know how.
You're not even close with your guesses, bro. Like you if you want to come in here and make claims as if you know what you're talking about, you should know what you're talking about.
No, how does the distance of a moon has any?
You just brought that up. I didn't mention the moon. You said that rockets have to go up and leave the Earth's atmosphere, right, and break through past it. And I said, where does that happen? Right, and you said you have no idea, you're not a rocket scientist, and then you started talking about the moon for some reason, which you also don't even close to know the distance to. So I'm just wondering why you're in here, way over your head, making silly claims that you know nothing about.
No. Do you know the 10th number of pi? I don't give a fuck what the 10th number of pi is.
Well, that's got nothing to do with this.
No, it has exactly to do with what I'm saying. Why would I need to know
what does pi have to do with rockets? What does pi have to do with
exactly has to do with what I'm talking about. Why do I need to know how far fucking Mars is from Earth?
No, this has nothing
if I'm not
to do
a rocket
with Mars.
scientist.
Okay, well, why are you in here making claims about rocket science?
Because your arguments they are illogical. Look.
Really? Water tests as flat. When we go out and test for curvature, there's zero curvature. Okay, so whatever is happening with rockets going up into the sky or anything like that is happening above a flat surface. That's being confirmed. We have empirical evidence. I don't know if you know what that means. Okay, but we have thousands of tests now that all show zero curvature. Right, so you can come in here and butcher your claims if you want, but it's not really going to benefit anybody. It's just going to make good content for us on our YouTube channel, that's all. So thank you. I'm going to go watch a movie with my wife. You have a good day.
Look, if what you're saying is true, any hostile government would have already debunked it, like Iran or North Korea. Okay? Isn't it surprising that they didn't? Because it's absolutely flat Earth is not the truth. Like, Earth is spherical. If it was somehow hypothetically flat, they would have already told us. They would have already debunked it. Your government literally wants to kill the Iranian politicians. They have no incentive to hold it to themselves.
Yeah, you're talking about people, sociology, politics. We're talking about geometry, about the surface of the Earth.
No, you have to think of it from multiple angles. They have no incentive to lie to you.
No, I don't have to think about it from multiple angles. I can just think about it in terms of geometry. The surface does not display the curvature necessary for it to be a sphere. End of story, bro.
No, I've never seen a whale, but I believe whales exist. That
All your musings about like countries and leaders and politics and
then why
socialism,
believe
it
anything at
doesn't
all?
matter.
Like, why believe that oxygen exists? Why believe that whales exist? I've never seen a whale. I've never seen a fucking
Now you're
white
not
shark.
sure if anything's real, bro. You're broken in the head.
No, you're broken, bro. Like this room is broken. Like you flat earthers, you believe anything.
See, this is what you want to do. You want to talk about the people and not the issue at hand, subject, the topic, the surface itself, thing we
Look,
live
you
on.
need to have some sort of trust in anything. Even
No, I
banks
don't.
would go bankrupt.
No, I
No,
don't.
you have to.
No, I don't.
Okay, then
No, I
don't
don't. I
have
don't
it.
have to. I don't have to.
Even the banks you
delude
use,
yourself
you
all you
need to have some sort of trust in your bank. There
No,
would be
you
like.
can delude yourself about that all you like.
Huh?
Go for it. You can delude yourself about that all you want. Doesn't mean it's true. There's no this necessity that you've concocted doesn't exist.
It does. Even in business, man. Like if you having a business transaction, you have some sort of trust in the other party that they will pay you money.
No, that's
Void. Everything is a case by case basis.
Everything needs trust in it. All right.
Yeah,
So
keep
does
playing
these
yourself.
institutions that your government has built.
Do you have to trust that you are the height you are?
Pardon?
What height are you? What are you? 6 foot? Do you have to trust that?
No, I can measure it. It's quantifiable.
Yeah, you measure it. It's an objective truth. It is irrelevant of whether someone wants to trust you on it or not. It is what it is. It's not going to change.
No, but a lot of things are not because let's say, have you seen a blue whale?
It's all a case by case basis. I don't know why you want to just put it all into
Do you
one
believe
single
in blue whales?
category.
Do you believe blue whales exist or not? Yes or no? You believe blue
Whales are
exist
not
or
an
not?
extraordinary claim.
No, have you seen them?
I've seen
Have you
sea
seen them?
life of other nature, right?
No. Have you seen blue whales?
I haven't seen a specific species in,
No,
in the
exactly.
ocean.
You have not
Necessarily
seen
mean
blue
it's
whales, but your
not
government tells you blue whales exist, so you believe
Yeah,
it.
but you know something I've never fucking seen in my whole existence? A
This is just a
spherical
concession.
planet, right?
Have you seen
Yeah,
a fucking
exactly.
kangaroo? Have you seen a kangaroo? You
Yes.
don't live in Australia, right?
Yes, but this is just a concession from you. You saying that, it means you are admitting that you can't support the claim. Good job.
Yeah, so you're 6 foot in height. The Earth is curving. Give us the measurements of 6 foot in height, and then give us the measurements of the Earth curve. That's all we care about.
We're not stopping you from having your trust, bro. You can trust and believe all you want, right? We're not stopping you. We're choosing not to, based on evidence. If you want to ignore the evidence, you're free to. Nobody's stopping you. Are you here to try and convert us? Believe like I do. No.
Look,
Go
your
away.
your claim is equivalent of saying blue whales don't exist because I've never seen a blue whale. That's what your claim is.
Yeah, fine. Okay. Prove it. Show me one then.
What do you want me? You want me like to get a fucking blue whale from Pacific Ocean or something?
Yes, take me to one.
See?
I don't need to prove that unicorns don't exist.
You're strawmanning. I'm talking about blue whales, not unicorns.
Yeah, I don't need to prove that blue whales exist or don't exist.
No.
I'm
Do
not
you
making
believe
a
blue
claim
whales
about
exist?
it.
No. Do you believe it? Do you believe they exist or they don't?
Yes. Yes. I accept they exist without evidence.
How do you know they exist? Can you
Because
prove
it's
it?
not an extraordinary claim. They're a creature. I've seen creatures, large creatures. I've seen dolphins. I've seen other smaller whales. I've never seen a blue whale in the wild. I accept the testimony of many other people who have. There's creatures in the ocean. I've seen them. It's not a stretch to accept that a blue whale exists based on other life forms I've seen in the ocean and the testimony of other people who have seen them firsthand.
Void must believe in megalodons as well, I guess.
Yeah, because we have found skeletons of megalodons.
Currently existing, I was talking about.
Not currently, but we have skeletons of dinosaurs, megalodons.
Okay, we're not going into all that fucking nonsense, Paradox.
Dinosaur is nonsense according to you?
What is a stretch, though, is to accept without evidence, based on the testimony of, 26 people, that the Earth is a sphere. With no measurements of it. Not one. And attempts to measure just yield the result of no curvature.
Because I've seen the footage from the ISS.
Yeah, cool story.
And it's nonsense, so...
Alright, even
you know they admittedly use wide-angle lenses which distort horizontal lines, right?
So in 2025, in 2026...
Yeah, I do know that too.
You can't differentiate between reality and what's fake, what's not real because of how advanced technology is and how advanced AI is. But what about 20 years ago? How about 20 years ago? Even CGI can't do that shit.
Hey.
Void, we'll put your words to the test that you can distinguish between reality and CGI. Okay? So
what you're telling me, the ISS live footage is CGI? So that's all made up?
CGI. Nobody said that.
So
Who said CGI?
What is it then? What is it
You
then?
said CGI.
No,
but
what
here,
is it then?
Look, I posted something in the side chat for you, a little test for you. So can you go through them? Tell us which ones are real, which ones are CGI. Since you claim to know how to differentiate between reality and fakery in 2026.
I think they are captured from different angles, and they have like different atmospheric conditions. So, for example,
okay. So your claim is they're all real. Is that what you're saying?
It's just about different angles and the atmospheric conditions and the.
Yeah, I never asked for why they may all look different. Are you just saying they're all real, right? De facto.
Look,
Yes.
I'm not a CGI. I'm not sure, but they sure look pretty realistic. Just from different angles. For example, one of them is captured from South.
All I'm asking you is which of these represents something that exists in reality?
All of them.
And which doesn't?
I mean, some of them. For example, at the bottom one, there are some at the bottom that look kind of sketchy, and they have a lot of atmospheric. They have just too many clouds in some of them.
Too many clouds. Would that be based on your own observations from such a vantage point to compare it to? You know how many clouds there should be.
Abnormally more clouds than there should be. Maybe I'm not. I'm not a topologist or a
How many
CGI.
clouds?
Yeah.
Is it like 20, 25? How many?
Huh?
How many clouds should there be?
you can't quantify that.
Brian, what the
in
fuck are
that
you
way.
talking about? What the fuck are you talking about then?
No, he's not a meteorologist, Cyclone, but he can trust them.
No, there's too many clouds, bro. How many should there be? I don't know.
No, in a specific region, like fully covered
Too
with
many
the clouds.
Which specific region has too many clouds, and how do you know it's too many?
Abnormally more.
Abnormally more.
Yes, because they're spread out in general.
What's abnormal? Which part's abnormal, and how do you know what's normal?
When you have a general reference of multiple things to compare to.
Yeah, but you don't have any reference because you've never seen the Earth from this perspective. Your whole thing's retarded. I'm just pointing out.
Bro, you're the flat earther, bro.
Yeah, correct. Which is why I'm not saying dumb shit like there's too many clouds in that cartoon CGI ball Earth. Too many clouds. You outside counting clouds?
Yeah, can you stop hard pressing on that? That's just one of the ways you can look at it. Not necessarily that's true, okay?
I know, it was very stupid. I was just pointing out it was a stupid thing that you said. That's all.
No, that could be true. Like,
no, it could just be you speaking out your ass. You've got no idea how many clouds there should or
no,
shouldn't
you're
be.
the fucking fat earther, bro. Come on.
Those are all cartoons. You base your worldview on cartoons. That's retarded. Anyway,
even in monsoon, they don't have this many clouds.
Void, do you want another little test?
Huh?
We can do another one. Here. So here you have multiple frames showing curvature of something, right? Can you tell us which one is actual Earth curve?
Which one is real Earth? All of them.
Mm-hmm.
All of them.
All of them?
Yes.
Okay, that's your final answer, all of them?
Yes.
So
the
Earth looks with that. I mean, what's that, mental retardation? Like,
yeah. So the Earth looks that curved from 100 foot. Does it, Void?
Yes. Yes, slightly curved. Yes, not 100 foot, but maybe 100,000 foot.
Well, there's an image there that you said that's a true representation. From 100 foot, does the Earth look that curved?
Not 100 foot, but surely 10,000
foot. So not all of them then.
Yeah, perhaps. Correcting myself. Yeah.
What's with all this fake curve going around?
Like, do you guys believe in some sort of like a religion or cult, by any chance?
No, we're not the globe believers. That would be you. That's in the cult.
He's trying so hard for it to be not about geometry.
No. Are you guys like?
You're a heliocentrist. Void, you're a heliocentrist, aren't you?
No, I'm not a heliocentrist.
You're not a heliocentrist, so you don't believe the Earth goes around the sun?
No, that was like before Galileo and shit.
Wow, so you don't even know what you're talking about, because that's the mainstream belief. So you're a geocentric glober? You think the sun goes around the Earth?
No, the Earth goes around the sun.
Hey, so you're a heliocentrist.
Yeah, I'm a heliocentrist. Sorry to correct myself.
Beep, boop, boop. Blue screen.
And the sun goes around the Milky Way.
Silly globers.
Correct.
Void, do you think the ground is spinning right now?
Yes.
Relative to us, no.
Relative to you, no. So the ground is stationary?
No, it's spinning.
No. Oh, it is spinning. How fast do you think it's spinning?
Relative to us, no. Relative to the Earth,
us, no. But it is spinning, right? It is or it isn't spinning. Just be straightforward.
I wouldn't say the ground is spinning. The Earth is spinning overall.
Oh, so the ground is not part of the Earth.
Hey, Cyclone, the Earth is spinning and you're spinning too with it.
Yes.
Am I? Am I? See,
but the ground is not spinning.
This is the religion, guys. You guys are in the religion. That's your religion, the spinning ground religion. How fast does your religion tell you that the ground is spinning?
So how would you explain a night and days?
No. It's not. How do I explain? I don't believe the ground is spinning. How fast do you think the ground is spinning?
It completes one rotation in one day.
So what speed is that?
I don't know.
You don't know.
Something like that.
What?
Yeah, you have to do mathematical calculation for that.
It's hundreds of thousands, if I'm not wrong.
Hundreds of thousands, and yet when you go outside, you detect no motion of the ground whatsoever.
Yeah, relative to us, no, yeah.
Right.
Relative to us, there's no motion
it's
because
just a belief. So it's just a belief you have.
No, you need to understand that we are spinning too.
I understand. You guys believe. You guys have a belief contrary to your experienced reality that the ground is moving at hundreds of thousands of miles an hour. Why'd you believe that?
Because I can see the sky changing. I can see the day and nights.
Right. What's that got to do with the ground you believe is spinning?
Earth spins.
No. You can go outside. There's no spin of the ground.
Hey, Cyclone. So
why is darkness? Why is there sun? Why is there light?
So why do you have that belief?
No, it's not a belief. It's a fact.
It is a belief because you don't experience the ground moving, do you?
As I told you, relative to us, you know about relativity, right?
Yeah, it means that's your excuse for you not experiencing the ground spinning, but you believe it is. That's the word you use instead of religion. You say relative. But what you mean is religion. The spinning ground religion.
Bro, have you seen a fucking elephant?
Have I seen an elephant? Wow. So how does an elephant tell you the ground's moving at hundreds of thousands?
No, but you do believe that elephants exist, right? Exactly.
Okay.
That's the point he's trying to make.
Yeah, so you believe the ground is spinning at hundreds of thousands of miles an hour because of elephants, Is that right?
Bro, are you like, what the fuck?
Well, then why are you talking about elephants?
You're deviating from the point. It's a metaphor.
Come on, guys. I'm asking you to figure out, try and figure out what possible reason you have to believe the ground is spinning at thousands of miles an hour.
Yeah, because I believe elephants exist. For your simple brain.
Okay.
Yeah, exactly. For fucking elephants.
Well, that's retarded. That's about
that's fucking retarded for you. You believe elephants exist even though you haven't seen any elephants.
Yeah, that's why I expect from you globe believers. Elephants, therefore the ground is spinning.
Right. That's fantastic, bro. What a tool.
That's pretty good, right, guys? That's good stuff. That's the best globe proof we've heard all day. Elephants.
That was an analogy, man.
No, that was his reason for believing the ground is spinning. He said, elephants. It doesn't really make any sense. Your religion sounds weird.
But still, how do you explain days and nights?
What do you mean? What do I need to explain about days and nights?
So if Earth is not revolving, how the sky is changing according to you?
Well, you just said it. The sky is changing.
The sky is changing, but what's the mechanism? Why is it happening?
What do you mean?
No, I need a reason to know that.
No, you don't. You don't have a reason to believe the ground is spinning, but you believe that. Why are you pretending you need a reason all of a sudden? Your entire globe belief is based on no reason whatsoever. You were just told it. I'll just tell you the sky's moving. What's the difference?
Sky is not moving, man. The sky is.
That's what you said. You said the sky
ground is moving. No, I said Earth is moving. I said ground is moving.
Yeah, but you don't have any evidence for that. You just said that you observed the sky moving.
No, I said the sky is changing.
Yeah, as in it's moving. The things in the sky appear to move.
No, as the Earth moves, the skies change.
Well, the Earth. What evidence do you have that the Earth's moving? As far as you can tell, the Earth is not moving, unless you're in an earthquake or something. What happened to that Void guy? Oh, he's spazzing out. Oh, someone muted him. No, he's spazzing out.
All right, we'll just get banned in a moment if he keeps it up.
Void, explain the elephant thing again. How do the elephants tell you the ground is spinning?
Do you believe dolphins exist?
Why are you asking me about what do I believe?
Because we'll come to a conclusion after that.
You're trying to prove that the ground is spinning at thousands of miles an hour, remember? You said elephants.
Because in order to come to a conclusion, I have to ask you this question.
No.
So,
your belief
do you
in the
believe
ground
dolphins
spinning,
exist?
My belief has nothing to do with your deciding that the ground is spinning, unless your evidence for the ground spinning is my beliefs, which wouldn't make any sense, even less sense than your elephant comment. It's on you, Void. This is about what you believe. You said the ground is spinning at thousands of miles an hour, you believe, and then we asked you why, and then you spoke about elephants, and now you're trying to ask what I believe. Are you confused about your own belief?
Bro, you're trolling at this point.
No, I'm inquiring about your claim. You claimed the ground spinning at thousands of miles an hour. I asked why you believed that. You started talking about elephants. Everyone heard you.
Because of belief. Because of belief.
Is that not what he said?
Yeah, because of belief. That's the answer.
Okay, so you just believe it.
I've never seen a dolphin, but I believe dolphins exist.
So it's just a belief you have that the ground is spinning at thousands of miles an hour?
Partly, yes.
Why do you believe that?
Because I have some sort of trust in multiple global institutions.
Multiple global institutions. Which one? Which one told you the ground is spinning at thousands of miles an hour?
For example, the U.S. Even if, let's say, your government is lying to us, North Korean they would have an incentive.
So what evidence did the U.S. government give you that you have placed your faith in like a religion? Did they tell you to say the elephant thing?
If a flat earther asks you why you think the earth is spinning, just tell them about elephants.
That sounds like an elephant.
Classic.
I would say
so what
half of you guys just want some sort of comic book effect.
Yeah, you guys
just want some sort of comic book.
This is what he does.
And half of you are just a bunch of fucking.
Listen, your elephant-based spinning ground belief has nothing to do with us. You just said it was to do with the U.S. government. So how does the U.S. government convince you that the ground is spinning because of elephants?
See,
what was the evidence they gave you?
No. The way you frame it is just completely trolling, man. But I get it. Okay,
well, no.
Like
to be fair,
maybe they showed him an elephant.
It was very retarded what you said. So yes, I am trolling you a bit because it was very stupid. But now you realize that was stupid, and you won't say something stupid like that again, hopefully. So now I'm asking you seriously because you said, well, my belief in the ground spinning at thousands of miles an hour comes from the U.S. government. So I said, well, what evidence did the U.S. government give you that made you believe it?
Look, my government gave me that. And
gave you what? Your government gave you what?
they taught us in school, so I have
taught you in
some
school.
sort of.
Okay, but what I asked what evidence they gave you, not what they told
Based
you.
on what? So, did they say, we know the Earth is spinning because... Now, fill in the blank.
Because we could observe it, we could quantify it.
No,
we can
you
have
can't observe
multiple
it.
scientific
You can't
evidence.
observe it. No, you don't observe it. That's the whole point. That's why we're challenging your belief.
Look,
that's why you said it's a belief you have because you don't observe or experience it. And now we're trying to find out where this belief of yours comes from. And you said you were taught it in school. Fine. So were we. What evidence did they give you, though? Or did they just say, this is the case, believe it, write it down on the tests?
All right. So let's put that let's put that aside. Like, if you ever have traveled through like an aeroplane, they don't go straight to the destination.
Yeah.
They go in a curvature.
Yeah, they
right?
treat the Earth as motionless. They don't treat the Earth as spinning. So that won't help you in this regard.
So are the airline companies lying to us?
Oh dear. No.
When they say that they treat the Earth as flat and stationary? No, they're not lying.
They're not telling you, hey Void, enjoy the flight. We're going to navigate this spinning ball ground beneath us. No, they don't tell you that.
Why do they go in a curvature? Why don't they go straight? If
They don't account for any curvature as they're flying. They treat the ground as flat and motionless when they fly.
True,
That's how they're taught to
but they
fly.
still they don't
right,
go.
okay. So it's not going to do much good to speak about flying planes because as far as that goes, they're just flying over a flat, motionless Earth. That would be what we are talking about. You're talking about this spinning ball ground religion. That's
Why would a flight from London to New York go above Greenland, go through Greenland?
Why would you have a belief?
Not directly.
Why would you have a belief in a spinning ball ground with no evidence?
No. Why are you deviating from the question? Why do they go over
you deviated from the
Why do they
question,
go over Greenland?
Because we were
Why do they
asking
go
you
over Greenland?
what evidence you were given for your claim that the ground is spinning hundreds of thousands of miles an hour. That was the question which you have tried to deviate from. Remember?
So you don't have any answer for that.
Well, I've demonstrated the point. You have no reason to believe in this ground spinning at hundreds of thousands of miles an hour. Do you agree?
Even if I agree to your point, these airline companies, why do they go over Greenland and not through the Atlantic Strait? Why?
Why don't you go and ask them?
Why don't you fucking sue them then? They are
You want me to sue? You want me to sue the airlines? Why would I sue the airlines? What do you want me to say? What do you want me to say?
You'll be a multimillionaire if you win the lawsuit.
What should I sue them for?
For charging extra
flat and motionless.
Yeah, sue them.
No,
you'll be a multimillionaire. You'll be a billionaire.
I can't sue them for treating the Earth as it really is.
All of you guys just go and sue these airline companies because they're charging you for extra miles.
I think you should sue your school because they convinced you that the ground's spinning at hundreds of thousands of miles an hour, and you've just realized they gave you no evidence at all.
You're still deviating. Like, why don't you sue the airline company?
That's the original point. That's what we were discussing. You're the one who's deviated. And I know why. Because you don't have any evidence. You don't know why you believe in a spinning ball Earth. Well, you do. It was because you were told it.
And because planes go over Greenland.
Jeez. It's silly, this whole globe belief thing, isn't it?
Yeah, elephants in Greenland. I get it now.
Yeah. See, I mean, it just takes like 10 minutes of thinking about it, and you can tell how silly the whole thing is.
What about lunar eclipse? What's the shadow of the? What's the from which object? From which object is the
darkening
is
on
the
the
shadow
moon
on the
during the
moon?
lunar eclipse? You mean the darkening? Yeah, what shadow? What shadow?
Yeah, Luke.
Yeah, the shadow, the darkening, the whatever you want to call it.
Yeah. But what if it's not a shadow?
Can somebody explain that here?
Nah, don't really need to explain
I don't think you could.
I thought so.
By the way,
how would you explain it?
All of
How
you
would you
guys
explain
believe in
it?
religion,
Hold
right?
on, Void. Hold on, Void. Void, there's another Glober who's about to fall on his sword. You should just chill. Now you're off the hook. So, Luke, how do you explain it?
Well, the sun, the Earth is aligned with the moon, right?
How do you know that?
Well, how do you know it's not?
Well, that's not okay. So you don't know that. You don't know that's what it is. Then.
That's a concession.
That's a concession immediately. So you don't know that. There you go.
Well, we know that.
Oh, how do you know that, Luke?
There's many things that you guys cannot explain.
Okay, well, you can't explain it either, as you've just demonstrated.
This is just like an example of how the Earth is.
Come on, give me your.
round.
Okay, let's do it this way. You give me your explanation of how it works. It's not your explanation. The story you were told as a child and never thought to question. Tell us that.
You guys only see like
it's not about you guys.
like an
It's not about
inch
me, Luke.
in
Come
front
on,
of
Luke.
you.
Come on,
You
Luke.
don't
Tell us.
see. You guys only see like an inch in front of you. You don't see the big
Inch
picture.
in front of us. No, we see for miles and miles and miles, Luke. That's how we know the Earth is flat, because we see
Yeah,
way
What he means to say, Typhon, is that you don't use your imagination like I do.
You come to conclusions based on what you see with your own eyes.
Oh, and you come to conclusions based on stories you were told as a child, Luke, that you've never thought that you didn't think about. Yeah. Let's do an example. So the lunar eclipse, go on, explain it. What is that?
Well, it's just an example of how the well, you can obviously see the shadow on the moon.
Well, how do you know it's
shadow?
How do you know it's a shadow? Oh, it's the
How do
shadow
you
of
know
the
it's
Earth.
not?
How do you know that?
It's not.
Okay, so how do you know it's not?
So you cannot explain moon. You cannot
How do you know
explain
it's
the
not,
sun.
Luke?
You
It's
cannot.
not
You
proof that
cannot
that's what it
explain
is.
every
Hold on, Luke.
planet and star in the
Hold on a second, Luke. You don't need
universe.
to spiral already. Luke, chill. Luke,
The only
chill.
thing that you
Luke,
guys cling
chill.
on is
Luke,
the
chill.
curvature.
Luke, need to chill.
The only thing is curvature.
Keep talking about us, Luke.
Okay, Luke. So, Luke, you saying what else could it be is not proof of your claim, is it?
It's not.
Okay.
It's a shadow. On the
Right. So how do you know it's the shadow of the Earth cast onto the moon? How do you know that?
This is only one example.
Yeah.
There's
I'm
many
asking you,
examples.
how do you know that? I'm asking
Many
how you
evidence.
know that. How do you know that?
Sorry?
Keep
How
not
do I know?
answering the question, Luke.
That's a loaded question. How do I know
How do you know
Earth
it's the
is
shadow
aligned with
of
the
the
moon?
Earth? How do you know it's the shadow of the Earth being cast onto the moon?
It's a loaded
How do you know
question.
that?
It's like
No.
me
It's a
asking you
direct
how.
question. It's a
What's
question about
what's
your
fucking-
claim.
What's mine?
You claimed
Sorry?
it. You said the eclipse is the shadow of the Earth on the moon. How do you know it's the shadow
Yeah.
of the Earth on the moon? How do you know that?
That's a loaded question.
Oh wow! So so let's just be honest, Luke. You don't know that, right? That's just what you've been told. Yeah.
Well,
Is that fair to say?
You have your beliefs, and I have my beliefs.
No. I didn't make a claim about it. I didn't make a claim. Remember, I didn't say it's the
Yeah.
shadow of something on the moon. You did, but you don't know that, right? That's just what you've been told.
Well, you have been told the Earth is flat.
No. I've not been
What's your
told
point?
anything. I'm not making a claim about it.
Bro, you said
How
we
are you not
know.
claiming
We
the
know.
Earth is
So,
flat?
Luke, you either need to, at this point, admit that you don't know, right? And admit that it's just a belief, or tell us how you know.
See, it goes like this. You say the Earth is casting a shadow on the moon. We say, how do you know? Oh, that's a loaded question. Then you ask us, what's being casted on the moon, and we say we don't know. Like, oh, see, you don't know, and yeah, we don't know.
Yeah,
so
that's
then what do you believe?
It's only
we don't believe.
How you can see
you don't have a belief.
The planet is actually round.
You have a belief.
Yeah, that's all just beliefs you've got, Luke, based on stories you were told as a child that you've never challenged. Would you care to challenge them with us here today?
Well, I'm not a, I don't want to insult you guys, but I'm not a fucking crack.
It's okay, Luke. Luke, you couldn't insult us even if you tried. You couldn't if you tried. So don't worry about that. We'll just talk about your beliefs in the globe, and soon you will realize that they're laughable, and you have no reason to believe them.
The Earth is round. It's shaped like a ball.
Derf rond. Okay. So who's measured the Earth to be a ball in all human history? Who measured that?
People have gone to space, and the Earth is round. Like who?
Yeah, who measured that?
I learned that the Earth is flat.
It's okay, Jonas. We're speaking to Luke right now because he's an adult. Who's measured the Earth to be a ball then?
We've gone to space.
Oh, have you? We have gone to space. When did you go to space?
Human beings have gone to space.
Oh, human beings. Okay, so not you, right?
No, why would I?
So you can see, like, even without going to space or going to extreme heights, you can see objects or cities, skyscrapers disappearing beneath the horizon, right? If you look at it from a great distance.
What's the horizon?
What proof do you have that the Earth is flat? Where's your proof? Where's your evidence?
Go outside.
Go outside, yeah, that's true.
Oh my
God. Have you noticed when you go outside that you don't observe curvature or motion of the ground?
You cannot observe curvature while you are a speck of dust. In
a speck of dust? No, I'm a human being, Luke. How could a speck of dust be talking on Discord?
I will find where you live.
You're a speck of dust compared to the size of
You've never seen curvature because you're so big, so you've never seen curvature.
Yeah, and I'm explaining why you cannot just go out and see how the Earth is
you've never seen it
because you are a speck of dust.
Okay, so Luke, in your belief, right? You've never experienced curvature of the Earth, and you believe. And you believe that's because you're a speck of dust.
You are a speck of dust on a.
You can speak for yourself, Luke. You believe you're a speck of dust. Okay?
Like what is it called?
Well, you don't know you're on a ball, Luke, because you only experience flat. Remember?
Like a football, whatever. You're like a speck of dust on a football. That's the size of you.
You haven't got there yet.
So it's not that easy to see curvature when you go outside.
Okay, Luke. Okay, we agree. You can't detect or observe curvature, so how do you know you're on a big ball?
Well, you can see, for example, the Lake Michigan. There's pictures of the Chicago, I think.
Across
the lake.
That's right. That's interesting, because Chicago is supposed to be hidden by the curvature.
And it is.
No. It's visible. You just said you can see the skyline.
No, it's not.
Yeah, you can see Chicago's skyline over Lake Michigan.
Yeah, but the bottom of the city, whatever,
but
the
you're not supposed to see
are hidden.
The tops, the whole skyline, including the tops of the skyscrapers, are supposed to be hidden beneath the curve. So why are they not?
No, they're not.
Yes, they are.
No, they're not.
That was the whole point. That's why it made the news. Do you not remember this? Because you're not supposed to be able to see any of the skyline. So why do we? Where's the curve? Or have they got the size of the ball wrong? Why do we see the building? Uh-oh. You just walked right into it, Luke. That's a globe debunk that you just talked about.
There's atmospheric refraction also.
Or is that why the curve isn't blocking the buildings like it's supposed to?
I don't know how much does it affect the.
Oh, we do. Don't worry, Luke. We've studied this for a long time. You can look it up. How much curvature is there supposed to be according to the globe religion? Over 50 miles.
So okay, so how do you explain? Even if you don't believe in the official
the official cartoon from NASA,
the official curvature measurements.
The official
How do you
curvature
explain?
measurement.
How do you
Hold on.
explain the
Stop the phone.
city being
Which
sunk
official
behind the horizon?
Sorry, just quickly, which official curvature measurements would those be? Curvature's never been measured.
I think it's I don't know. I think it's like 20 centimeters over 1 mile or something like that.
Over 1 mile. When's that been measured?
Or 1 kilometer? I don't know.
When's that?
But
That's never been
anyways,
measured. No, that's never been measured. What are you talking about?
So how do you explain the ships sunking behind
Well,
the horizon or cities like
no
the
curvature
bases
has
of
ever
the
been measured.
skyscrapers hidden behind the horizon?
We're not deviating away from that claim about
so
measurement.
Can you just clarify? Curvature has never been measured, right?
Well, okay, let's check that. I don't know.
Seems like the kind of thing you should have checked before you tried to say that we were all stupid for not believing it. Starting to think you might be the stupid one here, Luke.
So the curvature has been measured many times.
Oh, well, that's a
over
relief.
2,000 years.
Oh, great. Okay, just post the measurement. Just tell us who measured it. And just so we're clear, we're talking about curvature, not like something else like shadows or something, and an assumption of curvature, right? This is a direct measurement of surface curvature.
So some guy named
yeah, we know it. Don't worry.
Eratosthenes.
Yes. Well, he didn't measure curve, though, did he? He didn't measure curve.
He noticed that in this city called Cyan, that's modern Aswan in Egypt,
we love this story.
The sun was directly overhead at noon on the summer solstice, and cast no shadow. At the same time, in Alexandria, a vertical stick did not cast a shadow. So what he did, he measured the shadow angle in Alexandria about 7.
Oh, so he measured a shadow angle. So not curvature. He assumed the curvature, right?
And he knew the distance between the two cities. So he
and then he assumed
geometry.
And so he assumed curvature, yeah?
So yeah, there's many cases where
so that's an assumption of curvature, but what we asked for was a measurement of curvature, not an assumption of it. So who's actually measured it? I mean, you're saying this is like, what, 2,000 years ago? So you're basing your entire worldview on this story of a guy 2,000 years ago with sticks, is that right? No one's measured it?
No, well, today we use satellites, radar, gravity measurements, spacecraft tracking.
Okay, so could you post a modern measurement then? Could you post something legit, not just a story about some goat herd with sticks?
I think it's funny how he said, "Oh, they measured it." Like, let me call my buddy 500 stadia away and say, "Hey, mark that time right there. That's the measurement I want."
Well, that wouldn't be curvature anyway. You'd just be looking at shadows on what you perceive to be a flat surface. The shadows weren't curved, were they?
They weren't even on the same meridian.
Yeah, this is classic.
So
who measures
it? Drops about 8 centimeters per kilometer.
Okay. Is that just that's just the claim though? That's never been measured, has it?
Well, as I said,
no, that'd be a slope. That'd be like a ramp.
Yeah,
that would be a ramp.
He's close enough. He's for a glober. Listen, we know you globers don't know anything about the globe. That's close enough.
So I'm just curious where he thinks the horizon is from 180 centimeter observation.
Well, hold on. Before we get into that, I need to know. I need Luke to come to terms with the curvature's never been measured.
Well, it has been measured many times.
Okay, so who measured it, Luke? Because the guy with the sticks didn't measure it.
I don't think you understand.
It's not a problem with my understanding. You just said he measured shadows. That's not curvature.
Yeah,
You think we didn't think
shadow
to Google?
angle. He measured shadow angle.
So not curvature. You think
He
you didn't? You
measured
think we
the
didn't
shadow
think to Google?
angle
Who measured the
in
curve?
Alexandria, and it was
Yeah, he assumed
7.2.
curvature. He assumed curvature. Look, we understand this is the first time you're hearing of this. We heard about it 10 years ago. It's an assumption of curvature. So, who did an actual measurement of that 8 inches per mile squared that you mentioned? Who's measured that ever?
Well, as I said many times, we measured, but he didn't measure the shadow. He measured the shadow angle, and it was
Right.
7.2 degrees.
Okay, so no one's measured the actual curvature.
Yeah, well, he did.
No. He measured shadow.
He actually did, like 2,000.
That's a shadow. That's a shadow. Not the
140
curvature.
BC. and,
Yeah, Luke.
and here we are.
You're
in
saying you've
2026.
already said what he measured, and it wasn't
Don't
even the
believe
surface.
there's curvature.
He didn't measure 8 inches per mile squared of surface curvature, did he?
Okay, well, it was nice talking to you guys. Take care.
Oh, you tapping out, Luke? You tapping out? He's tapping out. Rip. Oh dear. GG's. Any other Globers want to help us out? Who's measured the curve? Don't be shy. What about all that, T-Dub? I know you enjoyed that. The elephants. The shadows. Classic.
Yeah, absolutely classic. Yeah, Greenland. But
Greenland.
I mean, it's just such a preponderance of strong evidence. I have to go back to the globe, guys. I'm sorry.
Sue the airlines.
Right, sue the airlines.
Oh boy. So who else we got in here? Danny HCR. What's up, Danny? Are you listening to that? No. Who else? Shomika. What's up, Shomika? Tsukuyomi. What's up? Oh well, oh well. Now we wait.
Are they Googling?
No, I think we're just waiting for the next globe believer to realize the Earth's not a globe. I agree, Danny. It doesn't matter how much we point out to these guys that no curvature has ever been detected, measured, quantified, or motion, or gas pressure without a container. It doesn't matter. You can't argue with these brick wall globe heads. But it's fun anyway, because, you know, they make it clear to the audience what a bankrupt religion this whole philosophy is of the globe. So we don't mind. We just exposed it 24/7, 365 days a year. And it's the best entertainment money can't buy. All free. Good stuff.
Yeah. Yeah, people pay a lot of money to see a good comedian. You can just come here and get a laugh for free.
Yeah, there's no stand-up that can compare to a globe believer trying to explain why he believes the ground is spinning at millions of miles an hour. You don't understand why people lie, Danny? You don't understand why an authority would ever mislead you? You must be very naive. You must live a very sheltered life. What's up, Violet? That was quick. I just don't understand why the government would lie to us. Imagine. You think the government doesn't lie, Danny? Don't know where you're living. Yeah, your government lies too, Danny. They don't even have to be lying. I mean, you're just believing images you've seen from NASA. That's just one organization. Maybe believe Russia and India too. So 3 organizations. Maybe China as well. 4. Just believe 4 organizations with your entire worldview because they gave you images and videos. I mean, they're not even technically telling you need to believe it. It's offer and acceptance. They offer, you accept. You don't challenge, you don't question. You just accept, you just believe. Maroween? I don't know how to say your name. What's up, Maroween? Maroin? We're looking for some evidence that the Earth is a big spinning ball, if you have any. What's up, Sweet Chili?
Hello.
How's it going?
Everything's fine. What about you? You're
I'm good, thank you. What brings you to the Flat Earth chat?
sorry, was an interesting topic.
It is very interesting. You got some questions? What are your thoughts?
Not yet.
Okay. Do you think the Earth's a globe?
Yes.
What makes you think that?
Evidence.
Which evidence?
Well, studies that we have ready.
The what? Sorry?
Studies that we have already, the scientific evidence. And
Okay. Anything specific?
Yes.
Like measurements? Any measurements or anything? Because we don't experience, like me and you living our lives on Earth, we don't experience the Earth to be a spinning ball, do we?
Not yet.
It just seems flat and motionless to us. So
practically. Sorry.
So what evidence has convinced you that what you experience isn't correct?
Question. Easy answer would say it's the pictures that we have
Yes, the pictures. That's a
taken
good answer.
outside the air.
But it's very easy to make fake pictures, isn't it?
Now, yes. Nowadays,
so how-
yes, but before we can still believe what we got.
But should we base our entire belief on what reality is based on images that we can't know are true?
100%.
Well, how do we know if those images are real or not? Because we would have to go to where they say they're going to and take our own pictures, but we can't do that, can we?
Not yet.
So how sure are you? Do you just trust that they're telling the truth?
It's the same question if I will be in the opposite position.
Well, no, because remember, you experienced the Earth to be flat and motionless directly yourself. You don't have to believe that. That's just what you experienced. But someone's saying, hey, here's a picture of it, and it's not what you think it is, but you don't know that picture is real. So I'm saying, is it a good idea to base your worldview on images that you can't prove are real?
Not 100%, as I said, but it can help you to have a picture of what the reality could be, because my reality cannot be the same as for
But what if they're fake?
a person from... Yes,
Your senses are lying to you.
Oh, so Danny, you don't trust your senses. I guess you just wear a blindfold every day.
No. How do you know you can trust your senses? You don't know that.
Well, how do you know you can trust the U.S. government?
I don't know if you can trust it, but how do you know if you can trust?
Well, why are you choosing to trust the U.S. government over your senses? Then
I'm not trusting the U.S. government. I'm trusting millions of people that work for
millions
stuff
of
like
people.
that. Instead of only my only experience.
But none of them have experienced the globe either.
I mean, somewhere on the moon, somewhere in space.
No, that's you just trusting the U.S. government again. That's trusting the U.S. government because you don't know anyone went.
I mean, the Russians were also in space.
Okay, so you trust the U.S. and the Russian government more than your senses. Okay, well let's do
European Space Agency.
If you're gonna do numbers, if we're gonna do a number comparison, 8 billion people experience a flat, motionless Earth. About 25 people say they've seen a globe.
How do you know that these people are actually really not just an imagination of yourself?
What, the 8 billion people?
I mean, it's theoretically more likely that you're just an empty brain floating around in space than everything that's happened right now. So
no, that doesn't make any sense. So, I mean, if you want to appeal to the majority, you've got 8 billion people who experience a flat, motionless Earth, and you've got about 25 people that said they saw a globe.
So you're trusting some agency to...
No,
there actually are 8 billion people. How do you know that there are 8 billion people and experience 8 billion people being in the same place?
Because everyone agrees and acknowledges that we experience the Earth to be a motion.
Yeah, but how do you know it's 8 billion people?
Well, that's by the by. However many people there are. My argument isn't about how many people there are. It's about what the Earth is and how we
But
experience
why do you
it.
believe the fact that 8 billion people live,
I didn't
even
say I
though you
believe it. I
have
was just
experienced
using
that?
for an example. The
You're
point
just
is, everyone on Earth
disproving your own
experiences it
fact.
to be flat. Everyone on Earth experiences it flat and motionless.
How do you know that? Have you talked to every single person on the planet?
Well,
just
yeah,
assuming
everyone I've
stuff
spoken
at this
to
point.
knows that. Well, okay, so who on Earth do you think experiences or detects curvature or motion of the ground?
I don't know. I haven't talked to that many people about
Okay.
it.
Have you ever spoken to anyone who says they've experienced curvature or motion of the ground?
I can explain why you don't experience motion, because you only experience acceleration, and the Earth isn't accelerating or decelerating.
Oh no, they say
it's
it
at a
is.
constant
They say
speed.
it is accelerating. No, they say it's not.
It's at a constant speed.
No, they say it's an elliptical orbit, and an elliptical orbit would necessitate acceleration and deceleration. Also,
Yeah, but we accelerate
motion. Circular
same
motion
speed.
is
Everything around us
constant
does.
acceleration. Circular motion is constant acceleration. So, by your own argument, you're claiming you would detect motion.
Yeah, okay. Even if the Earth is accelerating, let me talk right now. Because everything else around you is accelerating at the same speed, you don't experience the acceleration. If you're in a car and you accelerate, you're accelerating faster than the ground. But
so your argument
nothing around you, everything that touches you accelerates with you, so you don't accelerate because the accelerate that are against something else is the same.
So the argument is, you know the Earth is moving because you don't experience the Earth moving.
No, I know the Earth is moving because of observations.
Observations of what?
Took of the Earth, of the.
I'm talking. You're not.
Which observation would that be?
Maybe the moon.
Many different observations and calculations.
Well, a calculation can just be theoretical. What we need actual reality here. So, you got an observation in reality that proves the ground is spinning?
Yeah, the Hubble Space.
The Hubble Space Telescope. No, that's not looking at the Earth.
Or any satellite.
Okay, so which one did you see that made you believe it?
Not one in particular.
Well,
just
did you see any? You didn't see anything.
Yeah, I've seen satellites in the sky.
And it showed you that the ground was spinning?
No, the pictures that the satellites took.
Oh, which picture?
All the data that was.
A picture. A picture is a still image. That's not showing you something moving.
And videos and stuff like that.
Oh, a video. Could you post the video in the chat? We want to.
I don't have the video.
Okay, so that's just kind of a baseless claim then.
Okay.
Maybe when we were walking, we see the moon.
To be honest, I don't care if you believe me or not. It won't change anything in my life.
Believe you. I know you didn't. I know you're just hoping that it's the case because you believe it, but that's okay. So, Sweet Chili, what were you saying there?
I was just imagining one of the memorable experience that I got when I was a child is that the fact that when you walk on the street, the moon is always behind you, like following you, and that could be a reason that the Earth is closed because it's about circumferences in a circle.
That could just be the movement of the moon, though, as you're still underneath it.
But the moon is always there. When
the moon's
we
not always there. You don't always see the moon.
At night, I mean, the moon is not gravitating or something like speeding so fast that we cannot catch it. I mean, we are the ones that are walking, and that the Earth is also moving.
Well, no, but that's what we're saying. There's no evidence that the Earth is moving.
No, but I mean, I got the feeling that the Earth is moving as I am walking, and the moon is.
But it doesn't feel like the Earth is
following me.
But it only feels like the Earth is moving if you're in an earthquake or something. Other than that, the ground just feels still. And you see the moon moving, not the Earth.
Of course, from the Earth, I cannot say that I can see the moon moving.
Yeah, right. This is what we're saying. So from our
outside Earth.
Yeah, but this is the thing. They'll say so. All of us experience no motion of the Earth. We experience motion of the sun, the moon, the stars. But then someone's telling us, you just can't tell. Trust us. Believe us. Why should we believe them?
Why not?
Well, why should we?
What is there to not believe in this? Why would you?
Well, they're making a positive claim that we don't experience, so they need to provide proof. So they need to provide proof.
They have provided a lot of proof. You just don't acknowledge it as proof.
What proof did they provide?
Like several pictures of it. So the
How do you know those
video of
pictures are
them
real?
landing on the moon.
How do you know that's real?
You don't know if anything is real. You can't prove the realness of anything.
That's what I'm saying. So you don't know
you can't
they're
prove
real.
anything.
Right.
You can't prove that maybe I'm just an AI talking to you
You don't know
now.
they're real. So why would you believe them?
Maybe I'm an AI talking to you right now. You can't prove that.
I don't know. The AIs I've spoken to sound a lot more intelligent than this. But you just admitted you don't know that they're real. So why are you saying we should believe them when you don't know that they're real?
No, I just said you can't believe anything. So
Yeah, exactly. We don't believe those.
Most likely.
So right. So you're saying you're saying you can't believe anything. So you can't believe you don't know that they're real. So why should we believe them? Why do you believe them?
Because that's what my experience told me.
No, your experience is that the Earth is flat and motionless.
No, that's not my experience.
Okay, where did you experience curvature?
At times.
A tennis ball, for example, has a
tennis ball.
A ball.
Okay,
it's
but
a
not
ball.
the Earth. But not the Earth, right?
I don't know that. I mean, I think I know that it's a ball. I think I know it's a.
Well, no, because this is the thing. The story that you're claiming to believe, the story they're telling us is that we don't experience curvature or motion. They're telling us we experience the flat, motionless Earth. But they can go somewhere that none of us can go to, and they can see that it's a spinning ball. They're not claiming that we can experience a spinning ball.
Okay.
So, and then you're saying, well, they've given us images, and I asked, how do you know those images are real? And you've just admitted you don't know they're real. You can't know.
No, I said you can't. Nobody can know anything.
Right. So that would then include you not knowing that these images are real.
My claim was just that everything you could think of, like all your reality, could just be made up.
Not really.
He's gone to brain in a jar, man.
How can you prove
brain in a jar?
you're not?
Okay,
how can you prove you're not dreaming this right now?
Are you on Discord right now?
How I don't know. Can I?
You don't know if you're on Discord
maybe
right
you're
now?
dreaming it. Maybe you're dreaming that I'm on Discord
talking
right
to me
now.
on Discord right now, you don't know if you're on Discord. But
maybe I'm just dreaming it. Maybe I'm just dreaming it.
You do know that the Earth's a globe, right?
Maybe I'm just dreaming it.
Okay, so you don't know that the Earth's a globe anymore.
Maybe I'm dreaming maybe I've been dreaming my whole life and I just don't know it. And when I die, I wake up and everything is different.
Okay,
you can't know anything.
The Earth being a globe is just a dream.
Could be.
Could be. There you go, Danny. Progress.
It could also be a dream that it's not a globe. Could also
well,
be a dream
at least you experience the flatness. You don't experience.
I don't experience the flatness. I just experience. Maybe it's a cube.
You don't experience the curve.
Maybe it's a cube.
Well, you'd be living on one of the flat sides of the cube if that's the case.
Yes.
There you go. So there you go, Danny. Well done. You've realized you don't know that the Earth is a globe. That's progress. But you also don't know if you're on Discord, so maybe that's not progress.
Maybe my name isn't even Danny. Maybe I'm just remembering it wrong.
Well, no, that's your name on Discord. I know you don't know that you're on Discord, but you are actually
maybe
on Discord.
Maybe my name isn't even Danny on Discord.
Well,
maybe if you close your eyes for 1 second, you can't.
I know you're struggling now to deal with any kind of reality, Danny, but everyone else in the room can. So
maybe your eyes are lying to you, and it doesn't even say Danny.
Kind of spiraled out. We get it. You don't know anything. You're a brain in a jar. You don't know if you're on Discord. Just put yourself on mute.
Maybe I'm already on mute, and you're just imagining it.
It's okay, Danny. This has been a good spiral for you.
You can use the same argument. Yeah, I was thinking more if we use the same last argument, then I could say that I don't believe that the Earth is flat. Either. 100%.
No, you don't have to believe that. You experienced it already directly.
Also, I cannot say it because if I remember, it was the same belief that people got before.
It's different though because you experience the flatness.
I cannot be sure what exactly I'm feeling or experience right now.
Well, you can be sure that you're not experiencing the ground spinning, right?
And if I turn around really fast?
Then that would be you turning around really fast on a ground that isn't turning around. Like when you go outside, you're chilling, you sit in a park, you're sitting down. It doesn't seem like the ground is moving, does it?
No.
Yeah, so you know that. You at least know that. So that's something you can hold on to, even if you're confused like Danny. Yeah, and if you're in the car, you can tell if the car's moving. There you go. So even if you're confused like Danny and you don't know you're on Discord, you can at least know when you go outside that you don't experience the ground to be spinning or moving.
I can know that I'm a white male. I'm in America. I'm breathing. I'm generally happy most of the time. I know what job I go to every day. There's a lot of things I know and there's a lot of things that you know in your own personal life. You know these things, like Cyclone's saying.
Yeah, you should hold on to these things that you know to be true. And then if someone comes along and tells you, hey, that thing that you know to be true is not true, you need to say, give me proof. Give me good proof. And if they just give you images and videos that you don't know are real, that's not good proof. You understand, Sweet Chili?
Yes.
Do you think anyone's ever measured these things? So you say, okay, we can't experience
Actually,
the motion.
yes. But,
okay.
Through the history,
right?
The ancients.
The ancients. Well, the ancients were all flat earthers, but
they thought there was sort of flat earth because they couldn't believe with their eyes that far
so how
away
did they
from
measure
the
it
sea.
then? How can you say they measured the globe if they were all flat earthers?
Yeah.
Which one of them measured the globe?
That time, nobody.
Okay, has anyone ever measured a globe?
We don't have the capacity yet. And it's true that we cannot believe everything that we got, but we hope that with technology we can appreciate what actually...
I mean, we've got a lot of good technology now. We've got like high-powered telescopes and cameras and lasers. We should be able to measure it if it's a globe.
Yeah, they help us to get some point of what exactly the reality could be.
Right.
And
so
yes, I cannot believe 100% what the government is actually telling me because I'm not that
good. Correct.
easy to believe. But I cannot also say that I don't believe scientifics. I try to believe the scientists and the ones that try to give us the real information and be neutral.
But none of the scientists have measured a globe. None of the
arguments.
Right, but none of the scientists have measured or proven a globe either.
They discover some, example, how the waves move, or
how the waves move,
or the
that's a good point. That's a good
from
point.
one point to the other point of the Earth, and how they think it was something with the Earth, the stations or the movement, depending on the seasons, they go with it. And they know exactly how they have to move through the air in a round way.
Okay.
So I'm trying to say that maybe cannot trust everyone. Scientific experiment either, but the nature is one that
Yes,
could
trust
give us
nature.
some argument.
Trust nature. Yes, that's what we're saying. We are saying, let's look at nature, and we'll go with what nature tells us. And nature tells us that the Earth is flat and motionless. Like bodies of water, think about that, right? Any body of water you've ever seen, from a glass, a cup that you have on your desk, up to a big lake, that water is flat. Right?
I hate niggers.
Wow. Very interesting. Sweet chili, water is a good proof because bodies of water are flat. Right?
The sea, the ocean, not my glass of water, because I know moving
It's the same substance. It's water. That's what water does. So you put it in your cup and you look at the surface of it.
It's a limited water, kind of water.
Well, no, but water always does the same thing. You put it in a container, it takes the shape of the container, and the surface, if you're not moving the water around, will be flat. Right? From a cup, then you go up to a bathtub, and then a swimming pool, then a pond, then a lake. It's all the same. It's water. And it lies flat and level. That's why they use water as a reference for level, for building. And this has been done throughout all of human history. That's how they establish horizontal level, using water. Yeah?
What about the shadows? When the sun is moving, and depending on the day, I think it was a documentary about, and the people, I think, was Greece.
Yeah, that was done
they
on
were talking about that. The
yeah.
shadows.
His name was Eratosthenes. Eratosthenes is what they tell you, and
that one.
That he assumed that the Earth was a ball, but actually he did that on a flat Earth, and the Chinese did the same thing, and they understood that it was a flat Earth, so they did the same calculation basically, but they assumed a different calculation because they didn't assume that the surface was a ball, but they did the same test with shadows, and they got they're looking to get a distance to the sun instead of curvature or size of a ball Earth. So he didn't measure a ball Earth. He just measured shadow angles from the sun, and he assumed the Earth was a ball. But you could do the same thing, assuming that it's flat.
Mm-hmm.
Which is what's actually happening.
Topic. Yeah, it could be either way.
Yeah.
And
so it's interesting. They try and tell us.
Yeah,
they try and tell us that proves that the Earth is a ball, but it doesn't. Why are they telling us that?
Cannot say that it doesn't.
Well, it doesn't because there's two possibilities.
Who has enough arguments to tell us that it's the opposite, that the Earth is flat, when we are not sure?
We do.
With pictures?
No, with measurement.
Measure. Well, who did these measures?
Thousands of people. Tens of thousands.
Of people. It's now the majority who has the right to
we're the ones.
Right.
We're the ones. Well, no, because you can do it yourself. You can measure it.
How?
Long distance observations, laser test. You test line of sight. Do you know what I mean when I say line of sight? Like how far you can see across the surface. So, according to the globe, there should be a limit to how far we can see because of the curvature, yeah? You understand that?
What was the result?
So, if you're let's say you're on a basketball and you're an ant, there's only so much of the surface you can see because the surface is curving down and away from you.
So I must believe what my imperfect eyes can see.
Well, your eyes can see further than the globe model says you should be able to see. Yeah. You want to see an example of a laser test where someone uses a laser to test how far the laser can be shot?
Okay, why not?
Okay, it's in the chat.
Let's see.
This is 28. It says 28.6 mile laser test. So this is people are basically going on lakes and big bodies of water, and they're saying, right, according to the globe model, at 10 miles there should be 66 feet of drop from point A to point B over the lake. At 20 miles there should be 266 feet of drop. That's like a skyscraper. At 30 miles you're talking 600 feet of curvature drop, right? So if you shine a laser across that lake, you shouldn't be able to hit a target on the other side because it's supposed to drop away like 600 feet. Yeah? But when people go to the lake and they shoot the laser, they're able to hit targets at the other side. Which isn't possible if there's supposed to be a curve in the way, blocking the target. You see? So this is testing line of sight. You understand that principle, Sweet Chili?
Yeah, but as I said, if I rely on everything on a laser test with
I'm not saying you have to. I'm not saying you have to just believe this. I'm just giving you an example so that you can think about how this can be tested, and then you could maybe go out wherever you live and say, well, I know that there's a big lake near me that's 10 miles wide. I'm going to take my binoculars or my camera and I'm going to see if I can see something on the other side, or just test how far you can see in general. And then you can compare it to the globe math that's supposed to limit your vision. Yeah?
Yeah.
You can test it in reality. That's what we recommend. This is how we know the Earth is not a ball like they've told us. We see too far. We shoot lasers too far. All kinds of things. The water isn't curving. It's flat, just like we observed.
But it also depends on how long the lake is.
Yes.
Short lake, I could say, hey, I can see the end of the lake, or maybe
you have to know the distance. Yeah, you have to know the
could be
distance you're
from the
looking.
other side, and I'm from the other side,
Yes.
and then we see each other, and then haha.
Yes, you have to know the distance. You have to know the distance that you're looking. And then you use the globe model. Then you use the globe model and you figure out the geometry. So over 10 miles, I said, there's 66 feet of drop. Right? So if you were on one side of a 10-mile lake and your friend was on another side of that 10-mile lake, your friend is supposed to be hidden by about 60 feet of curved water. So you shouldn't be able to see him. Right?
Interesting. I would like to get some laser experiments also by in the ocean.
Yeah, I mean, people have done all kinds of tests, and listen, I'm going to send you a link to a place where we have loads of different examples of this. Okay, it doesn't let me send you the link. See if you scroll up.
It's also funny, like examples, we got examples from the other part of the ideology, I will say. And as we just spoke, we cannot be sure of everything 100%. So you gave me examples, I understand that, but I cannot. I taste it on my own.
Yes, you have to use your brain. I'm not saying just believe me. I'm not saying just to believe what we're saying. I'm saying don't believe other people. Understand and find out for yourself. That's what I'm saying. But what I'm trying to show you is examples of what other people have done so that they can find out for themselves, and that might help you understand how you can find out for yourself. Yeah? So, I'm trying to send you the link. It's discord.gg/flatearth. If you go up to the YouTube bot at the top of this chat that says 24/7 live, you see that? One of the accounts in the channel. So if you scroll down to the About Me, the fourth link down, it says discord.gg/flatearth. Do you see that?
Yes.
Right, join that server. And then when you're in the main page, I'll tell you where the information is. If you scroll down about 3/4 down the channels, there's loads of channels. There's terabytes. We've got PDFs, articles, academic papers, documentaries, all kinds of information. But if you scroll about 3/4 of the way down, you'll see additional information, and it's all alphabetized A to Z under different topics. So you've got things like Antarctica, astronauts, beginners references, NASA, eclipses. Do you see all those channels? Now, if you look under letter L, you'll see laser tests and long distance observations. Do you see those two channels? You see all the alphabetized topics? Like nearly towards the bottom of the server channels.
Lost it.
Do you see them? Or did you join the server?
I just click on something different and I'm not sure where I am.
I'm gonna ping you in the lobby. Hold on, Sweet Chili was your name, wasn't it? Is that your name on here? How's that? It's not showing you. Let me see. Sweet Chili. Dun dun dun.
Oh.
All right, you're gonna have to ping me or something, or add me as a friend if you can't find it. Right.
I will try to find.
Well, it's on there anyway. The link that you clicked on, discord.gg/flatearth, got all this information, loads of long distance observations, laser tests, etc. Will demonstrate what we were just talking about. If you're interested.
Okay, I will check it out. But as I said, I cannot be 100% sure of anything as we
But you are sure
argue about. But it's nice to see another point of view, I think.
Absolutely, absolutely. But just to clarify, you are sure that you're on Discord, right?
Yeah, of course. I can say
good.
I'm
That's
sure
good enough.
about that.
Beautiful. That's beautiful. That's all we
Somebody
need.
has to be sure about what
Wow.
actually
You're
he
going to
is
be a flat earther
doing.
in no time with that kind of awareness. We appreciate that.
No worries.
All right. Well, it was nice talking to you, Sweet Chili. Thank you for talking to us.
Thank you. Also, have a nice day.
You too. You too. Beautiful. All right. Who else we got? Beckett. See Beckett at the top. What's up, Beckett? Isaac Wax. Oh, we just dipped. Cool. What's up, Beckett? What brings you by?
Just to chat.
Just to chat. Good stuff.
Yeah.
What do you want to chat about?
I don't know, anything you want.
Okay. Do you believe that the Earth is a globe?
I'm really not interested on geography.
Well, it's not really geography. I suppose it does fall under. I suppose you could include it in geography, but it's more like your worldview, how you think of the Earth that you live on. Do you think it's a big ball that spins? Like when you go
No,
outside.
it's you mean is it like a circle or flat or something like that or what?
No, a sphere. Do you think it's a spinning sphere, the ground, the Earth that you live on?
I don't completely get it.
You don't completely get it. So you've heard of the globe, right?
Global changes?
I
don't.
Like in a classroom, the globe Earth, the ball. What do you know what the Earth is?
Yeah.
Earth. Okay, what shape do you think the Earth is?
Like a circle.
A circle. Like a football?
Yeah, maybe.
Yeah, okay. So that would be a sphere, because a circle would be flat, a flat circle, like a clock.
Maybe it's like also different from. Okay, it's like half. So I don't know how to say it. Well, it's okay.
But you think it's like a football?
Yeah.
Okay, why do you think it's like a football?
Why this topic? I really don't. I really don't know anything.
Okay, so why do you think it's like a football if you don't know anything?
That's because we saw the ball and also the picture in our books. So
the pictures in the books.
Yeah.
Yes.
Exactly. And
Okay.
even like when you are watching a movie, you are seeing this desk or something
Right.
cool.
But
Yeah, even in class.
but it's very easy
Yeah.
to make fake images and videos, isn't it?
Yeah, of course, but also like this is like a mindset put to our mind without notice. That's because like every class we attend, there is a bowl and
Yes,
the
exactly.
teacher.
So that's what
Yeah,
we're asking. That's what we're asking. We're saying, because they told us the same thing, and in the classroom, they showed us the football earth, and they said, you're living on this football earth. But there's no evidence for
exactly.
that. But when we go outside into nature, it doesn't seem like a spinning football earth, does it?
No.
No. And then we say, okay, but it doesn't seem like that. And they say, well, here's a picture. But we don't know that that picture is real. How can we know that?
Yeah, I agree.
Yeah, so we challenged that. We said, okay, well, we don't just want to believe a picture because that could be fake. So we want to know in reality, when you go outside, where's it been measured? Has the curve, the football curve, has that ever been measured? What do you think? Do you think that's ever been measured?
But you don't gonna find the truth because you will not be like on the plan or to see the full earth. I don't know.
Yeah, correct. But what if I told you you don't have to see the full thing to know whether or not it's the ball that they've told us?
Okay,
Do you know how we know that?
How do you gonna know?
Right, because they tell us the size of the football, right? You know, they tell us the size of the earth. Yeah?
Yeah.
And so that means there must be a specific rate of curvature across the surface, right? So it must.
What is the meaning of curvature?
Curvature is like the curve of the football, where the surface. If you were an ant on a basketball, the surface of the basketball would curve down and away from you as it gets further away.
Oh, yeah. I got you. Yep.
Yeah. So they give us a size and they tell us how much it should curve. So over 10 miles, let's say, You know miles or
Okay.
kilometers? So
I
10
don't know
miles.
actually.
10 miles. Do you know how much curvature they say it should drop?
No.
Do you
I
want to
don't know.
guess?
Oh, you
They
can
say
tell me.
they say
Oh
it's
yeah.
over 66 feet.
Okay.
That's quite a lot, right? Do you
Yeah.
know how much that is? That's, I don't know, what, 20 meters? 20 odd meters?
It's
So
really a lot.
so if you went to a lake that was 10 miles wide and you stood on one side and your friend stood on the other side of this 10-mile lake, they're saying your friend should be about 60 feet below a curve of water. So you would never be able to see him.
Yeah.
Yeah? So what people are doing is they're going to these big lakes or salt flats or shorelines, basically anywhere there's a big body of water, because then you don't have to worry about hills and valleys. It's just level. So they go to this lake, they stand on the other side, and they get a telescope or binoculars or a high-powered zoom camera or a laser,
yeah.
and they see if they can see their friend on the other side. And guess what?
What? They see them.
They see them.
Yep.
Yeah. But we shouldn't be able to see them if we're living on the football, they told us.
Ah. Yeah.
You see? You understand?
Yeah. Yeah. Understand now.
So that's it. And you can go and test it.
Yeah, maybe one day.
Maybe one day, Becca. That's all right. Well, I can show you loads of examples of people doing this. They've filmed it, they've recorded it, they've documented it.
Okay.
You see.
You can.
All right. I can't send you the link again. So, right, I've sent you the friend request so that I can send you the link.
Okay.
Let me know when you've accepted.
Okay, I accept it.
Okay. That didn't go through. Let me try again.
Okay.
Okay, there you go. Did you see the link I sent you?
Yeah. Okay.
Okay,
Fine.
join that, and I'll tell you where to look. So you join that server.
Okay.
Okay, now scroll down about 3/4 the whole way down. Go basically right to the bottom.
Show server information?
No,
Or
just
not?
when you're in the main server page, you'll see all these different channels. See all these different channels?
Okay. Oh, okay. I scroll down.
Scroll down, and then you'll see all the different topics, and it's in alphabetical order, A to Z. Yeah, you see things like
Yeah.
Antarctica, curvature, gravity. You see all these channels?
Near to it, like time zones and
Time zone,
graphic.
that's one of them.
Yeah.
Yeah, you see
Okay.
all these. Okay, so look under the letter L for laser. And you will
yeah, laser. Oh,
see, you see laser tests, and then under that, you'll see long distance observations. You see that?
Oh, yeah. I opened it.
Right. Now, these two channels will show you all of these tests, a bunch of them.
Oh,
And this will help you
okay.
understand. Okay?
Thank you. Yeah.
You're welcome. I'm also going to send you a couple of intro videos because it's complicated stuff. But
Yeah.
these videos will be simple, right?
Yeah.
And when you have time, you research in your own time, just whenever, or don't. It's up to you. I'm just saying this is where resources are, and whenever you want, you can come and ask questions here, or you can listen to us on YouTube. We are live on YouTube 24/7. So if you type
Oh,
into
wow.
YouTube, 24/7 Flat Earth Discord, you will find our streams. Okay?
Okay. Okay. I will do it.
Yeah, you should do that. It's a good time. And if you've got questions, you can let us know, yeah?
Of course. Of course, I'll do.
Okay, beautiful. You've been amazing. Thank you, Beckett. You're a gem.
Welcome.
All right, there's some videos for you. Watch in your own time. Enjoy. Welcome to Flat Earth.
Okay, I'll do it. Thank you.
Okay, peace. All right, guys, that's a good end to my shift. Who's up? Who's going to take it? See DJ in the house. What's up, DJ? Plain and Truth. Over Fences. Morvis. What's up, guys? Effie Alaskan. Good stuff. 20 cups. I'm going to go on listen mode. It's been real. Stay flat.
Good stuff, Cyclone. Good to see you, man. Those some good conversations.
Yeah, thank you. You too, bro.
Yeah, have a good one, man.
Hello, guys. Hello, guys.
Hello.
Hello. Sleep, guys. It's 5 a.m. Please, guys, sleep.
Are you guys listening to something? I saw the VC. I thought people were listening to like a podcast or something. But Gorgie's here. Welcome, Gorgie.
Hello.
I have a trouble with Pinterest. I see things I like there, but they don't want me to save the pictures. You're telling me they let you save the images? You must be more special than me.
Yeah, you have to use it. It's really nice.
Okay. Yeah. It's a painting, don't you think? It's a painting?
No.
You think it's a photo?
Yeah.
It's hard to see on Discord, because it's so small.
Yeah. So what are you doing, guys?
Oh, I don't know. I just got here like seconds before you got here. I don't know what they're doing. Maybe somebody else wants to tell us what they're doing.
Yeah.
Usually they're talking about how the earth is flat, how the globe is total fantasy, or, pseudo scientific science fiction construction, how it's a myth, or, a cult religion from the ancient Greeks. That's usually what they're doing. I don't know what they've been doing today. Did you know that?
No, this is the first time to join this.
Great. Wow. So you came on February 1st, 2026, day before Groundhog Day.
Yeah.
Great choice. Yeah. Yeah. So what we do here is we talk about how, like you are born on this world and you run around. At least this is how it was before the zombie apocalypse, military industrial education internet complex took over the brains of the youth of the world. Used to be you were born in the world and there were 3 channels and they never told you it was a globe. So you went outside and you felt like it's pretty flat and stationary out there. And you laid on the ground and you watched cumulus clouds float by. And you thought, seems like we're standing still and the sun's moving across the sky. That's how it used to be, yeah. And then you went to school, and it wasn't in kindergarten. It was probably like, 3rd or 4th grade. They might have first tried to start telling you, yeah, you're wrong. You're wrong. Your personal experience is wrong, and you're actually secretly on a round ball moving at a high rate of speed, despite all evidence to the contrary. And even though you feel like the sun's moving across the sky and the moon's moving across the sky as it appears, and the stars are moving in a fixed pattern, unlike the wandering stars, otherwise known as Mars, Jupiter, Venus, and so on. Actually, you're wrong, and only the great science God in the sky can tell you how it really is. So you better listen to us the rest of your life, and if you don't, you're going to die. Yep. So we kind of reject that. We're kind of like, yeah, let's just accept our actual experience the way we observe and experience it, and let's not be into their science God, pseudoscience God, science fiction fantasy. So, yep, that's why we're here.
Yeah. I'm sorry. I want to say this is the time I have to sleep, and then
that's too bad.
very nice to meet you. And I sent you an ad. We can talk later.
I saw you sent me a friend request. Yeah, it was so nice. Like I only talked to you for like 5 seconds, and you already sent me a friend request. You're so friendly. Yeah, that was cool. I accepted it. Yeah.
Okay, that's really nice. Thank you. Nice to meet you.
You're welcome. Yeah. So as you go to sleep, remember it's okay to accept your personal experience the way true scientists did for centuries, and the way Western civilization was built upon, actually observing nature and accepting reality the way it was. So you're allowed to accept reality the way it presents itself. Just don't forget that. All right, Gorgie? I hope you come back and see us another time. You're welcome anytime.
Thank you so much. Take
You're
care.
welcome.
And good
You too. Bye-bye. Enjoy your horizon.
Nice.
Gorgie's cool. Gorgie wants to be my friend. Yeah, so we'll be buddies forever, I guess. Blank has joined us. Welcome to 24/7 Flat Earth, where we will 24/7 destroy your globe. Would you like to have your globe destroyed today, Blank?
No, it's a dumb argument. I don't care.
Oh, it's dumb. Oh, tell me the number one reason why no globe is dumb.
Yeah, I don't feel like debating you. I'm good.
You don't feel like blank, blank, blank. I'm good. Could you slow down and say that again, please?
Oh, I said I don't feel like debating you. I'm good.
Oh, you don't feel like debating. Okay. Well, I don't feel like debating either. I just asked for your number one reason. I felt like since you know, that no globe is a dumb argument, like I felt like you seemed so confident. I thought you could easily come up with your number one reason why you believe in the globe. I'm not even asking for a debate.
Are you on coke?
What is your number one reason?
Are you on coke?
Oh, blank. The answer to that question is no.
Are you?
I've never tried cocaine. Do you recommend it? You think I should? I've made it this far without trying it. I don't think I will.
Are you like high on caffeine or meth?
I am not. Neither of those things. Thank you for your concern over my health. Oh, somebody muted you. Yeah, it wasn't me. I thought you really cared about me. You're running through all the destructive chemicals I could be on, wondering if I'm on them. Thanks, Blank. Thanks for your concern. Too bad you can't come up with even one reason why you believe in a globe, even though you're sure flat Earth is dumb. So thanks for your proof that the globe is dumb. Flat Earth 1, globe 0. Actually, Flat Earth 2, globe 0, because Horizon Dude didn't have any proof either.
Ladies and gentlemen, we got him.
Oh, yes, Blank. I don't think someone's butthurt. I just think that they were tired of your immature attempt at deflection of providing some kind of proof of your fantasy globe. So even though you began the insults by calling the flat Earth argument dumb, when I asked for even one reason why you believed in the globe, you were unable to provide one and instead accused me of being on 3 different drugs, which if you gave me a blood test, you would find out I was on none of those 3 drugs. And so if your best proof of the globe is your baseless accusations upon the state of my health, then you're a loser. So that's why somebody muted you. Sorry. Do you think we'll have another contestant? I feel like we should at least have a third one. There's Wen Hao and VLTK. You think they have a number one reason? Oh, Blank is telling me now that he's abusing his mod. Yeah, that's right. Yeah, you're so right, Blank. Yeah, you should be able to come in, call us dumb, and then have baseless accusations about us being on various drugs. So, yeah, you're so right. Gosh, I mean, yeah, definitely appeal that one. Yeah, I'm sure they'll be totally on your side. You are so blameless, Blank. Yeah, I'm so sorry for you. I will sit here and play my tiny violin for you all night long. I guess that was a DM he sent me. I don't even know where that is. Oh no, maybe it's in Veganism is Better. I see I have a ping in Veganism is Better. He probably went up there to mess with them. Oh yeah, it's in the Veganism channel. Yeah. She muted me. Yeah. Mm-hmm. That's right, Blank. You tell yourself whatever you need to get through the night. Oh, hi, Andy. We're hoping the third time is a charm and that you'll be able to have an actual conversation. Nope. All right. 3 strikes, they're out. Globe fail once again.
Damn, son, where'd you find this?
Oh, yeah. News update. Blank's muted in the Veganism is Better channel, too. What a surprise. Such a congenial fellow. You can't imagine why the vegans would mute him. I don't know who's doing the soundboard, but you guys are doing a great job. Like, I really appreciate your soundboard antics, even though I know not everyone appreciates the soundboard, but I do.
I'm just playing around with it a little bit. That was me.
Yeah, it's cool. Yeah. I'm not too proficient on it. I think I tried it a couple times. It's kind of fun. Yeah. Yeah.
Yeah, I don't know all the sounds yet, so if you hear something weird, it's just me messing with it.
Nice.
Yeah, I mean, now in 2026, we've discovered that we have sounds on the soundboard that aren't from Fresh and Fit. You know, we also have emojis and stickers that aren't from Fresh and Fit in the Flat Earth. Imagine that. Yeah, so it's cool. Oh, yes, Blank is reporting me. This is so great. Gosh, I haven't had a nemesis in so long. Thanks, Blank. I can't wait to get reported. Maybe they'll actually, like, you know, take action. That would be even more fun. Thanks, Blank. Luckily, everything's recorded, so, you know, I'm open to review at any time. Hope you are too, Blank. Mr. Nice Guy, please tell me you're going to be the one who's going to provide a decent conversation to us tonight. Do you think you're going to be the one? I mean, with a name like Mr. Nice Guy, right? He's got to at least respond to me. Otherwise, you're going to have to change your name to Mr. Rude Guy. Somebody welcomes you into the room. Your name's Mr. Nice Guy, but you just ignore them. Okay. False advertising, Mr. Nice Guy. Oh, I just happened to see there's a new 24/7 Flat Earth podcast. I'll see if I can get the link. "5 hours ago, power does not give up knowledge because knowledge is power." I haven't listened to it yet, but I bet it's great. 22 minutes. Yeah, I think that's true. I mean, only just going by that title, not even hearing the podcast. I mean, I totally agree. It's like knowledge is power. I mean, that's why that's one of the things I've noticed through the years, not just talking to globe believers, but just people in general who believe in narratives without evidence. They get pretty upset when you're confident about your assertions, or your conclusions about the globe being fake or whatever it is. It must be some kind of instinctual thing where they realize, oh, this person isn't backing down, even though everything they say is going against the mainstream narrative and is a thing that I've been told is supposed to indicate that they have a low level of intellect, or they're only flat earthers because of their religion or whatever it is. Like all the myths that they've been told, when they're shattered because they come face to face with a real flat earther, it really upsets them, right? Because knowledge is power, especially when you have conclusively demonstrated to yourself that the globe is an impossibility, that no curvature has ever been measured or demonstrated. And in fact, there's thousands of counterexamples that easily smash the false mathematical conjecture that we live on a sphere with a radius of 3,959 miles, since that, of course, would indicate that the rate of curvature would increase at 8 inches per mile squared, and the horizon would be no further than 1.22 miles times the square root of the observer's height in feet. So once you realize that there's thousands of examples that disprove both of those mathematical conjectures, and especially if you're a person who recognizes that it only takes one counterexample to disprove a mathematical conjecture, a mathematical model, especially when that counterexample has been repeated multiple times or has been demonstrated in multiple locations by thousands of independent observers, and you conclusively have come to the realization that the globe is not only not true, it's a complete mathematical impossibility, in that the Earth is matching your lived experience of being flat and stationary. It does instill a bit of confidence in people who truly understand that, and that really upsets those globe heads, doesn't it? Because their thing is only based on belief, religion, appeal to authority, so on and so forth. And most people wouldn't want to acknowledge their entire worldview is relying on somebody else's claim that can't be substantiated in reality. I mean, I know that was difficult for me to acknowledge. I thought these people who claimed the globe actually had something to back it up. I just assumed that was the case. Like everybody new who comes in here does. They assume that it wouldn't be possible to carry out this fraud. But luckily, we don't have to prove that it was possible for them to carry it out. Once you go out in reality and observe the horizon, observe, the long distance sightings of lighthouses, islands, and so on, you no longer have to just take on faith that the entire educational system is based on a lie, that NASA is based on a lie, so on and so forth. You know it. So, yeah, I totally agree with the title of this podcast, Knowledge is Power. I totally want to listen to it. If I knew how to make this bot thing work, I would play it in here, but I don't. Dee is here. Welcome, Dee. Oh, Indio's here. Maybe you know how to play it. I was just telling them I noticed you had this new podcast and we wanted to listen to it, but I don't know how to play it in here. Do you know, Indio?
Yeah, I know how to play it. I joined because I heard you on YouTube say bot thing, so I had to come in here and rescue the world from you being a boomer. So
Oh my goodness. Yes, I retaliated against you for that comment at some unknown future time, but you will know when it happens.
yeah, I can play it, but I don't know if I can play it with Spotify. Though I can play it another way because I still have the original. So stand by.
Okay, super. We just like the title. I do, anyway. I was just giving you exposition about your title. But I'm going to withdraw all my endorsement because you called me a boomer. And Mar's here. Welcome, Mar.
You're not actually a boomer.
I know you know that, and I know it too. How are you doing, Mar? Welcome to the Flatter channel.
Yes.
What? Oh, Mara's gone. I'm not having luck, Indio. I've struck out like every new person that comes in that I try to talk to. They have either left or gone up in flames. So I don't know. Maybe somebody else should talk to the new people.
DJ spinning hits by request.
Yeah, there's a video of amateur rocket being shot up into space, and you can clearly see a curve, but these guys just always change the subject or ignore it.
That means it will be also on the ground. If you can see
start
from
with
the
the whole
rocket.
Bigfoot, unicorn shtick.
Yeah, that would be the curvature that we're asking for the measurement of that no one has. That
Okay, but you can
curvature.
see it. Like,
Okay, so why can't you measure it?
So, are we trying to disprove flat Earth, or are we trying to prove globe Earth here?
Well, they'd be the same thing.
There's
wouldn't
two
they?
sides.
In order to disprove the flat Earth, you would need to prove a globe because.
Okay, so
flat
where's the
Earth is
where are the globe
observable
tards?
reality.
Are there any globe tards in the call?
Yeah, we're just speaking to a few of them. No, the first guy was cool. What is it, Mansky? He's a big-time globe head. He's been coming here for months and just like sideshow Bob walking on rakes 24/7. But the first guy, who was that? Because he could actually hold a conversation. So we've not got someone from the flat Earth side who can pick this up.
Who's on? TWN? Setu?
Hello.
DJ? Mr. Ross?
I am.
Yo!
I may not be.
Yo, is Indio here? Dre?
What I would say is that if that imagery that Mansky's talking about is indicative of a sphere Earth with a radius of 3,959 miles, and when we go to a 20-mile lake, or we look across a 21-mile body of water, we wouldn't see clear to the other side. There would be a horizon at about 2.7 miles, and a curvature drop of about 260 feet at the other end. But that's not what we find. So sorry, the imagery.
Can we set aside the curvature drop for a bit? Because I'm presenting here a photo of the Earth, and you're saying that it's been manipulated. Is that correct?
I'm saying that if it is indicative of a sphere Earth with a radius of 3,959 miles or a circumference value of around 25,000 miles, then when we go to a large body of water like a lake and look across 21 miles of surface of water, we wouldn't see clear to the other side. There would be a horizon at 2.7 miles and a curvature drop of 260 feet at the other end. But there isn't.
That's just a statement that you made now.
Yes, correct. So any imagery that's presented to you as some kind of evidence or a claim that it is representative of the Earth as viewed from a very far away, and it comes with those values of this Earth's size, its radius, its diameter, its circumference, then when we go to a large body of water like a lake, and we look across 21 miles of surface of the water, we shouldn't see clear to the other side, but we do. So therefore, do what you will with that imagery. Think about it as you will. If you want to just rest your faith on that unverifiable image, that's on you. Right? But meanwhile,
well, you've got to actually explain the steps.
Yeah, sure.
You can't just tell me that because I'm looking at a circle with some kind of radius that this needs to happen.
Right. So if that is the Earth and its surface is curving, then there's geometric consequences, right, to what we will see and what we can measure on the surface here on Earth, right? Meaning there's a curvature rate to it. So roughly 8 inches per mile squared, which means over a distance of about 20 miles, there would be a curvature drop of around 250 feet. Do you understand?
Right.
How much drop
Okay.
is there? How much drop is there?
I'll go to the Earth curve a little bit. Earth curve calculator. We've got, I don't know how to use this in conjunction with the image, whatever.
Because if the Earth doesn't curve as much, that means it would be an even bigger globe.
True. Look, if you're just looking at the image, if it was, for the sake of argument, not touched at all, right? No Photoshop has been altered. They just took it off, like they printed it as soon as it was taken, right? And nothing happened to it. Would that mean we live on a sphere? If the image was true, mind you.
The correct term, I think, is oblate spheroid, but yeah.
Hypothetically,
So the image,
if it was true,
the image
it'd be
has
true.
been, changed.
If the image was true, the Earth would measure accordingly, curved. However, besides doctoring, there's a very simple explanation, and that they used a wide-angle lens which curves horizontal lines. So if you look at the video, early on when they're close to the ground, does the horizon appear curved? If yes, then this is a wide-angle lens.
I don't know. I don't see a video, and I'm not talking about a specific image. There's lots of images of Earth.
Yeah, and we've gone through you're welcome to try to find one. We've gone through thousands of them, and we have hundreds of ones that don't have a wide-angle lens, and they show flat horizons.
Can you show us that?
According to the math, the ISS is too low to the ground to have the Earth curve, and so they need to use wide-angle lenses to make it appear curved.
Can we all agree that you believe that the image is doctored?
No, I didn't say it was doctored. A lens effect does not mean the image is doctored.
What about an image like without a wide-angle lens?
I'm not. You have to show me a specific image for me to claim it's doctored or not. Okay? It doesn't really matter because the surface determines if the Earth is curved or not. And so, if you have an image showing a unicorn in your backyard, and then we go to your backyard and there's no unicorn, I am not obligated to believe in your image. Do you understand?
I can't actually send anything in the chat. I can't send an image.
So you don't understand?
No, I do understand. I'm trying to send an image and I can't.
That may be an issue of just being too new to the server, so you might have to, participate more in chats until you level up, and then they'll grant you that access.
Right. So, do half of you believe that the images are doctored and half of you believe that it's using a wide-angle lens? What is the actual consensus on this? Is there a consensus?
How would there be a consensus on multiple images? Each image is specific to that image. We don't have an imaginary consensus. We're not a cult like the cult you come from. We're not a cult like the cult we left. We're just the people who left your cult, okay? Get it through your brain.
Okay. You can also decide that none of the images are indicative of a globe, that they're either wide-angle lenses or doctored. They're not mutually exclusive. I'll just send DJ the image, whatever.
There's many potential causes for the images. You like us can simply.
This is the most standard image.
Images.
I didn't like.
I understand. I'm just saying any image that contains the globe in it, you can just go test it yourself. Does the reality curve like the image is presenting to you? If it does not, the image is not true, regardless of how it was made.
Right. So, okay. Some images are made with a wide-angle lens, and some are doctored. Can we agree on that at least?
Yeah, sure. NASA admits we have a link here for you from NASA to a graphics designer working for NASA who created the blue marble image. They freely admit that they doctor some images and create some images. Many people believe those images are real images. There are other images they claim are real images, and we simply test the surface. So we don't care what other people claim when they don't have any evidence backing those claims. The evidence comes from reality conforming to your images or not. If reality doesn't conform to the image, then the image clearly isn't true regardless of how you derived it. You could have created it through an AI. Whoa! That doesn't mean it was doctored by a human or using a wide-angle lens. There could be other methods made to create images. what was he called again? Math Powerland, one of the earlier flat earthers. He claimed to have worked for NASA making paintings, very realistic paintings of globes. And he ended up making a comedy routine after he stopped working for NASA and was like, is this a painting or a photograph? And he had globes. And he made fun of this because he was and ended up becoming one of the earlier flat earthers because his paintings were so realistic that people believed they were real pictures of actual globes in outer space. But we're not making claims about the entirety of supposed space pictures. We're testing those claims. The pictures themselves are the claims, and we're testing the claims. Do the claims hold up in reality? And they don't. That's the simple.
I'm not doubting any of that, okay? I'm simply saying, all right, let me put this as cleanly as possible. The images could have been painted, doctored, photoshopped, created pixel by pixel, manually written in a text editor, all right? It doesn't matter. An image as of 2026 has no value whatsoever. It is not proof, all right, alone. But let's say for the sake of argument that an image was not doctored, it was not painted, it's not fake, all right? For the sake of argument, all right? If the image was actually real, taken on a spacecraft outside of Earth, right? If all of those things were true, never mind that you don't believe in them. Just say that they were.
Yeah, I'll
the one I
you,
posted.
if all of those things, if
I haven't finished.
Were true, okay, sorry.
All right, if all of those things were true, and you just take any random image like the one I sent you, right? That would indicate that we're on a sphere, right? But I know you don't believe all of this.
No problem. If we assume all of this is true and we went out into outer space and we saw the Earth as a ball, the Earth would measure as a ball on the surface. It doesn't, so your hypothetical doesn't make any sense.
Right.
Your image doesn't make any sense.
What's wrong with it?
Well, on one half of the ball, you have Africa.
And that's a problem. Why?
Well, on the other side of the ball, you have North and South America, Asia, Europe, Australia, Antarctica, all the oceans and seas surrounding.
So?
That's why it's a problem. Think about it, sir. Use brain.
On the other side, we have too many things. I'm pretty sure if I went on Google Earth and I can get this exact perspective and everything will be fine. Right now.
Well, then you have the same problem with Google Earth.
WebGL is not supported on my browser. That's great.
Senator, this stuff seems to be going in one of your ears and out the other. Good luck to you, dude.
Hello, guys. How are you guys?
You just told me that my image makes no sense. Out of the blue.
How are you, bro?
I'm great.
Yeah, it makes
Where are you
no
from,
sense
guys?
because this is not something.
Where are you from, guys?
Sense. Sorry.
Where are you from?
Real quick, and then I'll okay.
No. Respond to me.
Yes.
Quick.
Yes.
Where are you from?
No. First, I'm responding to him, and then I will respond to you. Don't make me mute you. So it doesn't make any sense because what you experience is a flat non-rotating world. You see the stars and the sun move in the sky, and you experience the world as a locally flat plane. That's how it's described, that's how it's mathematically used, that's how we function and use the world we live in. However, there's this belief that the world curves.
Okay, I paused it because it seems like a couple people, Mizit and Surreal, want to talk in this chat. Is that the case? Or should I just play it?
I mean,
some
we're
more?
kind of working on it right now in the chat. The problem I have is the claiming that the fact you can see buildings in Chicago from Lake Michigan.
You're telling me on a swimming pool in your backyard, you have a deck on one side of your pool and a deck on the other side of your swimming pool, and they're both on this touching the lake at some point. You're telling me one side is higher than the other. That's why you see it.
No. Trying to take something over several hundred or 7,000 miles and then compare it to a 12, 16-foot wide pool is a horrible argument.
How is 53 miles the same as 1,200 miles?
How is 53 miles the same as 20 feet from a swimming pool?
Oh, you can just get real close to the water.
Okay.
Okay, let's just cut through this bullshit. Let's just cut through this bullshit, okay?
Bro, please, someone go to space, man.
Dude, yeah, you first. When you go there, come back and tell us all about it. So it's really simple. There's more than one photograph and video of the Chicago skyline from across Lake Michigan. In fact, Rob Skiba started in Chicago on a boat he chartered and sailed all the way across Lake Michigan, 52 miles, and filmed Chicago the entire time. You realize that from 50 miles away, you should only see the antenna of Willis Tower and nothing else. Dandelion's in here. Dandelion has seen it with her own two eyes. People see it all the time. This isn't a rare event.
I understand that. I live in the state.
Okay, fantastic. You live in Illinois.
No, Michigan.
Lake Michigan
so
is
then-
in Michigan.
Yeah, you
Yeah,
should
but
be
when
asking
you're
yourself.
looking- when you're looking at
You should
Chicago,
be
you're
asking
looking across the lake.
yourself. Yeah, you should be asking yourself, why can I see Chicago across the lake?
So the
much higher
calculator
is
that you guys are
Chicago?
posting
Beyond
pictures
what we
of,
can
I'm
experience,
confused at
and
where
that
you get 3
special
miles
people
for
can
the
go
distance to
outside the
horizon.
globe and
Because that's the
experience it as
horizon
a
distance
globe.
from 6 feet.
Meanwhile, you
You have to use mean sea level to
cannot.
calculate distance to
So
horizon.
you just have to
No,
believe
you
in
don't. It's
the
1.22
You look it
times
up,
the square
bud.
root of the
And then
observer site in feet.
you are
That's what it
enlightened
is.
because you are
How
part
much
of
do you
the
think?
religion of the
How
globe.
much? Say you did the elevation of Everest.
So we don't.
Okay,
we
I
don't
can't hear you
3,900
because somebody else is
we have to go
talking.
out and test
Yeah,
their
hold on. I
claims,
got to pause that
and their
again.
claims
I'll
fall
just stop
flat.
it.
Unintended. I'm kidding. Yeah, I just realized that I was gonna make a different point, but then I fucked it.
Okay.
Yeah, that's how it usually goes anyway. I was going to make a different point, but you guys ruined it with facts.
Yeah. So the curve calculator, the horizon distance, and you can look it up. It's 1.22 miles times the square root of the observer site in feet. Even if you did more than the mean radius, you did Mount Everest. It's just adding 5 miles to 3,500 or 3,959 miles. So you're gonna add 5 miles to it. You think it's gonna change? What do you think it'll change? We can tell you how much it's going to change, because if you take the polar radius and compare it to the claimed equatorial radius, which is a different 11 miles, the difference is in the 100th decimal place. So instead of being 7.98 inches per mile squared, it's something like 7.97 inches per mile squared.
I mean, just doing Google search tells me you have to use the mean sea level to calculate distance to horizon. I don't know how hard that is to just
Okay.
type it in on Google and find the answer that you're looking for.
The distance to the horizon.
You
on the
you had
globe.
3 miles and the distance to horizon. When
I'll
it
give you a
should be-
calculator
it
where you
should
can
be-
change.
It should be.
Listen, look, bro. You can complain. You can complain all you want. I'll give you a calculator where
Nobody's
you can put
complaining.
in any radius
Just
you want.
like usual, right?
I'll give you a calculator that you can put in any radius you desire.
Right here on my screen.
I'm going to give you a calculator where you can put in any
The
radius
same-
you
the
desire.
same
You give us the right
calculator.
number. No, we're going to let you give us the right number. You're going to give us the right number. I'm going to give you the calculator to do it.
To stop talking so that I can talk. How about that?
Yeah,
Listen.
How about you shut the fuck up before I ban you?
Average surface level.
Why are you so angry right now, dude?
Gentlemen,
Let's let one person talk at a time.
Where did you find this one, Noki? This surreal guy?
I know him IRL, so I like.
Why is,
calm down, bro.
why is he so mad right now?
I don't know. Like, I think there's some miscommunication right now, so I think we just all need to relax. Let's
Well, you go pull him aside and tell him to relax and try to figure out why he's so angry at people today.
Because you're
Yeah,
just saying
gentlemen, if I
asshole
may,
stuff and comments
with
to
all
him
due
when
respect.
he's trying to talk.
Oh, grow up.
No,
Joe.
triggering triangle did.
Call me. Bro, relax for a second. Okay. You're asking about the curvature and how that thing is calculated and where it comes from and all this shit. Go in the text chat. 37 minutes past the hour. There's the full derivation for you as to how that value came to be known. If you have any questions about what the fuck that even means, I don't know what your mathematical acumen is like. So I can't prove that you're going to understand it, but check it out. If you have any questions, let us know.
Well, here's
Or
the
if
funny
you
thing.
want to contest it, feel free.
Fucking Lake Michigan is something like 563 miles above mean sea level, or 563 feet. Okay, so take the 3959 and add 563 feet to it. How far do you think? How much do you think that's going to change the horizon distance? A fucking
My
millimeter?
argument for that, what I was trying to figure out is
it's a
how
red
high
herring.
above sea level Chicago is versus if you were standing on the beach in Lake Michigan to look over there.
Chicago's
Because they're not at the
Lake
same
Michigan is something like 563 above sea level. Somewhere in there. It's 500.
Yeah,
it's 500 plus feet above sea level. Why does that matter?
But Chicago isn't on sea level. It's
Chicago's the Chicago. There's a hold on. I'll tell you because I know the numbers, dude. It's called North Shore Boulevard. It's 8 feet above sea level, or not sea level. It's 8 feet above the level of the lake. Sorry.
8 feet.
8 feet above the level of the lake.
Yes, Cleveland is 7 feet above Lake
Did you know
Erie.
that a river runs through Chicago? And if you go to the edge of the river, which I actually did, like, I don't know, 3 weeks ago, the river is only like below the street level from where you're standing. It's only down like 10 feet. And that river is the level of the lake. These are red herring arguments.
So I get what you're
We got
saying
way
is
better
you're
than Chicago
saying-
skyline.
Yeah, dude, you want to do the math? We can walk you through it.
No, I mean 8 feet from the shore. I mean that math kind of speaks for itself.
It's 8
Especially
feet
when you're already
above the
at,
level of the lake.
53 miles.
No, it's 8 feet above the level of the lake.
Yeah, that's what I meant.
Okay, so it's 8 feet
how
higher.
does it- Yeah, what do you mean by it speaks for itself?
It speaks for itself because if I'm in Michigan and I'm standing on the lake and I'm trying to look at buildings that the bottom of them are in Chicago, it's only 8 feet higher up on the other end at the base than what it is at Chicago or than what it is in Michigan.
You
So
gotta
that's
make
why
a
you're saying it's a red
1,400
herring.
feet, dude. 1,400 feet is the problem.
Right? I mean, if it's speaking for itself, it sounds like he knows what it should be. Obviously, he doesn't, but give him the benefit of the doubt, right? What should you expect versus what you get if it's 8 feet difference? And how do you conclusion that, we're off?
I just muted whoever 20K ups is because he doesn't know how to debate just without trying to put little jabs and trigger people.
So here's how it's going to work. Don't mute people in the server, otherwise you're going to get banned. So you're going to unmute him, and you're going to have a nice conversation with us, otherwise you'll go away.
What did he say that was wrong?
What was so triggering? Holy crap!
Okay.
Because
you guys came in triggered. I heard. I saw in chat you guys came in all freaked out.
I nailed him on the mathematics, and that he obviously doesn't know how to count or do math. And that's
okay. So, hey, Mick, do you want to talk to? Do you want to talk to Surreal? Maybe you
Is
can
that who
calm
we
him
were
down.
talking to before?
The one that was freaking out about the horizon distance.
Oh, was that not the guy that just left?
No, that was his buddy.
Oh, okay. Well, yeah, that's what I was kind of thought I was talking to.
No, I'm mute Surreal then. I mean, I'll just plug my ears.
Oh, I'm sorry.
Not from you. Plug in because he was sparking out. I don't want to hear him scream in my ear.
I mean, dude, if anyone's
I'll unmute him, dude. Let's freaking get this show on the road. I'll unmute him. Hello?
Oh, he's unmuted.
You're unmuted.
Yeah. Dude, if you're going to contest the math, I mean, you're more than welcome to. If we made a mistake in our calculations, I'm sure most people here would want to know that. So if you can point that out, yeah, no shit, dude.
Okay, I was
You'd
just
be doing
curious.
a great
I wasn't freaking out about the calculator or anything. I was like, I asked a question and then I got yelled at, and then I got asked another question, and I was in the middle of answering it when I was just constantly interrupted. So I was just confused at like why I was being screamed at when I was just trying to answer a question that I was asked.
All right. Well, I mean, I'm guilty for interrupting. I was trying to get in here a few minutes ago about, like, check the math out. It's right there, like, point to us where we made a mistake,
So upon the research that I did outside of this channel, because I've only been in this for like 7 minutes or so, my research has told me that you need to use mean sea level, not just the elevation of the lake itself, but mean sea level when calculating distance to horizon. When I put in the numbers of the mean sea level of the beach in Michigan, on Lake Michigan, it says distance to horizon should be 19.36 miles, not 3 miles.
Show the calculation. Can you show the calculation? Take a screenshot. Show it.
I'm going to continue talking.
No, you're going to show it. You're going to show it because you're lying your ass off.
So you got to put that
distance.
We've been doing this for over a decade. We know how to calculate this.
This is what I'm talking about, dude. I was in the middle of talking and explaining it.
Because you're lying.
To your feet, you have to add sea level to where you're standing and where Chicago is. So you can't just add it on one side.
Yeah, bro. If you show the math, it would be very helpful because we can see what you did, and maybe point out maybe you got like a unit conversion problem or whatnot. Because that doesn't sound like much sense. It does not correlate with what others have done in here, and many of them have been doing it for a long time.
100 feet off the top of my head is 12 miles. That's a 12-mile distant horizon. 100 feet.
Okay, cool. 100 feet. Now, can I continue, please?
Well, how can it be 19 miles?
I will post the screenshots in just a second. Let me just explain it first, please. All right. So I'm on omnicalculator.com. Distance to horizon calculator, right? Height above average surface level says on Earth, this corresponds to height above sea level, right? The celestial body is Earth because we're on Earth, correct?
Yeah, did you put in a 500-foot observer height?
There is no observer height on the distance to horizon calculator. I'm calculating the distance to horizon number
is determined by how high you are, dude.
The distance to horizon says this corresponds to the height above sea level. I put 250 because that beach on Michigan is 250 feet above sea level, correct?
Homie. Bro.
579.
Yeah, dude, of course you need to put in an observer height because the horizon distance...
So you want me to put 579 instead? Because it gets even bigger then. If I put 579 in, it's 29.466.
I want you to link the calculator. That's what I want you to do because you're using it wrong.
Yeah, listen, he's saying there's an observer height. You have to include the observer height because it's gonna change.
He thinks the observer height is the elevation above sea level. Don't you?
Dude, I just posted the link.
Do you think that? Okay, cool, awesome. Let's see this.
This is the distance to horizon calculator that you have to calculate that to plug it into the Earth curvature calculator, correct?
Height above surface level, that's what it says.
Yeah, and then click the little I next to it.
bro.
Click the little more info button next to it and read what it says right underneath it. On Earth, this corresponds to height above sea level.
Yes.
Yeah.
Yeah.
If you're on the ocean, if you're on the ocean,
put in precious little 579 then. And then do celestial body Earth, and then
Why
it's
would I put in
21.466.
That wouldn't be your height above the surface level.
Because you
579 is not a height above your surface level.
Corresponds to the height above sea level, correct?
And he's doing it wrong, though, dude. That's the height. Hang on. That's the height above sea level of the observer, not of the thing that's out in the horizon, right?
That doesn't say observer on there, so I guess I don't know what you're asking.
So the whole point here in calculating the distance to the horizon is relative to an individual optic, i.e. your eyes or a camera or whatnot. The horizon is the vanishing point, right? The vanishing line or the apparent line where the sky meets the ground, right? So it's relative to a thing that's looking out over the horizon. Right? So the height in question here is of the observer.
And it's what, like 3 miles at 6 foot?
Right. Check it out, right? In that calculator, just to make sure we're actually on par, right? Plug in 6 feet into that slot, right, and see what you get. That'll confirm whether or not we're using it appropriately.
I guess I don't understand why you're using an observer height when it says this directly corresponds to the height above sea level. I mean, it's sea level, right? Mean sea level.
Height above sea level of the observer or of the optic, right? If you're on the beach, right above the fucking, you're right on the beach, right, overlooking the ocean or some shit, right, and you're 6 feet tall. You're 6 feet above sea level.
Right, because I'm at the ocean. I'm at the ocean, right? I'm not.
Yeah, he's claiming it's 500 feet in the air, and that's what the difference is. And you guys keep arguing in a circle. Why don't you just stop him from that already?
But he doesn't seem to. I want to get it right because he's making a critical error here. He's making absolute.
Can I clear something up real quick?
Error. He's making a mind-boggling error that if we don't correct him, we don't put the effort in correcting him, this is going to go nowhere. Unless
Can I clear something up? Can I clear something up real quick? Okay.
Go.
I was discussing with them earlier. They were saying that because the elevation of Chicago and say somewhere like on Michigan are different, that they're going to get they're basically saying that seeing across the water that you have to take into consideration the elevations of each. But I'm explaining them that if you're on the beach of each one and you're looking over water, I don't know how to. I'm trying my best to explain it to him, but I don't.
Yeah.
Maybe you
Look,
can.
I understand
all
that.
this. We know. Look. Talk to fucking PhDs in physics about this shit. We know what the calculation's supposed to be. Okay, there's no doubt that calculator is calculating height of the observer above sea level. If you wanted to calculate a distance from a higher elevation above sea level, you would add it to the radius, whatever that distance is. So it'd be 3,959 miles plus 579 feet. That would be your radius. And then you would calculate from there. So if it's asking for observer height, why isn't it saying, what is the observer height? I'm just very...
implied.
Why is it above the surface?
Bro, because the horizon, dude, the horizon is implied to be again, the apparent line where the sky meets the ground. So that is at a elevation of 0, basically. Right? So you're trying to calculate how far the distance from your particular observation height out into the distance where that line of sight basically hits the ground at height 0. It's implied. Follow?
He's thinking that he's at like a higher, because he's at higher elevation on the beach in Michigan, that he has to incorporate that to the beach in Chicago. I think that's, I don't know how to explain.
We understand what he's doing, but it's just the horizon distance is determined by two things: the size of the ball, okay, and the height of the observer. That's it. Because the horizon is a tangent that just intersects the ball. So I posted two graphics with two different observer heights, and you can see that the horizon at the low observer height moves towards that observer, and at the higher observer height moves away. Okay? But if we change the size of this little ball that's under the circle, the horizon distance is also going to increase if we increase the size of the circle, and it's going to decrease if we make the circle smaller. So all you do to account for the increased elevation is you increase the radius of the Earth by 579 feet, which don't mean a goddamn thing, because it's probably, I would bet it's in 1,000 decimal places or something. We didn't make up these numbers. These are the official globe numbers. We didn't make them up. If you have a problem with them, take them to the people that made them. I think he realized his mistake. He bugged out.
Yeah, he left. I don't, like, they were arguing with me. I was just trying to explain. I'm really bad at explaining stuff, but they're saying that the elevation in Michigan is different from the elevation. This is why in Chicago. This is why they were like, I was trying to use the analogy with them. I was like, well, if you're at one end of a fucking pool and you're looking across water, I said this is why they do it over water. It's why the measurements are like everything's over water. Because if it's a ball, then sure, you shouldn't be able to see through water. But they seem to think that, well, the elevation of Michigan, whatever, is higher or lower or whatever, and you're not taking that into consideration. I was like, well, it's going across water. And you're at the beach. I don't understand. I just couldn't explain to him. I didn't know how to explain it.
No, I mean, I don't know. People like that, I don't know if they're trolling, they're being willfully ignorant or what. Obviously, water that's connected doesn't have different elevations. Right?
No, yeah, but I was trying to explain to them. They're like, oh, well, no, you're higher at one side. And I was like, brother, if you're at the beach on both sides, water's level. So the only, thing that the argument they would have is that, okay, you shouldn't be able to see through however many, 100 feet of fucking water to the other side.
Yeah, it's supposed to be 1,400 feet. Dude, where did you find those two?
No, I know them in real life. So, but I was in our Discord just chilling, just gaming or whatever, and I was telling them about how I've been hanging out in here and learning a lot of stuff, and then we kind of got into the conversation. So I was trying to explain them, the distances and how we shouldn't be able to see that far, and yada yada yada. And so they're like arguing with me.
Coping
over, if you're on one beach to the other side of the beach, they're like, oh, well, you're at two different elevations. And I'm like, buddy, we're at sea level. He's like, yeah, but that's not the same as sea level. I'm like, buddy, you're at water. He's like, well, it's apparent to ocean sea level or something. I don't know. And I was just like, listen, I'm not the best person to explain this because I'm still kind of new in the field. I'm still learning. But I was like, if Indio's in here, he could have a better chance to explain it.
Think about this. So the mean radius of the Earth is 3,959 miles. That's the average of the polar and equatorial radius that they say. Now, if I'm on top of Mount Everest, it's just the radius plus the height of Mount Everest that I do the calculation for.
I mean, they were telling me that, bro, the radius means nothing. You have to take into consideration the circumference. And I'm like, brother,
why?
I don't know. Why.
The radius is the circumference. They're the same thing, man.
I know. Brother, I know. I'm literally trying to explain.
You derive the circumference from the radius and vice versa. Like it's not like it's dumb to even say something. Like they were just fucking mad or something.
Yeah, I don't know why it got heated so fast. I have no idea. He's normally not like that, but I think I don't know. But he probably also doesn't like being wrong. He doesn't also, you know.
It was to stave off embarrassment. We've seen it before. I mean, especially in people your age. I'm an old dude. Okay, so I'm just saying, in people your age, I've seen them in order to stave off. Because for some reason in your generation, it seems like you guys don't think you're allowed to not know something because of the availability of Google. If you say I don't know, it's like some mortal sin. So you guys don't want to be the dumb one. And I'm not talking about you specifically. I'm just talking about your generation, your age. And to stop the confrontation, or they just fucking spurg out. Because if we're doing meta and talking about how they're behaving, we're never going to reveal that they have no idea what you're talking about, what the horizon means, what the distance should be, or any of those things. They just didn't know anything about it, and they tried to cover it up by freaking out.
What happened?
Joe Mama.
Yeah, I mean that was wild. I mean, he was putting in he wasn't putting in observer height. He was putting in the elevation difference or something.
Elevation. He thought the observer height was the elevation.
Yeah, exactly. But that's where I was trying to, because I thought there was a miscommunication. Like, you guys weren't understanding where you got the number from. So that's why I was trying to go back to the analogy of, they were saying, oh, well, the elevation difference is
I understood where he got the number from when he gave me the horizon distance. As soon as he said that, I knew exactly what he did. Because it's so far off.
Right, no, but I'm saying before we even got to that point.
To be fair, he's not the first person to do that. I've seen maybe a handful of others do that. Where they think they just don't, like, I think Dr. Shiba did that. Didn't Dr. Shiba do that shit? When he was talking to Dave Weiss? He's got 3 fucking PhDs. 4 PhDs? 3 PhDs? I don't know. Anyway, the point.
Right, but what I was confused about, what I was trying to explain to him, was like, bro, you're over water. So, it should be like the perfect, if it was a globe, it should be the perfect 8 inches per mile squared. Like, you shouldn't, like, you're on the beach on both sides. You know what I mean? That's just water. It should be curving at the exact rate they say it does.
Yeah, it should be pretty, listen. It's the difference between the curvature of a circle that's 3,959 miles, and the curvature of a circle that's 3,959 miles plus 579 feet. There's no fucking difference. That's why I said I'll give you a curve calculator. You can input the radius. You can put whatever radius you want. So when they do stuff like that, that Invincible, I'll just give you a pro tip. This is a pro tip. When they say you're wrong about the number, say, okay, what's the right number? You calculate it and correct me. Because it's easy to say you're wrong. But can you say what's right? So you say, hey, okay, I concede. I'm absolutely wrong. Give us the correct number. And what you'll find is they don't know the correct number. They don't know how to get it. They don't know anything. It's because your number's correct. And they're just like, you must be wrong. We call it everything a flat earther says is wrong syndrome. That's what those two had.
Right. Well, I'm obviously a bit more humble. I'll admit, when I don't know something or something's intriguing, like I didn't automatically just dismiss something and go into
you're not wrong because you're not wrong in their eyes, Noki, in their eyes, you're not wrong because of what you said. You're wrong because you're a flat earther. That's it. That's your evaluation. You're a flat earther. It must be wrong. That's what they think. There's that much bias.
Right. Well, and am I right? I mean, because I'm literally trying to explain to them, if you're on the beach on both sides across Lake Michigan, like the only curvature, it should be the perfect, obviously because you can't do it on land because you got the hills and, all the flat and mountains and all it could block the view, right?
Still the same horizon distance. The calculation
that's why we do it over water. Yeah, but that's why we do it over water, right? Because there's nothing going to be blocking your views.
Well, I mean, because water is supposed to conform to the shape of a ball because of gravity. And that's the fundamental premise. And that's the fundamental premise of everything said. That you just say, hey, water is supposed to conform to the shape of a ball. So because of gravity. What are they going to say? No? They're going to start arguing you about that? No, they won't. They'll say, yeah, that's right. Okay, so water should be curving. We go to a big lake. There should be curvature on that water because it's conforming into the shape of a ball because of gravity. We should be able to measure that curvature. It's really simple.
Right, but he's arguing. He's saying like, oh well, let's just say Chicago is higher above sea level than Michigan. But I was like, okay, but like, you're at the beach, dude. You're at the sea level. Like, I don't know how to make it clear to you.
No one ever claimed Michigan was on a hill. Okay, no one ever claimed that. If it, like, they would have a point if Michigan was on a hill or it was upslope when you hit the shore, but it's not. Or I mean, I don't mean Michigan. I mean Chicago. If Chicago was on a higher elevation, but it's like 8 feet above sea level, and they could have just looked that up. You know what I mean?
Right,
See,
but
they just came up with something without thinking about it, or just going, "Hey, man, I'm gonna go look up how high is Chicago above sea level." They just didn't bother to look.
Yeah, Noki, don't worry about it, man. You were correct, right? The water is supposed to be conforming to the surface of the sphere, even if it is 500 feet higher than mean sea level. It's peanuts. It's probably, like Indio said, in the thousandths of decimal points difference, which is nothing. You're not even going to get an extra mile, even if you added it on both sides of the Earth, for crying out loud. It's 1,000 feet, okay, but you're still not at another mile. So, you're fine. This topic triggers people so bad they have a hard time even conceptualizing what it is that they're going to argue with you about. He's not conceptualizing what he's talking about in this case. He doesn't even know why they're talking about mean sea level. He's thinking, oh, I got to add that to my observer height. No. So he's confused. He's not thinking about it right.
Right, like sure, like let's just say if you go into Chicago, and let's just say you're 1,000 feet above sea level, or let's just be exaggerative. If you're going down to the water at the beach, and you go to the beach on the other side of the lake, you're going to be at sea level, and the only thing, the water is going to form to the curvature, right? So it'd be a perfect 8 inches per mile squared. So, but they're thinking because one side is just way higher than the other. But I'm like, buddy, we're using the analogy of like at the other end of the pool, of one pool or the other. I'm like, it was just a lot of confusion. I just didn't know how to explain it. I'm like, man, I hope Indio's in here because he can explain it to you guys better than I can.
Like I said, it doesn't take long before this particular topic triggers them to the point where they stop thinking altogether. Like you heard him, he flipped out for a minute. He's like, I was confused. People started yelling, which really wasn't going on. Indio was just saying, okay, give me the size of the ball then. And he lost control because, number one, his ego was a little bruised up. He realized he's not getting it right. Indio was explaining it perfectly, but he wanted to dig his heels in. So at that point, there's really almost no recovery. They're gonna be in an emotional state. They're not going to be in a critical thinking state. They're not going to be humble enough to go, okay, maybe I should listen and see what they're actually telling me. No, I've got this little info button right here. See, I have to add in the elevation above sea level. Okay, fine. Do that, and then we're going to get your observer height above the lake level.
Well, I appreciate you guys for trying. I was trying to explain it to them, but they weren't hearing me. So I was like, well, maybe someone with more experience, like you guys, could better explain to them. But I think they just doubled down, and it just we weren't getting anywhere. We were just spinning tires.
Well, I hope you're still friends in real life. This has a potential sometimes to like make people get weird. You know what I'm saying?
Yeah, well, I mean, they've never even really considered it. It was just something I brought up while we were chilling in court and gaming and stuff. And then it kind of turned in, like, I would say like, some things about how we can see things that over a long distance that we shouldn't see over the curvature, over water. And then they were kind of looking for a reason to dismiss what I was saying. And so when I was explaining, like, you're at sea level on both sides, like I brought up because we live in Michigan, so I brought up how you can see Chicago, whatever, over the long distance, and they're like, "Oh yeah, but there's two different elevations." I'm like, "No, brother. If you're at sea level on both sides, the only thing that should be blocking is the curvature that they say is there." but they weren't receiving what I was saying.
Yep, I know. It just has that effect. I wish I could. We study this phenomena every day, right? And like Indio said, whatever a flat earther says is wrong. But when you mention flat Earth and they didn't know that about you, they have in their mind, the flat Earth disk in space with water falling off of it, and they're like, "There's no way you believe in that." And I'll tell you about a million different reasons why. And now they're in this state of ego, like, "I can't believe you're this stupid. You're not seeing it right. This is how it's supposed to work." It's usually over before it begins.
Yeah, I mean, they're just not like. I'm one of those people, like, if I don't know something, like, I'm all open ears. I want to hear what the argument is, and I want to see the evidence. And then, like, I'm not willing to dismiss something. I'm more willing to hear what other people have to say rather than just believing whatever people in high authorities like NASA or whatever have to say. So, but they don't seem to be that open-minded about it. So.
Yeah, well, that's why you're rare. I think most people are like your homies. You know what I'm saying? Most people are just fluoridated zombies. So if something comes up and it challenges the cult mentality, they flip out.
Yeah, and it just sucks too, because, like, I hate trying to talk with someone, but they're not actually listening. They're just thinking of the next thing they're going to say. They're not actually receiving the information and thinking about it. They're just waiting for you to stop talking so they can put in their whatever 2 cents without even at all hearing what you just said.
Yep. Well, that's like 90% of the conversations we have in this era. It's a bummer. I'm not saying it's good. It just seems to be the way it is. Everybody has to be right.
Well, I appreciate you guys for trying. They're wanting me to go to the court now. They're convinced they're going to prove you guys are wrong. So, I'm going to be entertained by this.
Okay. Later on.
Yeah.
Are they in pain? Are they in pain? Like, are they laying on the floor, curled up in a ball right now?
Oh yeah, bro. I mean, I've gotten multiple texts from both of them and calls, and so they're like, "Come over here, like we'll show you they're wrong or whatever." I'm like, "Okay, bro." Like, they couldn't even grasp what I was trying to say. They, like I said just before, they're not listening to what I'm saying. They're like stuck on one point. Oh, but 2 elevations. I'm like, bro, you're at sea level. You're at the same body of water. They didn't want to hear it. I'm like, okay, listen, we'll go to I'll show you the Flat Earth Discord that I was in, and these guys will better explain it to you than I can because I'm still learning. I still have a lot to learn. I'm gonna try to convince them to to do. We're gonna do some tests. Like I said, we live in Michigan, so there's, or not like we live in Michigan, so there's plenty of lakes we can do the test on. So I'm gonna try to convince them, see if they'll do those, and then see what they come up with.
They probably won't do anything with you because they're afraid they're gonna find out that the Earth is flat. You'll see. Maybe they will.
Well, look, man, make it easy on them. Make it easy on them. Get rid of the idea of Lake Michigan and just show them the Black Swan. That way you don't have to add anything. You're at sea level, so your observer height is whatever it is above the ocean.
Yeah, if we do that, well, it is winter right now, so everything's frozen. So I mean, it would be nice to go to. I think there's some pretty big lakes around where we're at. So I don't know. Well, if I ever do it, I'll definitely post it and get their reaction so I can get the big "I told you so."
Yeah. Well, if they're not willing to come back in here, good luck to you.
Maybe they will. Maybe they will after the test. Maybe, but I got some convincing to do first. Which is all the more reason why they should want to do it, right?
Don't get that out of your head. You don't want to be convincing anybody. They'll convince themselves. It's not your job to convince anybody.
Yeah,
right. If it doesn't sink in for them, they're going to be a glober.
Yeah, right. Well, I mean, that's how a lot of you guys started, right? I mean, you go to disprove flat Earth because you're like, oh, this is dumb. I'm gonna go disprove it, and then so I can move on, and then you end up becoming flat earther, right? So I mean, this would be a good test for them that they can see it firsthand for themselves. So there is no denial. They have to accept it.
You'll be amazed at how they don't have to accept it.
That's right.
Maybe you're right. We'll definitely see.
All you have to do if that happens is stop talking about it.
Alrighty, well, I'm gonna swap over and hear their what they've got to say. But I'll catch you guys later. Maybe another day.
Peace out, man.
Yep, later. Thanks for trying.
You bet.
Hey guys, we got any spinning ball believers on here right now?
We did, and they spun right out of here. They got scared.
Real quick, like I was just talking about doing a test with his friends. Like in 2015, when I went to my lake, I went with a buddy, 8.5 miles, flashed mirrors to each other, saw each other on each beach, whatever. To this day, he claims refraction. He still believes in the globe. He was on the other side of the 8-mile strip.
They see what they want to see. Hey, what lake was it?
Lake Cumberland in southern Kentucky.
Yeah, I've been there. I spent a summer in Somerset building a hotel, but I was living in a little town called Nancy. I don't know if you know where Nancy is, but I'm familiar with Lake Cumberland.
I grew up in this county over from Somerset. I grew up in Laurel County, but anyway.
Okay.
Yeah, but these
So
guys
the stretch that you found,
they'll convince themselves to stay on the globe for whatever reason. I mean, there's nothing you can do.
Yeah. So, how far was the stretch on Lake Cumberland that you found? How far?
8.5 miles. Should have been like 50-some feet of curvature there.
8.5 miles.
Damn, son, where'd you find this?
Who's doing a sandboard? That was funny. Anyway, I looked at it as giving gravity its last chance to show me it could curve water, and it failed miserably. But the other guy claims refraction. So who's crazy?
Yeah. Yep, they see what they want to see.
He literally thinks refraction made him be able to see me on the other side of the lake, standing there on the beach with a mirror. That's crazy, isn't it?
Yeah, well, you know what, Dave? I think that's what he has to tell himself. At the end of the day, he'll never forget what happened.
Yeah, for some folks, the indoctrination just runs a little too deep for whatever reasons, right? I mean, all we can do is share information with people. What they do with it is up to them.
100%.
Well, let's do a quick shout out to anybody listening to me talk right now. You think you live on a spinning ball in the middle of the vacuum of space and nothingness? Come in here and discuss. Ask these guys some questions, have a civil discussion. You may learn a few things. Okay, this has been Dead Air Dave doing what Dead Air Dave does, I guess. Hopefully, you guys will get it. Somebody who wants to come in here and think critically for themselves and actually have an open mind about things, about reality, maybe.
Earth's globe because of reciprocal zenith angles and geodetic surveying. Don't ask me because I'm not a scientist.